Right, so let us come back with the topics which are there in your first chapter. So in the first chapter, what do you have? You have basically in your NCERT. So these are the topics which will be the basic for your NEET and JEE exam also. So you should know the concept. Other than NCERT, you need to practice more and more number of questions. Right, so in your first chapter, you have nature of matter. You need to study about nature of matter, where you will be speaking about solid state, liquid and gaseous state. You will be studying what is the classification of that, how are they classified into elements, compounds like mixtures, heterogeneous, homogeneous, all that. After that, we'll be studying about properties of matter and measurement. We'll be studying both about the SI unit as well as mass and weight. I'll be teaching you that also. Next, we'll be studying about uncertainty in measurement. So most of the numericals are asked from here. In uncertainty in measurement, you'll be studying about scientific notation. In scientific notation, multiplication, division, addition and subtraction, all will be taught to you all. Next, significant figures, again you have the same multiplication, division, addition and subtraction. Apart from this, in dimension analysis, conversion, I'll be teaching you how we'll be converting liter, milliliter, centimeter cube, meter cube, everything, all the conversions I'll be showing there. Next, in 1.5, we'll be studying about laws of chemical combinations. This is a continuation topic of grade 10. Fine. So laws of chemical combination, there will be studying about law of conservation of mass, law of definite proportions, multiple proportions, Gay-Lussac's law, Avogadro's law. So all 1, 2, 3, 4, 5 laws of chemical combination, all the things you need to know. You should know the definition. You should also know an example for that. You should be able to write the definition, not in your own words. It should be according to the definition given in the textbook. After that, in 1.6, we'll be learning about Dalton's atomic theory. So when I have to speak about Dalton's atomic theory, again I said definition is important. The concept related to that is important, theory is important, right? So how can you apply Dalton's theory to different concepts? That also is important, which I'll be dealing with that. After that, in 1.7, I'll be teaching you about atomic and molecular masses. So in atomic and molecular masses, this is a basic question, we'll also be learning how to calculate atomic mass, average atomic mass, as well as molecular mass and formula mass. These are all your grade 10 syllabus, but not a problem. All these concepts will be done. After that, in 1.8, I'll be teaching you about mole concept and molar mass, right? Here molecular mass, here molar mass. I'll be teaching you about that. So according to this, where I require, because mole concept is very important, I'll be doing different numericals based on that mole concept also. Right, so let us come back and see the next topic which are there, the leftover topic which are there in your basic.
Unacademy, the biggest online platform, learning platform in India. Let's crack it. I'm Vani Potepalli, the verified educator for grade 12 students, CBSE, ICSE as well as state board students are with me.
For free students. The upcoming classes are doubt clearing session every Monday and Tuesday. Special classes include tips to learn general organic chemistry, tricks to perform chemistry board practicals, mind maps for organic and inorganic chemistry, and quiz, that too along with the fun facts of grade 11 students. Please join me in the special classes and enjoy the sessions.
These are Unacademy Plus subscription features where you have daily practice sessions, mock tests which are going on, live quizzes which will be going on, subjective test series coming soon. Join us. Unacademy iconic subscription features include personal mentors. You have live doubt clearing sessions. Weekly reports will be sent to the parents. Parent Connect, where the report will be sent to the parent and the educators are in contact with the parents too. A study planner is perfectly planned and all benefits of Plus also will come under iconic.
Vani 10 and Vani Live is my referral code. These are the subscription rates for 11 and 12 Plus iconic subscription. Rates are given. Please check the rates, students. Vani 10 and Vani Live is my referral code again to mention. These are grade 12 subscription for the Plus and grade 12 subscription for the iconic. You can choose for 1 month, 3 months also, because you still have 100 days for the board examination, students. Join me there. Unacademy presents for grade 10 students a very important and beautiful competition. Just check the details. The most challenging battle Unacademy combat to level up your preparations and practice for the CBSE grade 10 board examination, students. It's for both maths and science subjects would be undertaken. Now I'll tell you the timings, the competition, where you stand in the leaderboard all over India. So Unacademy combat, revise, practice and win. Get set to ace the CBSE 10th board examination, students. A chance to assess your progress and take part in a fun challenge. So this revised practice and win, the score, leaderboard, rating and awards. There are a lot to win, students. Let us see the details. Please try to participate in the competition. Let's see with the syllabus. K10 combat format would be 40 minutes experience in your life, 30 super questions, 6 combats, negative scoring, English and Hindi language both are available. Detailed video solutions also would be there after the competition. Combat timelines would be Combat 1, 31st January, subjects are max and science in all the combats. So from Combat 1 till Combat 6, the date is scheduled. We are there with you till your board examinations. So note the start date, students, 31st January till 11th April. All the dates as mentioned, note the date, note the timings, and also note the subjects. Right. So combat syllabus as per NCERT, that's the updated 2021 syllabus. Max syllabus and science syllabus is given here, students. Note the topics and get prepared for the competition. Detailed video solutions by the best educators would be given. So once your competition is done, you will know what are the solutions for the questions asked to. So know how well do you perform for the among the 1,000 learners in India. Live competition, students, participate. So here questions would be given to you that is going to test your understanding of concepts, and how you are going to apply the concepts in the application is going to be tested in this competition. Enroll now in the Unacademy Combat. Use the code Unacademy. So what you need to do, download the app from Google Play Store and you can register today, students. But don't forget to use the referral code Unacademy. And the most exciting. So rank 1 students are going to get 12 months Unacademy CBSE class 11 plus subscription. Wow. And the second prize winner would be getting 6 months of 11th class subscription. Rank 3 students will be getting 6 months Unacademy CBSE grade 11 subscription, and along with that, so plus you would be there in the plus platform enjoying all the features. Rank 4 to 50 will be getting 1 month Unacademy CBSE class 11 plus subscription, students. So look at the prizes. So note, students, Unacademy, the first combat competition is on January 31st, 2021, time 11.
Concepts of chemistry. Right, let us see the next topic which are there in basic concepts of chemistry. Here you have percentage composition calculations. So right, so there are many NEET questions also given based on that, JEE questions also given based on this. We will do all those. So in percentage composition, we'll be learning about empirical formula for molecular formula. So from the molecular formula also, empirical formula both, I'll be relating and show you how to calculate both. Fine. So in stoichiometric and stoichiometric calculations is the last topic of your chapter. There I'll be teaching about limiting reagents, and we'll be doing again we'll be doing numericals based on limiting reagent. How much ever there is a reactant consumed, whether this acts as a limiting reagent or not. Fine. So the last topic I'll be teaching about mass percentage, formula and numericals, mole fraction, molarity, molality and normality. So the percentage composition, everything we'll be learning about weight by weight percentage, volume by volume percentage. So we will be doing that. So this is your whole chapter. So my journey, as I said, is going to start from today till the month of this, if I have to tell you, till your NEET exam, almost till the month of May. I'll be doing it, if not one day, the other day, very next day will be uploaded. So I request you to join with me, we'll work hard together. Fine. So everything we will do, we will try to complete, and I want the grade 11 students also to smile and say confidently, chemistry is the easiest subject on this earth. You should say that word. When you feel chemistry is the easiest subject, you're done. You're the greatest person then. Fine. So thank you so much for watching this video, and I expect you all to join my platform. More number of people, more amount of energy it gives, more amount of videos I'll be uploading, and more amount of friends I get. Once in a lifetime, getting more friends, getting more students, and all your blessings on me. Thank you so much for that. So, welcome back, students. So, I've already given you the introduction for your first chapter of grade 11. That is some basic concepts of chemistry. So, now let's come back and start discussing the topic. Gradually, I'll be going into the depth of the topic. So, initially, the basic explanation which is there in your grade 10, quite common explanation. Right. So whenever we have to speak about the basic concepts of chemistry, we'll be learning, as I've given in the index, we'll be learning about what is matter, we'll be learning about what are the types of matter, we'll be gradually going into the units of them, then we'll be going into significant figures, dimension analysis, calculating the concentration, that is in terms of moles, mole fraction, molarity, normality, equivalent weight, formula weight. Right. So let's come back. So whenever I have to speak about matter, so we very well know it's a grade 6 question. So what is matter? Matter something is like we have studied in grade 6, even in ICSE books we would have studied in grade 4. So what is matter? Matter is something which occupies space, quite common thing. So something which occupies space, that means when it occupies space, that means what does it mean? It has certain amount of volume present in that. Right. So when you are speaking about some substance which is occupying space, that means it is occupying volume. At the same time, it has mass also. Fine. So when it has mass, and obviously when it has mass, you can easily sense with your hands. Your sense organs can feel that. You can feel that mass. When you can even see the shape of that particular mass. So what is matter? Matter is something which occupies mass or occupies space, and it has mass, as it can be also felt by our sense organs. Simple as that. Fine. So when I have to go into the classification of matter, so nobody will ask you what define matter. No. So when I have to go into the classification of matter, matter is basically of 5 types. What is that? It is solid, liquid, gaseous. The first 3 types of matter which are interconvertible, and the next 4th type of matter is called plasma, and the 5th type is called BEC, that is Bose-Einstein condensate. So after learning the definition of matter, let us come back. I'll be doing a small class. I'll be sharing you a small class on plasma and BEC also. So as of now, let us first come back to your concept in grade 11. So now what do? We have learned what is matter. So what is matter? Let us revise again. Matter is something which occupies a space, right? Fine. So when it is occupying space, that means it has mass also. When it has mass, I can easily sense it, I can easily feel it, I can hold it, I can touch this, right? So that is means felt by the sense organs. So that is your matter. So when I have to come back to the types of matter, as I said, solid, liquid, gases. So in solid, liquid, gases, what should you study? You should know the differences first, then I can go into the concept. So these are the important criteria which you should remember for the classification of solids. Fine. So what is this now? When I have to speak of the packing factor. So we have studied in grade 6 what are solids? Solids which have fixed definite shape and definite volume, isn't it? That means what is a packing fraction or packing factor? In a solid, atoms, molecules or ions are tightly packed, isn't it? So in solid, when the packing factor I have to speak, they're very, very, very tightly packed. The spaces between them is very, very less. So what is the packing factor? Packing factor, if I have to say, they're very close. Hence the solid is rigid in nature. Because it is rigid in nature, what does it have? It has definite shape and volume. This is what is important, correct? Yes. Now I have to speak about liquids, the packing factor. How is the packing factor? The atoms in that present, they're very far, this spaced, isn't it? There's a lot of space in the liquid, isn't it? So how is the packing factor? They are far away. I need to speak closer, synonym to that, far away. Right, they're not rigid, isn't it? Solid liquids are not rigid. So when they're not rigid, do they have definite shape? No, I don't have. So you can write no definite shape. Fine. And what about volume? They're going to take the give us, like, they'll have the shape of the container which you take. If you pour it in a glass, they'll have a shape of a glass. If you pour it in a teacup, it will be having the shape of a teacup. If you pour it in the form of in a spoon, that particular thing, it will occupy that space. So it will have the shape of the container, or volume of the container. That is important. So volume of container. That is the thing. Next, when I have to speak about the gases, they are more far away, isn't it? The packing factor, they're more far away, and far away The distance is too much. And when I have to speak about the shape and volume, they don't have definite shape, correct? Gases don't have definite volume also. You can't hold the gas molecules together in a container, closed container. You can compress it. To what extent? Once you release that container, or when you take out that, open the lid of that, it will diffuse and occupy this shape of the room. Again, further it diffuses. So gases more far away, packing factor, no definite shape and volume. Okay, right, both are not there in gases. When I have to speak about the vibration of particles, right? Solids, yes, they vibrate, but what that vibration in solids called jiggling. They jiggle from there only, that point only, they jiggle. Just here, all the solids are there. This will jiggle here, this will jiggle here, but they will not move out of the lattice side unless until there is a space or a void created. So, what will happen in solids? The vibration of the particles is solids. They jiggle. We call it as jiggle, this word. So liquids, obviously they vibrate because the spaces are more, isn't it? So the particles vibrate. When I have to speak about gases, they're more far away. Obviously, the particles, they vibrate more. The intensity of vibration is more in this, isn't it? So let us write vibration is high, more, vibration is high. Fine. So, but here you need to use the word jiggle. Done. Jiggling means moving in their own position. Done. So, compressibility factor. Can I compress solids? No. Solids are not compressible. I can't compress solids. Fine. Liquids, can I compress? Liquids are also not compressible. So when I have to take gases, yes, gases can be compressible, isn't it? We can convert the gases into liquid also by compressing. Fine, yes, they are compressible. You can write compressible means they can, under pressure, you can just compress it, decrease the volume of the particular form of matter. Right. Nature of flow. Do solids flow? Do they flow? They do not flow. Will liquids flow? Yes, that is the main property of liquids, isn't it? Do gases flow? Yes, they flow. So according to the nature of flow, solids do not flow. When I have to speak about the liquids, yes, they flow of particles is observed. Yes, flow of particles is observed. Why? Why is it observed? Because the spaces are more. You can write the reason also. Here, gases flow. Yes, flow of particles is higher. Is higher than liquids. Fine. When I have to speak of the melting point and boiling point. So when do we use melting point? I have to use melting point concept in solids and liquids. I can't use melting point in gases, isn't it? There your concept of boiling point comes into picture. So when I have to speak about solids, speak about the melting point, boiling point. Where will I use this melting point? I'll use the word melting point for solids as well as liquids. But gaseous state you can't use melting point. You need to use the term boiling point, isn't it? That is where, because the diffusion is very high, the molecules start evaporating into the atmosphere, right? So when I have to speak about melting point, solids, the melting point is above room temperature, isn't it? Yes, above room temperature. Fine. Next, when I have to speak about liquids, melting point is below room temperature. Below room temperature. Fine. So now, if I have to speak about gaseous, you need to speak about boiling point. As I said, boiling point is much below the room temperature. Is much below room temperature, isn't it? Yes, this is what. So these are the important differences of solids, liquids and gases. What are the factors, criteria? Try to make it, if they ask you, try to make the separate properties here so that you will get full marks in this. Packing factor, vibration of particles, compressibility factor, nature of flow, and melting and boiling point. So now let's come back and see the next classification. We have studied the types of matter, that is solid, liquid, gases, plasma and Bose-Einstein condensate. I said I'll be doing a video on plasma and Bose-Einstein condensate, a small story about that. Fine. So when I have to speak about the classification of matter, basically a matter, what did I say? What is matter? Matter is something which has mass and occupies space. Let us write that. So matter has mass and occupies space. Okay, this is quite simple. So when I have to classify matter, matter is divided into pure substances. Okay, all these are basic concepts. Then they are divided into mixtures. So when I have to speak about pure substance, what is the important thing about pure substance? Pure substance has fixed composition. This is the first important word you need to write. Fixed. That particular thing. If I speak about the purest form of hydrogen, H2, that is an elemental form, it's pure in nature. It has a fixed composition of hydrogen, fixed composition of chlorine, fixed composition of oxygen, fixed composition of nitrogen. I'm not speaking any other combination. It's a purest form. So fixed composition. Here when I have to speak about mixtures, it is a combination of two, like HCl, hydrochloric acid, H2SO4. It is a combination of hydrogen and sulfate ion, H3BO3. It's a combination of H plus, like boric acid rather, H plus and HBO3 minus. If I have to speak about nitric acid, H plus and nitrate ion. Like that, it is a combination of two particular, or even if I have to say in HNO3, three are there, isn't it? Hydrogen, nitrogen and oxygen. It's a mixture. So mixtures have variable composition. Remember this. This is fixed and this is variable composition. Now, next important factor about pure substance is, when I have to take a pure substance, as I said, it is a pure form of that. Fine, can I change further into every substance is a particular identity. Can I change the identity or not? Remember, can you completely change, or can you just, like by using physical method, can you change its identity? That is the concept which you should speak. So fixed composition, you said. You can also say can change, can changes be made, can change in identity and properties. That identity and properties can be changed by physical method, right? Completely property lost, no, a slight change in the identity and property. But when it comes to mixtures, they resist the change. They cannot change. Fine, identity and property will not be changed by physical method. Fine. So when I have to speak about the next property, most important, pure substance, I said hydrogen, chlorine, bromine, iodine. Can I further break them into simpler substances? Important. They cannot be, this is can, this is cannot be further dissociated, further broken. Fine. So mixtures, I can break them in, isn't it? I can dissociate them into HCl. I can break them into H plus and Cl minus ion, HNO3. I can break them into H plus and 2H plus and NO3 minus 2. Okay. If I take nitrate, H plus plus NO3 minus. I can break them into pure substances. So what can you write? They can be dissociated into pure substances. Simple, right? So what about the next important thing, the most last but not the least, what will be the properties? Properties are fixed, isn't it? For particular element, properties are fixed. Here both will have different property. If I take HCl, hydrogen will have one property, HCl will have one property. So properties are variable. Both will have different properties, isn't it? So when I have to speak about your further classification of pure substance, so pure substance again classified into elements and compounds. So again, your mixture is classified into homogeneous mixture and heterogeneous mixture. So homogeneous mixture, heterogeneous mixture. Okay. When I have to speak about elements, nothing simple. Just now I said it is just like this only. Hydrogen, chlorine, bromine, iodine, all are single entities. So what is element? It is the purest form of a substance. It can't be further dissociated anymore. Fine. So element is a purest form of a substance. Right, fine. So when I have to speak about compound is a combination of two or more. I said compound, HCl is a compound, combination of two, a cation and anion. H2CO3, combination of hydrogen, carbon, oxygen. It is a combination of all these atoms. So a compound is what? It is a mixture of elements. In which proportion? Definite proportion. That is important. Mixture of elements in definite proportion. Fine. So examples are given here, right? So further, will they retain the properties? They will not retain. When you heat or use in physical methods, they will retain. They will not retain the properties. The properties will change, isn't it? Yes. Now when I come back to homogeneous mixture, homogeneous means homo means similar. Everywhere the composition is similar to the particular thing. For example, if I take sand particles, only sand. What is that? It is only sand particles are present in that. It is homogeneous. It is all over same. If I take brass, the composition is same. It is the same brass metal all over. Alloy is a combination of that alloy. It's the same everywhere, right? If I have to take, means it is a same thing. If I have to take one composition only, so example, if I say what should I write? Homo means same composition. Correct. Which has elements having same composition. Rather, full sentence if I have tried. Heterogeneous, elements with different composition. Okay, what does that mean? As I said, if I take sand, only sand particles, right? If I have to take wheat grains, only wheat grains, I'm going to talk about wheat grains. It's a quite common composition all over. If I have to speak about this one, like brass, same composition all over. If I have to speak about bronze, it is the same composition all over. Fine. That is homogeneous, having elements having same composition. If I have to speak about heterogeneous, here two different combination, right? Salt and water. Salt and water is a heterogeneous composition. Sand and water, heterogeneous composition. Milk and sugar, heterogeneous composition, right? Yeah, your tea powder and your milk, heterogeneous. All these are called heterogeneous, having different composition. So basically this is a classification of your matter. Quite simple, nothing much, just once one reading will be over. You can memorize that, keep noting in your books. Right, now let's come back and see the differences between compound and mixture. Till now we have studied definition of matter. Then we have studied what are the types of matter, that is solid, liquid, gas, plasma and BAC. Then gradually I came into a topic that is classification of matter. They again divided into, as I showed you, pure substances and mixtures. Pure substances again divided into elements and compounds. Mixtures are again divided into homogeneous and heterogeneous. Now let us come back to this difference. So basically when I have to speak about compound, first let us take an example and then it's easy for us to do the differences. So compound, if I take the simplest one, water, the basic compound water. It is a combination of hydrogen and oxygen. Fine. So two elements combined together to form a compound. When I have to speak about mixture, as I said, it can be homogeneous or heterogeneous. Let me take heterogeneous mixture, sand and water. Okay, sand and water, simple. Or salt and water, sugar and water, not a problem. When I have to speak about the properties of these, now I'm going to differentiate. So ratio of the constituents. So when I have to take water, it's a fixed ratio. 2:1 ratio. It's fixed. You can't write simple as you wish. You can't write the formula for water, isn't it? So what is the ratio of constituents? These are the constituent particles. Hydrogen is a constituent particle. Oxygen is a constituent particle. Here, sand and water are constituents. So when I have to speak about the ratio of constituents, okay, before that, let me tell you something. Compounds are again classified. What are they? They're classified into organic compound and inorganic compound. Organic compound, inorganic compound. As I told you earlier, mixtures are classified into heterogeneous mixtures and homogeneous mixtures. Hetero and homo. What is this? Okay, I already told the differences between these. So what are organic compounds? Organic compounds are those which have carbon. They should have carbon in their compound. Compulsory. What are carbon compounds? Almost in nature, everything is made up of carbon, isn't it? So the best example are biomolecules, the proteins. Proteins have carbon in them. Carbohydrates, carbon in them. So the compounds which have carbons are called, carbon in the formula are called organic compounds. You need to have carbon in that. So you'll be using organic compounds, mostly like everything rather, if I have to say, organic chemistry, the whole, everything is of organic compounds only. The one which do not have carbon in the formula are called inorganic compounds. So what is inorganic compound? Simple example, right? HCl, right? It is inorganic, isn't it? It doesn't have carbon. Sulfuric acid doesn't have carbon. If I have to to speak about this one, what do you say? Any compound, nitric acid doesn't have carbon, sodium chloride doesn't have carbon. So the compounds which do not have carbon in them are called inorganic compounds. Fine. So when I have to speak about the ratio, when you see 2:1 ratio, so the ratio of a compound, the ratio of elements of the compound is fixed. They have fixed ratio. Fine. So if I have to speak about the ratio of compounds in this, sand and water, there's no fixed ratio. You take sand, you mix it in water, dissolve, it will not dissolve it. For dissolve, sugar and water, it will mix till you become the saturated solution. You keep dissolving, it will dissolve. That means it may or may not have fixed ratio. May or may not have fixed ratio. May not have fixed ratio unless until you measure and take it. Fixed ratio, right? Done. When I have to speak about the nature, the homogeneous, isn't it? Water, if I have to say, it is the same composition all over. So they are homogeneous in nature. So when I have to speak about mixture, they may or may not be homogeneous. It may be heterogeneous also, as I said. So may or may not be homogeneous. Fine, done. So next one, when I have to speak about the separation. So simply, if I take water, I have a glass of water with me. If somebody comes and asks me, you are sitting in your classroom, you have water in your water bottle. Somebody comes and asks you, separate water and hydrogen and oxygen and give it to me. Can you do that? No, you can only do it by electrolysis method. That means you can only do it by chemical methods. So what can you do? Separation, it can be separated only by chemical methods. Only chemically I can separate them. I can't do it physically. Just take water, hold your hands, pull it apart, you'll get hydrogen, oxygen. Not possible, isn't it? So only chemically I can separate compounds. So when I have to speak about sand in water or sugar in water, I can easily do. Suppose if I have sugar in water, if I use the crystallization process, say sugar particles will settle on top and water is there, both can be separated, isn't it? Fine. So what is this method? Is it chemical? No, it is a physical method or mechanical method. So you can write can be separated by physical methods. Physical or mechanical methods, you can write physical methods, right? When I have to speak about the formation of this, how is this formed? Basically, both in a compound, both the elements which are formed, they're formed in fixed ratio. It is almost like that only. How is this formed? It's formed mostly, if I have to speak, it is formed in fixed ratio or definite ratio. So how is this basically in nature formed? Hydrogen and oxygen, it is due to chemical combination methods only. So almost both the concepts all together we are going to write it here. Right. So as I said, it is a combination. Let us write. So formation, how? It can be formed by a chemical method. Then during this process, I am writing the same. Formed by chemical method, right? And when this is formed by chemical method, what is happening? Either there's absorption or evolution of what? Heat may be evolved in some reactions, light may be evolved in some reactions, current may be evolved in some reactions, electric, that amount of H nu will be evolved in some reactions, isn't it? So for heat or formed by chemical methods, either by evolution or absorption of what? What did I say? You will represent on the top of the reaction, isn't it? On the arrow you write. It may be in the form of heat. It may be in the form of light. It may be in the form of electrical energy also. Electrical energy. Fine. Now, when I have to speak about here, let us write chemical, instead of chemical methods, let us write mechanical methods. So what will happen? I can write physical here. Mechanical methods, right? Just separation. With your this one, you can take, suppose if I have to separate sand and water, I can just take a filter or something, separate, pour sand on that, pour sand and water. Sand will settle on the surface of the filter and water is collected in the beaker. So it's mechanically you're doing it, isn't it? So it can be separated by mechanical method. So here you can write formed by physical method. And is there any evolution when you're separating sand and water, when you're separating sugar and water by crystallization? Is there an evolution of heat, light? Nothing, isn't it? So no evolution of heat, okay, light, H nu, and electrical energy. We see me electrical energy. electrical energy. I'm writing in shortcuts, right? When I have to speak of the melting and boiling points in compounds, the melting and boiling point are very sharp. Water has sharp, everything has sharp. They will melt only at that temperature, not above that or below that, right? So at that particular boiling temperatures are melting and BP are sharp. So here, is there anything very sharp? Nothing, isn't it? They vary. So you can write MP/BP may vary. That's it. So these are the differences between compounds and mixtures. Now using this data, let us solve some questions based on compounds and mixtures. Right, let us come back and do this question, which is based on your elements, compounds, mixtures, as well as again classification of mixtures. So basically, whenever you learn a topic, unless until you apply the concept in the question, the topic will not be clear to you all. So remember, whichever topic is taught to you, try to do more number of questions on that. So then only you'll be knowing, okay, this is how I have studied, this is how I need to apply. In the exam, nobody will ask you what is a mixture, what is a compound, what is heterogeneous mixture. They will ask you to apply the concept which you have studied, right? So here what do they give us? Classify the following into elements, mixtures, compounds, and indicate if the mixture is homogeneous or heterogeneous. So we very well know we have divided mixtures into homo and hetero. We have divided again your pure substances into elements and compounds, right? So now what should I do? I need to find out whether the given examples are they elements, are they mixtures or compounds, right? Three things I need to just see. These three, fine. So what are elements? The purest form of the particular substance. Mixtures, they may be homogeneous. It may or may be homogeneous. It may be same. It may be different also, like hetero. Compounds, as I said, two elements combined together to form compounds. Let's see. When I have to see smoke, smoke basically is a combination of different gases, isn't it? So what will it be? It will compulsory be a mixture. MIX, okay, I'll write mixture. M stands for mixture, right? So when I have to speak about brass, brass is a combination of copper and zinc, right? So what should I write again? Brass is again a combination of copper and zinc, means it is again a mixture, isn't it? Yes, it's a combination of copper and zinc. So again, this is a mixture. Now when I have to see dry ice we very well know. So it is basically a compound, isn't it? So it is a compound. NaCl, again it is a combination of two pure elements. It is a compound. Distilled water, H2O, it is a combination of hydrogen and oxygen. It is a compound. Fine. Mercury, mercury is the purest form. It is an elemental form, that is Hg. So purest form is nothing but element, capital E. Sucrose, sucrose is a combination of glucose and fructose. So what is it coming in the category? It's coming under category compound because it is a combination of two elements. Aerated drinks, your soft drinks, again they have compressed carbon dioxide present in that. So it is a mixture also, mixture. Fine. Now they've asked, so I've divided according to them, elements I've divided into mixtures, I've divided into compounds. Now they said classify or indicate the mixtures into homo and hetero. So homo means having the same phase throughout, same composition throughout. Hetero means different compositions. So when I have to speak, here I have a mixture, here I have a mixture, here I have a mixture. Now see this particular thing, as I said, smoke, it is a combination of different gases. So is the composition same all over? No, isn't it? So this is a heterogeneous mixture. So brass has the same composition. You have the same ratio of copper and zinc. So brass is a homogeneous mixture. Next, aerated drinks, again the same composition. Unless until you mix up in the same composition, the same even composition, you will not get that intensity or you will not get the tanginess in that particular soft drink. So aerated drinks are again homogeneous. So this is how you are going to classify. So simple concept, remember what is an element, remember what is a mixture, remember what is a compound, and divide them accordingly. Right, now let us come back and do the next type of question. What is this? Here they've given us gunpowder is a mixture of sulfur, charcoal and potassium nitrate. How would you separate it into its constituents? So basically, till now I have not studied anything. I have only studied about elements, mixtures, or like pure substances, mixtures, elements, compounds, heterogeneous, homogeneous. But now, basically, let us go into a next level of understanding. So whenever some certain mixture is given to you, you should know about the solubility of them. So if you know the solubility, I can easily say, okay, this is soluble in this is soluble in that, and I can separate out. So they given us what? Gunpowder is a mixture of sulfur, charcoal and potassium nitrate. But basically we have both the types of solvents, isn't it? Polar solvents and non-polar solvents. So let me divide. So first one is your polar solvent. Next one is your non-polar solvent. So what is a polar solvent? It's nothing universal solvent, that is nothing but water. Non-polar solvent is carbon disulfide, which is a linear molecule. Fine. So next, when I have to start, sulfur. Sulfur is soluble in water or carbon disulfide. Sulfur is always soluble in non-polar solvent. So ruled out, I have separated. Next comes charcoal. Charcoal is neither soluble in water nor soluble in non-polar solvent, both. So what are you going to, you will get charcoal separately. Why? Because it is neither soluble in water, polar solvent, it is neither soluble in non-polar solvent. The leftover is KNO3. KNO3, because it is an ionic compound, it dissolves in, KNO3 dissolves in a polar solvent. Now all three are separated, isn't it? So this is how you are going to reason a question. Fine. Let us see this question. Here what do they give me? This is an NCERT exemplar question. It is there in the exemplar book. Right. Which of the following statements about a compound is incorrect? So I should see which is the incorrect statement for a compound. So we already studied the differences between compounds and mixtures. I already know the properties of compounds. Let's see. A molecule of compound has atoms of different element. Fine. Compound has atoms of different elements, a correct statement, nothing incorrect in that, so ruled out. A compound cannot be separated into its constituent elements by physical methods of separation. Okay, that is also true. I have already given the differences. I can separate them further by physical methods. Next, I said a compound retains physical properties of its constituent elements. Wrong, isn't it? So it will not retain, it may change. Suppose if I take iron sulfide, if I heat it, it will change, isn't it? The complete structure of iron and sulfur will change and you can't revert back the condition. So this is a incorrect statement of this. Last one, the ratio of atoms of different elements in a compound is fixed, isn't it? Compound water molecule, remember this water molecule. If you remember this, you can relate. Water molecule, the ratio is 2:1, it is fixed. So the incorrect statement is it will retain this set, it will not retain its property once you start heating it. For example, one of the physical method, you heat it. So this is how you're going to reason the question. Let's come back and see one more question. Right, let us see this question. What does this question say? Which of the following is a homogeneous mixture? So what actually is a homogeneous mixture? As I said, which has the same composition throughout. Brass, same composition. Sand, same composition. Isn't it? Seawater, same composition. So right, so the same composition. Fine. So which of the following homogeneous mixture? Mixture of salt and water. No, it is clearly showing that it's not homogeneous. It has two different combinations. Next, sugar solution. Sugar solution has the same composition throughout. So this is a homogeneous mixture. Next, mixture of sugar, salt, sand. No, it is heterogeneous, isn't it? So iodized table salt. No, that is also heterogeneous in nature. So the homogeneous mixture is sugar solution. This is how you need to apply the concepts. And start solving the numericals which are based on uncertainty measurement. So we have already studied in uncertainty measurement what concepts. We have studied about scientific notation, representation, then we have studied about significant figures, then we have also studied about dimension analysis, isn't it? So these three topics come under uncertainty measurement. So when I have to speak about solving the question, so now concept is clear, now let us start solving. I picked up certain questions from your comprehensive. I'll also be doing every question of NCERT. Yes, let's do this. Here what they give me, express the following in the scientific notation. So whenever scientific notation word is given to you, what should you remember? The formula for scientific notation is capital N into 10 raised to the small n. This is the formula, isn't it? Yes. So what is this capital N? This is a number which can range from 1 to 10. This small n is an exponent. This exponent, which can be either positive value, it can be negative value, it can be anything, but 10 raised to power of that particular exponent. So with this concept, let us start. So I need to apply this formula in this case. So in the first one, when I have to take, now just see, I need to write in this form. I said n means that particular number. It should range from 1 to 10. So this becomes 1.86. Fine, the remaining zeros I'll mention in the form of 10 raised to. So what did I do? How many did I shift? I shifted from, this is 1, this is 2, this is 3, this is 4, this is 5. I've shifted 5 positions. That's why it is 10 raised to 5. When you're going in this direction, it is positive. When you're going in this direction, in the exam, if you're writing in this direction, it is negative in nature. Right. When I have to go to the next one, 4007, again, I have to write it in the form of scientific notation, and that should start from between, it should be between 1 to 10. So I'm going to write 4.007. Now decimals, how many did I shift? It was here, isn't it? 1, from here 1, 2, 3. So 10 raised to the power of 3. Isn't it? I'm going this way, positive. Now if I have to write this is 0.0068. Now I'm going to write in scientific notation terms, because as I said, this is n. N stands from 1 to 10 only. So the number is n. What is 1 to 10? 6. 6.8. Now what am I going to do? I'm going to shift the decimal in this direction now. Right? How many positions? 1, 2, 3. Right? So when I shift it to the other direction, this will become 10 raised to the power of minus 3. Done. Let me come back to this. Now what am I going to do? I need to write in this notation, that is 700. It will become as 7 into. Now what did I do? I've shifted the decimal in 1 and 2. 2 positions. Isn't it? 7 into 10 raised to the power of 2. So fifth one, when I have to take 7.0042, I can write in this, because you have a non-digit number, non-zero digit. That means a number other than 0 is present. I can't write it. So the answer would be 7.0042. That's it. So this is how we are going to write the sum. Careful, whichever is given, substitute in this and write according to this. If I go towards this direction, it is positive. When I go to, when I go towards this direction, like if I have to stand like this, now I'm going in this direction, so it is positive. Here also I'm going in this direction, it is positive. Now here I'm going in this direction, so this is negative. Fine. Right. Now let's come back and do one more based on your scientific notation, so that your concepts are clear now. So again, they've given us to write in the form of scientific notation, that is, this is your NCERT question, right? So here, what should I do? As I say, every time whenever you're representing something in scientific notation, the number which you're going to write should be in the form, or it should be represented in the form of capital N, that is 1 to 10 only. The number should start from 1 to n, it can be till 10. So in this particular case, what am I going to do? 4. So it's going to start with 4.8 into 10 raised to the power. Now what are you going to do? You're going to shift the decimal from here, isn't it? You're going to shift to 1, 2, 3. Yes, so 4.8 into 10 raised to the power. So it is, I'm going in this direction, so it is minus 3. Now in this case, if I have to write, I need to represent from 2.34 into 10 raised to the power. Now what am I going to do? I'm going to shift the decimal, start from here, 1, 2, 3, 4, 5. I'm going in this direction, so it is positive 5 in this case. Now again, if I have to write this particular number, fine. So can I write anything here? This because the zeros are between 8, isn't it? So what will you write? So here you will write 3. Okay, let us shift from here and see 8.008 if I have to write. So what did I do? Into 10 raised to the power. Now what did I do? From here 1, 2, 3. Yes, 3. In this direction. Now if I have to write this number, start from capital N, that is 1 to 10, 5.0 into 10 raised to the power. Now what did you do? From here you have shifted, this is 1, this is 2, this is 3, isn't it? Fine. So you're going to write it as 3. Done. Now in this particular number, because the zeros are in between this, what should you do? Already there is a decimal here. You can't write any scientific notation here because the zeros are in between. All are significant. So what will you write? 6.0012. You need to represent the form of n into 10 raised to the power of n. This is what? So n I have written already, n. So what is n here? I have not shifted the decimal anywhere. So it is 0. So this is how you're going to write the scientific notation. Right, let us come back and solve one more question based on the significant figures. So scientific notation we have already understood. Now in significant figures, let us see the different variations. So what did we learn in significant figures? Whenever a question is given to you in significant figure, you need to remember all the 5 rules which I have told you. Yes, go through all the 5 rules which I already gave you about the non-zero digit zeros, zeros in between, zeros to the left, zeros to the right, and a number if you have scientific notation. I'm going to apply those in this concept. Fine. So what do they give me here in this? They said express the following numbers to 4 significant figures. I need to round off the number. Final number should be only, the final answer should be only 4 numbers using the scientific figure rules. Fine. So if I have to take this number, round off to 4. So round off 4 final answer. So that means the final answer which I write should be 4 only. Now see here, how will I round off? Start from count this number. First you need to be careful. This is 1, this is 2, this is 3, this is 4, this is 5. Fine. If the 5th number, because I need to round off this number to 4, if the 5th number is more than 5, then what will you do? You're going to add one number to this. 5th number is more than 5, right? So what will happen? This is more than 5, so 7 becomes 8. So what is the number? So what is it? More than 5 means round off last number to next number. Okay, that means round off last number to next number means how can I write this now? The answer is 5.608 because this is more than 5. It's simple, isn't it? Let us do the next one. If I have to take this number, so total numbers of significant figures are 4 I need to make. So the same is the case with this. I need to make this so many numbers. I need to write 4, round it off to 4 significant figures. So copy that exactly, 32.3. Now start counting 1, 2, 3, 4, 5. This number is less than 5. When you if the number is less than 5, what will you do? You drop the number. You drop the number. When you drop the number, what will happen? Yes, obviously, this particular thing will remain like that only. The answer is 32.9. No change in the last number. So 4 significant figures are written. Now in the next case, if I have to take 1.789, okay, what should I do? I need to round it off to 4 significant figures, they said. Fine. So simple. I'll take count from here 1, 2, 3, 4, 5. The 5th number is again more than 5. So what will I do? I'll round off this number. So I need to make it till 4. So 5th number is greater than 5. So what will happen to this? 9 will become 0. That means 89. Total 89 will become 0 means it should not be 80. It should be 90 because you're increasing. You're adding one number. 89 will become 90. So the answer is 1.790. Hope it is clear. Now in the 4th case, when I have to write this number, fine, significant figure. Now basically what is significant in this? I said the zeros which are towards the left are non-significant. Towards the left are extremely left are non-significant. The numbers which are towards right are significant. Here where are the zeros? They are towards the left. So what are the significant figures here? 7837 only. So how will I write this? I'm going to write it as 4 significant figures. Now I'll write 7, 8, 3, 7, but you will represent in the form of what the zeros raised to the power of 10. What did I do? How many I shifted? I shifted from 1, 2, 3. Isn't it? Yes, 3 positions have shifted. So you can write it as 7.87. So I went in this direction, isn't it? If I go in this direction positive, I go in this direction negative. So this is the answer. This is how you will write this significant figure. Right. Now, let's come back into some more questions on significant figures. Here, what did they give me? Express the following to 3 significant figures. Earlier, we've done with 4 significant figures. Now, 3. Let us do more. Here, when I have to solve this. Now, 3 means just count. Start from here. 1, 2, 3. So, you need to see, I need to write an answer with 3 significant figures. But while rounding off, you need to be careful and observe the 4th figure. Based on that only. What did I say? If it is more than 5, you need to increase the number. The number which is adjacent to that will be increased by 1 number. If it is less than that, you are going to drop that number. If it is equal, and again you have variation there, odd and even also, I'll show that also. Fine. So here, 3 significant figures. So this is less than 5. I can drop this number, drop it out. And what do you get? You get an answer of 6.02, 3 significant, because 3 only numbers they want me to write in the answer. Into 10 raised to the power of 23 will be like that only. When I have to take the second case, right? Now again, start from here. 3 significant figures, 1, 2, 3. Now fourth number you need to see. This is more than 5. So what should I do? I need to increase the number of this. Fine. What will it become? 5.36, because 5 will become 6. This is more than 5. So don't write 60. Why? Because they've asked me only 3 digits. It should be only 3 digits in the answer. So because of this 5 has become 6. The next question. When I have to speak about the next question, here I need to make again 3 significant figures. Start from here, 1, 2, 3. The fourth one, fine. But here what are the significant numbers? It is only 4, 5, 9, 7, isn't it? So you have to be careful in this case. So 4, 5, 9, 7 when I have to write. So careful. So the same thing, if you write the answer, it will be 0.04. Right? So, but here, what is a significant figure? Here it is 4, 5, 9, 7 only is a significant figure. You need to count that. So, 4, 5, 9 and 7. These 4 is only countable. You need to count. So, here when I have to see the fourth number, it is more than 5. More than 5, isn't it? So what will you write? If it is more than 5, this particular number, 4, 5, 9, 7. So what will happen? This will become 460, because this is more than 5. 59 will become 60. So this is 0.0460. This is the answer. Now, hope this is clear. Once again, 0.045. But here left, the zeros which are towards the left are non-significant. So the significant figures are 4, 5, 9, 7 only. Now in this, I need to round off to 3 digits, because they've asked me 3 digits. And in this case, when I see the fourth number is more than 5, that means I need to round off this number. So one number, if I increase, it will become 59 will become 60. So that's why I've written 0.460. Now, when I have to do the last one, 34.2. Now, see here, 1, 2, 3. I need to round off till the last digit, means only these numbers. So, after the third, the fourth digit is less than 5. That means you need to drop that number. If it is less than 5, you need to drop that number. Drop this number. What do you get? You're going to get 34.2. Only 3 significant figures. This is how you're going to solve the question. Right, now let's come back and do one more question. This is again from your NCERT book. Fine, what did they ask me? Earlier, they've asked me to round it off to 3 significant figures or 4 significant figures. But here they're asking you how many significance, because both the ways they may ask you. So how many I should know, right? How many significant figures are present in the following? Now, let us recollect the rules once again. In significant figures, first of all, the numbers which are towards the left are not, all the zeros towards the left, that is before the number, if they are towards the left, they are non-significant, right? That is the first rule. Next, the numbers which are in between the zeros which are in between the numbers are significant. Third rule, if the zeros are towards the right hand side of the decimal, right, then again they are significant in nature. Right, in certain cases we have written in the form of scientific notation, which you have seen. So those are the rules. Let us apply those. Now in this particular case, now count. Now towards the left, zeros are towards the left, ignore. They are not significant. So how many total? 2 are the significant figures. These 2 only, according to the rule. In the next one, the zero in between the numbers is significant. So all the 3 are significant. In this case, the same story again. Here the zeros in between the numbers are significant. So total how many? 1, 2, 3, 4. 4. Once again, after this. Then we said the 1, 2, 3, 4, 5, 6 are there. Now they're asking me how many significant figures. Now careful. If it is a decimal and if it is towards the right, it is significant. But here, are you finding any decimal? No, isn't it? Not there. So only significant figures are 3. This is 3. Now, in this case, here, this particular thing, how many significant figures? 1, 2, 3. Only 3. Right? Now, careful. There is a decimal here. When there is a decimal, and after decimal, if there is a 0. Here, there was no decimal, so I took out the 3 zeros. But here, after the decimal, towards right, if you have a 0, that is significant. Towards left, you are neglecting. Towards right, you are counting. Once again, towards the left, you are neglecting. Towards right, you are counting. So, total how many? 1, 2, 3, 4. Next, here the zeros are in between the numbers. So, all are significant figures. 1, 2, 3, 4, 5. 5. This is how we are going to apply all the rules of significant figures in such questions. Right, now let's come back and do this question. This is again your NCERT question, different ways of doing significant figures. So here, how many significant figures should be present in the answer of the following calculation? So basically they're not asking you to calculate, you just need to tell how many significant should be numbers should be present. Now when I have to see this is particularly basically a division part. Now nothing to see, just see whichever number is minimum in this. Now in this case, how many are there? This is not significant, 1, 2, 3, 4. Here in this case, all are significant, 5. Now in this case, 4 are significant. So what is the minimum number? This is the minimum number. So the minimum digit, how many ever significant figures are there? That answer also will have that significant figure only. Once again, count this. Now in this, there are 4 significant figures. I'm neglecting this because zeros are towards the left. In this case, all should be counted because all come under, all are significant. 1, 2, 3, 4, 5 are there. Now in this case, this you can neglect, 4 are there. Now what is the minimum number? 3. So the answer also will have 3 significant figures. So answer will have 3 significant figures. See the least number. Now here in this case, now when I have to speak about this multiplication, fine, this is 1 significant figure. Now these are 4. 4 plus 1, 5. But when you multiply the number, yes, you multiply, you get an answer which will be 1 number less than that. Here it is 4 plus 1, 5. But the answer will have only 4 significant figures. You multiply and see, you will only understand. Fine. Now when it comes to addition, what should you see? Again, see the numbers. So in this case, this is neglected, 3 significant figures in this case. In this case, 1, 2, 3, 4 significant figures. In this case, 3 significant figures. But in addition, what rule you want to remember? Here in this division, you're going to see the minimum least number. In addition, you're going to see the maximum number. Maximum, whichever number has significant figures, answer also will be this. Here in this case, 3. In this case, 4. In this case, 3. This is maximum number. So this is 4. So 4 will be your answer. So this is what you should remember. Once again, division, minimum number, multiplication, 1 number less, addition, the maximum number. It should be the answer also will be so many significant figures only. Right, now let us come back and do one more question, which is addition of your significant figures. Now see, what is the sum of 2.368 kg and 1.02 kg? So whenever addition is given to you, what should you remember? While rounding off, you have to be very careful, right? You need to see the minimum number. Okay, I'll tell you what it is. So first take the sum. 2.368 kg plus 1.02. Fine. So add it normally. This is 8. This is also 8. This is 3. This is 3. Now I need to round off the number. What should I do? I have to see the minimum significant number, which is the minimum significant. Here how many? 1, 2, 3, 4. 4 significant figures. Here in this case, it is only 3. That means I can round off my answer to 3 digits. You can take the 3 digits. So the final answer, you will write is 3.38. But when you are rounding off, you have to be careful because the fourth number is more than 5. Right? You need to remember 2. Meet the minimum number as well as rounding off. So here the fourth number is more than 5. So this will become extra. You need to add one more. This will become 39. So this is your answer. So this is kg. 3.39 is a kg. Listen, first of all, I saw the minimum number. Second, I saw the number which is after that number. If it is more than 5, I rounded it off. Simple question, isn't it? Yes. Now, let us see this question. Here, what did they give me? The mass of a sample of iron metal is 5.932. Right. If the density of iron is 7.8, what is the volume? So, let us write. First of all, density, how much is given? 7.8 gram per centimeter cube. What is the mass given? Mass is 5.932 grams. What should I should find out volume, right? I know density is equal to mass by volume. Volume I need to find. Volume goes here, density comes down. So volume is equal to mass by density. How much is the mass? It is 5.932. Divided by density is how much? 7.8. Okay, gram per centimeter cube. This is again gram. Gram and gram gets cancelled. Now when I solve this, I get an answer. What is the answer? Like I get an answer of 0.76. Like I get a big number. But when I round it off, I'm going to write it according or round off the answer according to the number, minimum number present. Right? Here also the same thing. I saw the minimum number. Here also the same thing. In this case, how many significant figures are there? 1, 2, 3, 4. But in this case, how many significant figures are 2? So the minimum number is 2. Significant figure is 2. So this also I rounded off to 2 significant figures. Why is this not significant? Because it is towards the left hand side. So the minimum number here, the significant figure. So what is this? Volume is equal to gram got cancelled. So centimeter cube. So remember, always see the minimum number present in the given data. Let us come back and do this question, which is again based on your addition or whatever it is. Let us see this based on your significant figures. So the mass of an atom of hydrogen is 1.008 AMU rather. What is the unified mass? What is the mass of 32 atoms of hydrogen? Simple, isn't it? What do they want us to know? One, if I have to speak of this one, mass of one atom of hydrogen, how much is it? 1.008 U. They've asked for 32 atoms. So 32 atoms, how much? They're asking us. Fine. Just cross multiply. 32 atoms into 1.008 U. That is nothing but per atom you're calculating. U by atoms. So atoms and atoms gets cancelled. Now once you multiply 32 into 1.008, you get 32.256 answer. What is this? U. Now, what is the thing? How much should I round it off to? If you multiply directly, you get this answer. How much should I round it off to? The concept is here, immediately when you see, as I said, you should see the smallest number. But this 32 is an exact number, isn't it? Exact, as I said, we have studied in the rule, exact number. It can have any number of significant figures. So don't go with that. Don't go with the exact number. If you have some decimal present there, then that is different. Here it is an exact number. So you need to consider this number. Here in this case, how many significant figures are there? Right? So as I said, exact number, don't consider. This number has 1, 2, 3, 4. Why 4? Because the zeros in between the numbers are also significant. There are 4. So round off this number to 4 significant figures. Now round it off. What do you get? 32.2. Fine. Now careful. After the fourth number, there is 6. That means it is more than 5. Then what will happen? 6. This 5 will become 26. So this is your answer. 32.26 U is the answer. So careful. This will not take because it is an it is an exact number. Leftover you have seen. After seeing that, you have come back to this. And while rounding off because this is 4 significant figures, I need to round to 4 significant figures. In that case, the fifth number is more than 5. So come back and make it round it off to the highest number. Now, this one. Here, express the result of the following calculation to the appropriate number of significant digits. Appropriate number means I should again see which is the minimum number and round it off to that. Now, suppose if I take this, if I multiply this, what do I get? I'm going to get 20.0, this part. Fine. So next, the leftover is I need to add this. So I'm going to get 215.67. Now add this. This is 7. This is 6. Now 5. This is 3. This is 2. So here in this case, as I said, the smallest number is the minimum number, that is 20.0. How many are there? The 3 significant figures. So here what did I get? I got 1, 2, 3, 4, 5 significant figures. So round it off to 3 significant figures. Come back. 1, 2, 3, right? So in this case, the fourth, this one, I'm going to take the fourth one, and careful, this is more than 5. So this will also increase in number. 6 will become 7. So 235.7 is the answer, right? So this is how you're going to do the sum. Right, now let us come back and solve this question. Here, what does this question say? How many significant figures should be present in the answer of the following calculations? So they want us to tell us the perfect significant figure. Right, they've given us certain questions here. Already, what did I do? I've already solved it and written the answer. That getting the answer, everybody will get that, but only thing is you should know how to write the significant figures. Now, in this case, when I have to see, as soon as you solve some numerical, your concentration should go and you should have, you need to concentrate on the number which is minimum significant figures. Now among this is non-significant. 1, 2, 3, 4 significant figures. In this case, all 4 are significant, but in this case only 3. So the minimum number is 3. So your answer also should be rounded off to 3 significant figures. Fine. So here in this case, now come back. This is your answer. These 2 are insignificant. You will not count them. So how many 3 means? 1, 2, 3. right? So now this is till here, you need to round. So how will you write? 0.05. Now careful, after 1 2 3 there is a number which is more than 5, isn't it? If it is more than 5, we will increase the number to that. So what will this become? 61. Fine. So this will become 61. Correct. Yes. The next question. Here in this case they have already given the number. Now come back and see the number which is this is minimum 2 significant figures. You need to round off the answer to see 2 significant figures. Now see here, 1 2 3 4 5 are there. Round it off. This becomes 3.3. Why? Because after this a number is equivalent to 5, but the number which is beyond this here is even. This is where you need to be careful. This is even, right? So that is why you're writing as 3.3 into 10 raised power of. Now what did you do? You shifted the decimal towards the side, 1 2 positions. So this is your answer. Now in the next case, this is your answer given. Now I have to round it off. So here in this case, when you round off this particular number, just see this is all significant, isn't it? Now we are going to shift the number to this. So this becomes 1.789. Okay, 89 becomes 90, isn't it? 1.790 because the number is more than 5. 1.790 into 10 raised power of 3. Fine. Now in the last case, this particular thing, the minimum number has 3 significant figures, so your answer also should have 3 significant figures, that is 1.04. So see the minimum number and round off the answer also to the minimum number of significant figures. Right, now let's come back and see the last set of questions from this of your comprehensive books. I'm again mentioning the same. NCERT questions also I've already solved. Let's see this. Now express the following calculation to the proper number of significant figures. So whenever such question is given to you, only one thumb rule which you should remember. What is that? Go with the number which has minimum significant figure. In this, there are 3 significant figures. In this case, 2 significant figures. Here in this case, this is a number which is minimum significant figure, that is 1, only 1, because the number, the 0 which is towards the left is non-significant according to the rule, right? So towards the right after the decimal are significant, towards the left they are non-significant. Fine. So now already I've taken the answer here. I got 0.0964 into 10 raised power of minus 6. Right? Instead of wasting time, I wrote the answer. So we've written the answer. Now let us round off. So what the minimum number has how many significant figures? Only 1. So come back. So here, just see. After 0, this is 9. Isn't it? More than 5. So round off that number. 9 becomes what? 10. Because I need to round it off to only one significant figure. Why? The minimum number is this. So 09 becomes 01. It is 0.1 into 10 raised to the power of minus 6. Hope this is clear. Fine. Now let us come back to this question. Here what did they give me? They've given me the Star of India sapphire weighs 563 carats. If 1 carat is equal to 200 milligrams. Okay, if 1 carat is 200 milligrams, 563 carats, how much weight? Simple, 563 into 200 by 1 carat, that is 1000 if you take, because it's milligram. I get an answer of 112.6 grams. Okay, 6 grams. That is your answer. Now here the number, okay, this is 3, this is the okay, 2 into 10 raised to the power of 2, this is 1 into 10 raised to the power of 3. Okay, so 3 is a number because I write it in scientific notation, 2 into 10 raised to the power of 2, 1 into 10 raised to the power of 3. So this number has minimum 3, so I brought it as 112.6. That is the answer. Then I started with giving you information regarding that is your significant figures as well as scientific notation. I also gave you what is the difference between element, mixed, compound, mixtures, all these things. Now let us come back to the next topic, that is dimension analysis. So you have in physics also and chemistry too. What is this? Dimension analysis, basically it is a technique. Like when numerical is given to you, a lot of conversions are supposed to be done. It's a technique for solving numericals. So in dimension dimension analysis, first important thing for your 11th examination, or rather most of them, you need to remember the conversion factors. What is that? The conversion factors, please Google it and you'll get it. The conversion factors which are pertaining to length, how to convert meter to centimeter, centimeter to further millimeter, like that. So the conversion factor of length, mass and weight, conversion factor of volume, conversion factor of temperature, conversion factor of pressure and force and energy. All these conversion factors, try to note it and keep. It will be very useful, but I'll also be doing along with the numericals also. So let's come back. So what did I say? Dimension analysis is nothing but it's a technique to solve numericals. So suppose if a question is given to us, so as I said, you need to remember all these. Now pertaining to this question, I've given you certain conversion factors here. Fine. So a jug contains 2 liters of milk. Calculate the volume of milk in meter cube. It is the simplest numerical. So I need to convert it into, and I need to find from liters, I need to find it into meter cube. How should you do? First of all, when you are trying to do it, try to pick up the quantity which is given to you, whatever quantity you are supposed to solve. So 2 liters, multiply it. So take, now first of all, what do I know from the conversion factors? 1 liter is equal to 1 dm cube, decimeter cube. The same dm cube is equal to 10 raised to the power of minus 3 meter cube. First keep noting in your book this. Then as and when you use it will be useful. Just keep practicing. First you should know the basic information. So 1 dm cube is equal to 10 raised to the power of minus 3 meter cube. Fine. That is again equal to 10 raised to the power of 3 centimeter cube. Again equal to 10 raised to the power of 3 milliliter cubic centimeter. 10 raised to the power of 3 cubic centimeter. So this is one way. And the second variety is 1 milliliter is equal to 1 centimeter cube, or equal to 10 raised to the power of minus 6 meter cube, or equal to 1 cubic centimeter. Now I'm going to use this data. How should I use? First of all, what did they ask me? They've given me this data. I need to convert it into meter cube. Simple. Now take 2 liters. Now divide by 1 liter. Why? Because this liter and this liter gets cancelled. Now come back to the table. 1 liter is how much? 1 dm cube. 1 dm cube is how much? Equal to 10 raised to the power of minus 3. Because I am going to stop here. Why? They've given me to find out for meter cube. So simple. Try to multiply with 10 raised to the power of minus 3 meter cube. Right along with the units. Hope you have understood this. You know, I can take dm cube, not a problem, but again dm cube, again meter cube, why to convert? Because this is equal to this. So 1 liter is equal to 10 raised to the power of minus 3 meter cube also. This liter and this liter gets cancelled. Now what is left? 2 into 10 raised to the power of minus 3 meter cube. Now we have got the answer, isn't it? Simple. Using dimension analysis, cancel the common terms. Fine. So now the answer which is expected is in meter cube. Fine. So these things will be given in the exam also. The parameters will be given, but better you remember, memorize the parameters, the conversion factors, and go to the exam. Right. So let's come back and do one more question which is based on the time value, right? So time, now we are going to consider the time factor. Now simple, we know 1 day is equal to 24 hours. Again the same, 1 hour is equal to 60 minutes, 1 minute is equal to 60 seconds. These are the conversion factors for time. Now what is given in the question? Simplest, basically how many seconds are there in 2 days? Nothing to do, simple. Remember, parameters are given to you. You need to convert the convert the days into seconds. How many seconds? Final answer you should have it in seconds. Simple. Pick up this information. So 2 days into, right, divide. Now I need to cancel this, correct? So divide it by 1 day, so that this day and this day gets cancelled. Now what is 1 day equal to? It is equal to 24 hours. Now still my answer is not ready because I need to find in seconds. Now again divide it by 1 hour. Why? This hour and this hour gets cancelled. So 1 hour is how much? 60 minutes. Done. Still my answer is not complete because I need to find in seconds. Divide this again by 1 minute. So this hour and this hour gets cancelled. This day and this day gets cancelled here. And now I need to cancel this minute. So I've divided with 1 minute. So 1 minute is how much? 60 seconds. So this minute and this minute gets cancelled. Now simple, isn't it? Now multiply 2 into 24 into 60 into 60. How much this comes to? This comes to almost 172,800 seconds. So this is how you're going to do the sum. Only thing important is, first of all, take the given quantity. It should be cancelled, then you multiply and divide it by 1 day, so that this day and this day gets cancelled. Now 1 day is equal to 24 hours, that I have written. To cancel this again I have written 1 hour. 1 hour is how much? 60 minutes. That hour and this hour got cancelled. Again, to cancel this minute, I have divided with 1 minute. 1 minute is how much? 60 seconds. This minute and this minute got cancelled. Finally, I have multiplied to get the required answer, which should be in seconds, because they have asked in seconds. Right, now let us come back and do the next one. Now we have picked up based on distance. So you need to know the conversion factors for distance. So what is this? Express each of the following in SI unit. So basically I need the given data. Let us read the question first. Distance between Earth and Sun, that is 93 million miles. I need to convert this million miles into the SI unit. What is the SI unit for distance? SI unit for distance is nothing but meters, isn't it? This is the SI unit. So meters. That means I need to convert the given answer into your meters. Fine. Let me pick up what is the data. What is 93 million miles? Nothing but 93 into 10 raised to the power of 6, isn't it? Yes. Miles. Fine. Done. So million I've written in this form. Done. Miles. Now pick up 93 into 10 raised to the power of 6. Okay. Miles. Fine. Into, I need to cancel this mile, so I'm going to write it in form of 1 mile, so that this mile and this mile gets cancelled. Now what is 1 mile equal to 1.6? These are the conversion factors which I've given. Please try to note it in your book. It may be useful in any numerical given in the exam. Fine. 1 mile is how much? 1.6 kilometer. Right. Into, I need to cancel the kilometer, so I'm going to write 1 km now. So this, first of all, let us cancel this mile and this mile got cancelled. Now this kilometer and this kilometer gets cancelled. What is 1 kilometer equal to? It is nothing but 10 raised to the power of 3 meters. Done. Now my final answer, I've stopped it till meters because I need to get the answer in SI unit. They said SI unit for distance is nothing but meters, as I said, so I've stopped it here. Now multiply 93 into 10 raised to the power of 6 into 1.6 into 10 raised to the power of 3. Fine. How much do I get? I'm going to get an answer of 148.8 into 6 plus 3, 9. Further, I can simplify writing in decimals, or I'm going to shift this 1 and 2. So what do I get? Because this is more than 5, I can round it off to 1.49. So this comes back to 1, 2. So 1.49 into 10 raised to the power of 11, isn't it? 2 decimals, so 11. This is the final answer which you have got. Right. Now let us see one more question which is based on the distance. So we have tried to solve in terms of, we have solved it like day concept. We have written in terms of length. We have spoken in terms of distance, right? We've spoken in terms of volume, like that. Let us see this distance again. So simple. What do they give us? Express each of the following. The question given to us is average distance between carbon atoms in diamond is 1.54 angstroms. Right? You need to write it in terms of your SI unit. Fine, both the conversions we will try to do it. Fine. So meters and centimeters. First of all, given to us is 1.54 angstroms into, I need to cancel this angstroms, so I'll write it as 1 angstrom. What is 1 angstrom equal to? It is nothing but 10 raised to the power of minus 10 meters. Suppose I'll still further convert it. What do I do to cancel this 1 meter? You will divide by 1 meter. So 1 angstrom and 1 angstrom gets cancelled here. 1 meter gets cancelled. What is 1 meter equal to? 10 raised to the power of minus 8 centimeter. Fine. So that is what you're going to do. Fine. Suppose if you are stopping it till here, what do you get? SI unit in terms of meters. How much do I get? 1.54 into 10 raised to the power of minus 10 meters. If you're further continuing till centimeter, if they ask you, like they've not asked us, if they further ask you in centimeter, you will multiply 1.54 into 10 raised to the power of minus 10 into 10 raised to the power of minus 8. Correct. So bases are same. Minus into plus, this becomes minus into plus minus, and you'll finally find the answer. So the answer which you get is 1.54 into 10 raised to the power of minus 10 plus minus 8. So 1.54 into 10 raised to the power of minus into plus is minus. So so minus into minus is plus. So I get 18 minus. This is in centimeter. This is how we are going to do. Right, now let's come back and do one more numerical. This is based on the height. So here what do they give us? Express each of the following in SI unit. That is a common question for all the three. Average height of Indian male, that is 5 feet 6 inches. So 5 feet 6 inches, they want us to write in SI unit. So what is the SI unit of this particular thing? It's meters, isn't it? That means I need to find the answer in meters. First of all, let us take that 5 feet. So 5 feet 6 inches. What does 5 feet 6 inches means? 1 feet is how much, or 1 foot is how much? 12 inches. So first of all, let us convert 5 into 12. 12 into 6, plus 6. Plus 6, isn't it? Fine. So 60 plus 6, nothing but 66 inches. 5 feet 6 inches means 66 inches. Now it's easy. I'll use the conversion factor. So like take that 66 inches. Fine. I need to find in what? In meters, because it is an SI unit for height. 66 inches into, I need to cancel this. So I'm going to divide by 1 inch. How much is 1 inch? I know 1 inch is equal to 2.54 into 10 raised to the minus 2 meters. So multiply that, 2.54 into 10 raised to the minus 2 meters, because I need the answer in meters. So multiply this now, 66 into these two multiplication factor, I get answer of 167. I've written it here directly into 10 raised to the minus 2 meters. So still further to simplify, I'm going to shift this decimal 1 and 2. That comes to 1.67. 2 already I shifted. 1.67 meters. So this is your 1.67 meters. That too we have converted given 5 feet 6 inches into meters according to the question given. That is SI unit for the height is nothing but in meters, finding in meters. Right, now let's come back and do one more NCERT numerical based on your dimension analysis. Here, what do they give us? Pressure is determined as force per unit area of the surface. The SI unit for pressure, that is Pascal, is given here. They'll give you like this in the numerical, the conversion factor. And what should I do? If the mass of the air sea level is 1034 gram per centimeter square, calculate the pressure in Pascal. Simplest, nothing much big numerical to solve. Let's see. Whichever answer you get, you need to get in terms of Pascal. That is what you remember. So this Pascal value is already given, right? Fine. So that means I'm going to get this value. From that value, I'm going to get this. Let's see. First of all, pick up this. What do we know? Pressure is equal to force per unit area. Or it can be mass per unit area. Right? Let us write. Mass is given to us how much? 1034 grams. Per unit area we have written, so into 9.8 ms n square divided by centimeter square. Yes, done. Fine. So now further convert this gram into kilogram now, because I need to get in Pascal, isn't it? So why this here in nm 1 Newton we have kilogram. So first I'll come back to this, find this and then equalize to this. Okay, let us see what I'm trying to tell you. 1034 gram converted to kg, then you multiply with 100 into 100 into 9.8 ms minus 2. So centimeter also you will convert it into 1000 meters, meter square. Fine. Now careful. 1 meter and this 1 meter gets cancelled. There's one more 1 meter left. This 1000 gets cancelled. Now what are we left with? We're left with 1034 into 9.8. How much it's coming to? It's coming to 1013320. Now careful. 1034 into 9.8, I got this answer. But what is left now units? Kilogram. If I have to speak, ms minus 2. ms minus 2. Now what did we write? 1 kilogram ms minus 2 is nothing but 1 Newton, isn't it? So this kilogram ms minus 2 is 1 Newton. So I'm going to write that as Newton. This kilogram ms2 Newton. So what is this 1 Newton equal to? Nothing but like if I have to take this meter above, this still meter left. So this second is also left. So kilogram is equal 1 kilogram meter second inverse is equal to 1 Newton meter square. because this is equal, this is also equivalent. Now further I'm going to shift this decimal to 5 positions. 1, 2, 3, 4, 5. It is equal to 1.01332. How many decimals did I shift? I have shifted 1, 2, 3, 4, 5 into 5, 10 raised to the power 5. Now 1 Newton per meter square is equal to 1 Pascal. So I got the answer as Pascal. Look here. Hope this is clear. First I took it in grams. I took the formula. I substituted. Then I converted grams into kilograms. Then I cancelled the common terms. After that I multiplied. I very well know 1 Newton is equal to 1 kg per meter square. So 1 kg per meter square. This is there. I've got the answer. But I very well know 1 Newton meter square is equal to 1 Pascal. So 1 Newton meter square is equal to 1 Pascal. Finally, I solved the answer in terms of pascals. Dimension analysis. I'm going very slowly, not a problem, because if you rush you'll trying to forget things. We will do it slowly but wonderfully. We'll complete all the topics, right? So when we come back to the next topic of the chapter, that is laws of chemical combination. So this is under your theoretical part of the chapter. After this we have calculation of atomic mass, molar mass, molecular mass, mole concept and all these things. So laws of chemical combination, when I have to speak, these are the basic laws which we are going to apply. Whenever a reactant and a product combines, they're going to follow this law. Any one of the laws it is going to follow. The first law which you should remember, I've seen most of the students when they say laws of chemical combinations, students tend to write different types. The basic laws of chemical combination, the first one which includes is law of conservation of mass. Law of conservation of mass is the first law. After that, second law of chemical combination is law of definite proportions. You have 5 laws which you should remember. Next, law of definite proportions. Yes. The next law of multiple proportions. To that, the fourth one, law of reciprocal proportions. The fifth one, not the least, Gay-Lussac's law. Gay-Lussac's law. Right? Now, these are the 5 laws which you should compulsory remember in laws of chemical combination topics. So when the examiner or when your teacher is given you to write in the exam, they want you to write the subheadings of this, definition of them, example of them, and if they give you a numerical, you should also be able to solve that. So these are all the 5 laws. Apart from this, there are 2 other laws which don't come under chemical combination. We are going to learn them separately. What are they? The laws are, the first one is Avogadro's law, and I'm going to teach you about Dalton's atomic theory. It's a basic theory, Dalton's atomic theory also. So let us come back and learn one after the other all the laws. Right, now let us come back and learn the laws of chemical combination. So what did we learn? We said law of chemical combination, it includes law of conservation of mass, law of definite proportions or constant proportions, next law of multiple proportions, fourth law of reciprocal proportions, fifth Gay-Lussac's law. Sometimes some books may include also Avogadro's law. Other than that, Dalton's law also we're going to learn. Fine. So when I have to speak about law of conservation of mass, who has introduced this? This law was introduced by Lavoisier, father of chemistry. This law was introduced by Joseph Proust. Alright, so this particular law was introduced in the year 1774. This law was introduced in the year 1799. Fine. So when I have to speak about this law, what does this say? So nothing, it's simplest. You have to remember when I have to take a reaction. Now let me take one reaction. So what is this? Here I have taken one reaction. This particular person has taken one reaction, that is mercury oxide. Okay, mercury oxide is a reaction. So when he has taken mercury oxide, when he has heated this, you're going to heat. So when you heat, what will happen? They decompose into products, isn't it? What product do you get? You get 2 products. What are they? One is mercury here in this case, the other is oxide. oxygen. Fine, simple. I picked up the experiment which he has done. So now initially when mercury oxide was taken, this is 100 grams, and when this dissociated, this has formed 92.6 grams and the leftover 7.4 grams. Now see here, this plus this comes to 100 grams, isn't it? So what did he conclude? He said during a chemical reaction. So chemical reaction means it can be a physical change as well as chemical change. What did he say? He said, let us write this 1774 here. So he said during a physical, in a reaction, let it be physical change or let it be chemical change, not a problem. So during a physical or chemical change, during a physical or chemical change, what will happen? What did he observe? The mass or the total mass of the product is equal to total mass of the reactants, right? So remember this, physical change, that is heat, evolution of like normal physical change, dissociating, or chemical reaction just like this. Fine. So during a physical or chemical change, total mass of products is equal to, okay, let me write in words, is equal to total mass of reactants, right? Mass of reactants. That means RHS is equal to LHS or LHS is equal to RHS. Total, this mass should be equal to this mass. That means, what did he conclude? He said mass can neither be created. So with this he has come to a conclusion saying that mass can neither be created nor destroyed. This is what he said. This is your law of conservation of mass. It is totally conserved in nature. Now when I have to speak about law of definite proportions or constant proportions, so what should you remember? Right, here we spoke in terms of masses only. RHS is equal to LHS, LHS is equal to RHS. Fine. So this, he concluded this concept. Now when I have to speak about in law of definite constant proportion, suppose if I take the basic example, water, right? So water formula is H2O. So what will this have? This is a chemical compound basically. So let us write in a chemical compound. Let us start with that. In a chemical compound. So what will happen in a chemical compound? What do we have? This particular hydrogen, when I take one hydrogen, 1, 2 hydrogens, 2. So 2 is 2. What is atomic mass of oxygen? It is nothing but 16. When you cancel this into simplest ratio, 1 is to 8. So what will happen? Fine. In a chemical compound. So what will have, if I say water, water is always, the formula for water is hydrogen, 2 hydrogens and 1 oxygen. It will have the same chemical elements, isn't it? It will have the same atoms always. Hydrogen will combine with oxygen. So same chemical atoms, isn't it? Or the atoms. So in a chemical compound will have same elements. A chemical compound or a chemical compound, let us write in a chemical, no, a chemical compound, right? A chemical compound will have the same elements. How are they combining? They are combining with fixed mass ratio by mass. Always they are combining in fixed ratio. Water means 1:8. So a chemical compound will have same elements combining with fixed ratio by mass. This is what is a thing, isn't it? Fine. So what do I mean? Once again, suppose if I take carbon dioxide, atomic number 6, this is 12, is to 1 oxygen 16, 2 oxygens 32. So let us go back with the 3 table. 3 fours are 12, right? So okay, 4 3s are, let us go with 4, anything is the same. 4 3s are 12, 1 4 8s are 32. So what is this? This is 3:8 ratio. What does that mean? In a chemical compound, if I speak about carbon dioxide, a chemical compound will have same elements. Carbon dioxide means every time it will have carbon and oxygen only, so it will have same elements. How are they combining? They are combining with fixed ratio. They are combining with fixed ratio. In terms of water it is 1:8, in terms of carbon dioxide is 3:8. So they combining with fixed ratio by mass. Why did I take mass? Because here carbon dioxide I have taken the mass, then I have taken the ratio. The oxygen mass I have taken this. So this is your law of constant proportion or law of definite proportions. So the first law speaks in terms of masses. The second law speaks in terms of masses in relation to their combining ratios also. They are picking up the masses in both the cases, but here in this case from the masses they are going into a ratio, constant constant ratio. That ratio or the fixed ratio, we are going to speak in terms of that. So these are the first two laws. Let us come back and learn law of multiple proportions and law of reciprocal proportions in law of chemical combinations. Right. So after learning the first law of chemical combination, that is the law of conservation of mass, we have learnt law of constant proportions and definite proportion. Now let us come back and learn what is meant by, or what is this law, that is law of multiple proportion teachers. So when I have to speak about law of multiple proportion, this was coined by John Dalton. Right. So John Dalton, we have already seen the earlier two levels here for law of conservation of mass as well as Proust for law of constant proportions. So when I have to speak about multiple proportions, first let us take an example and then start deriving or defining this. Suppose let us take three examples. Fine. Right. So in the first example, and we already know combination of elements form a compound, isn't it? So I'm going to start with an compound. Basically, suppose if I take carbon monoxide and I'm going to take carbon dioxide, right? This is one set. Two elements combine together to form a compound. Yes. Now when I'm going to take the second one, Cu2O and CuO. These are basically the examples, like quite common, any type of examples you can pick up. Next example, NH3 and N2H4. Right. So when I have to see the masses of these, fine. So let us come back to the masses. Now I said the elements combine together to form a compound. So when I have to take carbon, the mass of carbon is 12, atomic number 6 in mass is 12. The mass of oxygen here is 16. In this case, again, it is mass is fixed because carbon is same in both the cases. Now, here the mass of oxygen is 32. Here in this case, the mass of copper. Now what is this? This is called cuprous oxide. This is cupric oxide. Okay, ammonia and right. In this particular case, mass of copper, one copper is 63.5 grams. So 63.5 into 2 is to, what is the mass of oxygen? 16. In this case, it is again 63.5 and the mass of oxygen is 16. Let's come back to this ammonia now. Nitrogen mass is atomic number 7, mass is 14 is to 3. Here if I assume the mass of nitrogen, because it's a dimer, if I assume the mass of nitrogen is 14, the mass of hydrogen is 4. Now let's come back. Now in this particular case, which is fixed, one is fixed. In both the cases, this is fixed. In this case, this is fixed. In this case, this is fixed. Right? So let us come back to the simple ratio now. This is 1 and 1. So 16 is to 32. So 1 is to 2. So the simplest ratio is 1 is to 2. Now in this case, this is constant. The leftover, if I have to take, 2 is to 1. This is the simplest ratio. When I have to come back to this particular thing here, 14 and 14 common, the leftover ratio is 3 is to 4. Now how do I define? This is your multiple proportions. So how do I define? You can start writing like this. What is this? When elements combine together, basically elements only combine, isn't it? Let us write that. When elements, okay, let me write like this, a bit bigger. Elements combine together. What happens when they combine together? They form compounds. So the elements, when elements combine together to form compounds, right? This is done. First step is done. And in this, the masses of one of the element is fixed. That is what we have written, isn't it? Right? So let us write that also. The mass of one of the element is fixed and it combines with other element and it combines. So if this is fixed, in this case it is combining with other element, that is oxygen in this case, combines, and it combines with other element or another element. Done till here. Okay, it is right. And what is important? When these two combine together, they are going to bear, or they're going to form a simplest whole number ratio. That is, we are going to take the simplest ratio and that will be the whole number. In this case 1 is to 2, in this case 2 is to 1, in this case 3 is to 4. So and bear a simplest whole number ratio. Simplest whole number ratio. This is what is important. So this is your law of multiple proportions. The same element is trying to combine in different forms. Your carbon is combining, forming carbon monoxide and carbon dioxide. Copper is trying to form cuprous oxide, cupric oxide. Now nitrogen is forming a dimer of that. So that is the thing. So like if I have to take NH2, and it's not dimer, if I have to say NH2, NH2, hydrazine basically, it's like this. N2H4 is NH2, NH2. N2H4 is hydrazine. Fine. So now this is your law of multiple proportion. Let us come back and finally see when elements combine together. When elements combine together to form compounds, the mass of one of the element, is fixed, and it combines with another element which has that is variable. And once they combine, they're going to form a simplest whole number ratio. That is, those are the keywords which you need to write. Now let's come back and learn law of your reciprocal proportions. Right. Let's come back and learn the next law that is in your chemical combination. First was conservation of mass. Next is constant proportion. Third, we have learned about multiple proportions. Now we'll speak about reciprocal proportions. Now basically, what did we learn in the earlier case? We said when two elements combine to form compound. That is what we have written. But here in this case, you're going to write when two elements combine. We very well know they have to combine to form a product. But what are they combining? They're combining with a fixed mass of other element. One more they're going to combine, that is with a fixed weight. They're going to combine with another element, okay, elements rather, which are going to form compounds. Another elements I'm going to write, they're going to form compounds which have, what did I say, fixed mass, which has fixed mass. Fine. Fixed mass. And what will happen after combining? They're going to get, or we are going to get an answer which is of a whole number. It is almost similar to your previous one, but here the difference is we are talking about a third compound where you have fixed mass. Right, that's right, which has a fixed mass. They're going to bear a ratio which is, okay, simple ratio, let us write. Simple ratio which is a whole number or multiple of that. Okay, what am I trying to explain? Multiple of that. Now let us see the example, then you will understand. Suppose if I have to take an element, but here one condition is one should be fixed amount, fixed ratio. Fine. So here if I take carbon dioxide, I'm going to take sulfur dioxide. Here I'm going to take carbon disulfide. When I have to see the ratio of this, in the first case, here atomic mass 12 is to oxygen 16 and 32. Here in this case, sulfur 32 is to 32. Isn't it? Yes. So now how much did we get? This ratio and this ratio is standard. Oxygen, it's the same. So we are left with 12 is to 32. So this comes to simple ratio 3 is to 8. So I've got one ratio that is simple, that is whole numbers. Now when I have to compare with the third one, carbon disulfide. Carbon mass is 12. Sulfur 16 and 32 into 2, 64. When I have to say simple ratio 3 is to 16, isn't it? Yes. So let us take this. Now in reciprocal proportions, now let us see the ratio, because I need to compare between this set and this set. According to reciprocal proportions, 3 by 8 into 3 by 16, but the other way around, 2 is to 1. So this is your simplest whole number ratio. That is what we have mentioned at the end. It may be a whole number or multiple of that. That is what we have said. So this is your law of reciprocal proportions. Right, so let's come back and learn the next type of chemical combination. This in the law, that is Gay-Lussac's law of combining volumes. As the name suggests, Gay-Lussac's law of combining volumes. So volume, when do we use this? We are going to use when we have gaseous reactants and the product form also is gaseous. So basically Gay-Lussac's law speaks in terms of volumes, combining volumes of gaseous reactants. So suppose if I have to take in a container, it's a simple way of explaining, right? I'm going to take in this container hydrogen gas. How much is this? 1 volume of this, right? This is going to combine with 1 more chlorine gas. Here this is Cl2, chlorine, this is also gaseous, this is also 1 volume. These two combine together to form HCl gas. HCl gas, how much is this? If I have to balance H2 and Cl to 2. So this becomes 2 volumes. Now let us write the definition. So the volumes of the reactants or the volumes of the gaseous reactants and products combine in such a way that they bear a simple ratio, simple whole number ratio. But what? When the volumes are considered or taken in at what the same conditions of temperature and pressure should be maintained, then only they'll bear a simple ratio, simple whole number ratio, right? So let us write the law. The volumes of gaseous reactants combine to form products, right? Combine to form products. What? And when they combine to form product, what will happen? They combine to form products in what way? Which bear a simplest ratio. Products which bear a simplest whole number ratio, right? What is the ratio now? Here in this case it is 1:2. 1 volume into 1 volume into 2. That is a simple whole number ratio, right? At what condition? Under say what conditions I said? The volume should be taken under the same conditions of pressure and temperature. So let us write that simple ratio when the volume is taken under same conditions of temperature and pressure. This is what is important. So when you take in a temperature and pressure, constant temperature and constant pressure, then only this law will be applied. Suppose if I take one more example, like simple example, like hydrogen HCl we have taken. Let us prepare ammonia gas now. So nitrogen plus hydrogen gives us what? Ammonia, isn't it? Right, now what is the ratio here? If I have to take, this is 3, isn't it? 3 2s are 6, then this will be 2. Now it's balanced. Now the ratio is 1:3:2. Then only this is the simplest whole number ratio. Nitrogen is 2, here 2, hydrogen is 6, hydrogen is 6. So they are going to combine only when they maintain the constant temperature and pressure conditions. So Avogadro's law. So when I have to write the definition of this, right? First important, both the cases equal volumes. The word has to start with equal volumes. Here also equal volumes, right? Equal volumes of what? Of all the gases. Here also equal volumes of all the gases. The same thing, right? Under what? Under the same conditions or the same conditions of temperature and pressure. Under inverted commas, I forgot. Under same conditions of temperature and pressure. Okay, yes, here also same equal volumes of all gases under the same condition of temperature and pressure. Okay. Okay, now what is the difference? Here is the difference. What is the difference here? According to Berzelius, he said it contains equal volumes of all gases and at the same conditions of temperature contain equal number of atoms. This is where is a major drawback of this. Let us see what it is. Contain equal number of atoms. Right, here what did he say? Contains equal number of molecules. That is what is important. Fine. Right, so when I have to speak about this, let us take an example and understand. So now here in this case, both are going to speak about gaseous volumes. Now let me take hydrogen, a gaseous state. It's going to combine with chlorine. This is going to form 2HCl, hydrochloric acid gas. Right, same. So now here if I have to take, this is what, n moles. This is also what, n moles. Here this is 2n moles, isn't it? Fine. So now when I have to write in terms of atoms, because they said atoms, he spoke about regarding atoms. So 1 mole is nothing but this becomes 1 atom. This becomes 1 atom. This becomes, right, 2 atoms. Fine. When I have to make, this becomes half atom. This also becomes half atom. This becomes 1 atom. Right. So what is the drawback now? According to Dalton's atomic theory, atoms are indivisible, isn't it? I can't write atom as half atom. There is nothing called half atom. It is only 1 atom. You can speak about molecule, half molecule, not a problem. But here what is the concept? Atom can never be half, isn't it? So it is against Dalton's atomic theory, who said atoms are indivisible particles. They have subatomic particles like electrons, protons and neutrons, but atom is indivisible. It is a smallest indivisible particle. So this is where, so you can write atoms are indivisible. So this is ruled out. Hence this law is ruled out. So now when I have to speak about the second case, this one. So same H2 plus Cl2 giving me 2HCl. The same n moles of this. This also n moles of this, but here this is 2n moles of this. But here what did he speak? He spoke in terms of molecules. Now let us write that. 1, not atom, 1 molecule, 1 molecule, this is also 1 molecule, and this is 2 molecules. Further if I have to write, this will become half molecule, this also half molecule, this is 1 molecule. Right, now I can write, isn't it? Half molecule can exist. 2 half molecules combine together to form 1 molecule, isn't it? Right, so not a problem, right? In terms of molecule, it works out. So this is with Dalton's atomic theory. Dalton's atomic theory. So this particular law is approved because it is speaking in terms of Dalton's atomic theory, which is a basic atomic theory in terms of chemistry. So this is your Berzelius hypothesis. This is your Avogadro's law. Right, and now let's come back and learn the most important, Dalton's atomic theory, which is the base of all chemical combination reactions. So chemical combination laws, sorry, not reactions. So when I have to speak about Dalton's atomic theory, so this was coined by John Dalton. Right, so let us write that John Dalton has coined this word. So now what is it trying to explain us? So basically John Dalton's theory you need to learn under 6 different postulates. First of all, what is the first postulate? Let us write common things first and write the common things, then it's easy for you to remember. Fine, and this is the way I explain. So the first postulate which Dalton has proposed is matter is made up of the smallest indivisible particles called atoms. That is the first postulate is given. So what does it matter? Matter is made up of smallest indivisible particles. Indivisible particles, what are those called? Particles called atoms. Particles called atoms. That is, atom is the smallest. So the same thing related, we'll write in a different way. So atom is the smallest particle that can participate in the chemical reaction. The same atom, I'm writing it here. So what is that? Atom of the smallest particle, the same thing. What is that? Which participates in the chemical reaction. Which participates in chemical reaction. Okay, this is also done. Now, next, what did he speak about? He said atoms of same substance, atoms of different substance. Let us write that. Atoms of same substance. Next, atoms of different substance. I am writing the same thing so it's easy for you. So atoms of same substance, what do they have? They will have the same size, they'll have the same mass, they'll have the same chemical properties, they'll have the same shape, everything, isn't it? So atoms of same substance will have what are this? Same. What are they? Size, shape, mass, and chemical properties. So when I have to speak about this different substance, atoms of different substances they'll have different, isn't it? Will have, if this is same, these are also will be same. Then if this is have different, same thing. Criteria: size, shape, mass, and chemical properties. Fine, done. So this is what. And next, fourth one, what did 4 are over, isn't it? These two are similar, you can remember. Let us put this in box. This is one box which you can write. This is one more which is related to the first one, and this is the next one which is these two are related again. Yes. Now let us write now. As I said, atoms of different elements combine, they combine, isn't it? Different elements, HCl, hydrogen and chlorine are different element. When they combine, what did I say? He said they are going to combine in the fixed simple ratio, the whole number ratio. That is which law? That is nothing but law of constant proportion, isn't it? That law of constant proportion, it is relating to this law of Dalton. So what do? Atoms of, let us put a separate box for this, atoms of different substances combine in fixed which ratio? Simple or whole number ratio. Okay, simple or whole number ratio. Which we have already seen according to constant proportions. The last but not the least one, what did it say? This is just like your law of conservation of mass. This is law of constant proportion. Next one, what is law of conservation of mass say? It is mass can neither be, or matter can neither be created nor destroyed. So the same thing, matter can neither be created nor destroyed. That is what he said. So these are 1, 2 are related, 3, 4 are related, 5, 6 are related. How? This is constant proportion law, relation, conservation of mass, relation. So when we come back to Dalton's, every law has certain limitations, isn't it? Then only further you have different laws coming up to correct that and give us new observations. So when I have to come back to Dalton's atomic theory, the limitations are, that means what are the drawbacks rather, if I have to speak. So limitations is what topics which he could not explain. So Dalton, first of all, he said atom is indivisible, fine. He said atoms are neither, they can be neither destroyed nor created nor destroyed according to law of conservation of mass. But when it comes to limitations of Dalton's atomic theory, first thing is he could not explain, right? He could not just, he told atom, nothing about its structure. So he could not explain about, okay, let us write could not. Could not explain is a common word, fine. So he could not explain or speak about structure of atom. Structure of atom concept was not explained to us. When he could not speak about the structure of atom, we very well know when to hold an atom together, forming a molecule, there should be certain amount of forces acting between them. He could not explain about that also. He could not explain nature of forces between them. Nature of, okay, this F is weird. Nature of forces between them, fine. So now, After this, after the forces, what is important he should know about, or he should analyze. He is not analyzed about. Once the forces are there, he could not distinguish between an atom and a molecule. So he could not explain or not distinguish between. B by W means between. Yes, between atom and molecule. Okay, now what is the next one? After this, one more thing. We said like equal volume, or different atoms of different elements combined with, or atoms of different elements combined to form new products, isn't it? Find different elements combined to form different products, right, with which differ in the properties. That concept he could not explain. He could not explain why atoms of different elements combine. Different elements combine. Why do they combine? To form products. He could not explain why different elements combine to form molecules. Okay, he could not explain this. Apart from that, he could not support Gay-Lussac's law also. He could not support means he has not explained anything about Gay-Lussac's law, which speaks in terms of gaseous reactants. There we spoke about the volumes of gaseous reactants, isn't it, which combine in the fixed ratio. So he could not explain Gay-Lussac's law. Gay-Lussac's law. So these are the drawbacks of Dalton's atomic theory. So when you're learning, try to learn both the postulates as well as limitations. So the next topic in different types of masses is equivalent mass. So basically equivalent mass, first I've written the definition so that when I start solving all this you will understand. So how is it defined? It is defined as number of parts by weight of a substance. Okay, we'll be taking a ratio of the number of parts of the weight of the particular substance, whichever element is given to you, that combines with or it displays directly or indirectly. Okay, so remember all these keywords in your brain, so it's easy when I apply in all of these you will understand. Fine. Directly or indirectly means when they combine they're going to displace how much by weight, that is 1.008 weight of hydrogen, that is, or 8 parts by weight of oxygen, or 35.5 parts weight of chlorine. Okay, why did they give only specifically hydrogen, oxygen, chlorine? Basically the different methods for determining equivalent mass. What is that? Everything has a separate formula. 1, 2, 3, 4, 5, 6, 7, 8, 9 methods are there for determining equivalent mass. So for your prescribed NCERT syllabus, you have only general methods. What are those? We will see. So the first method is hydrogen displacement method. So this definition is common for this one, hydrogen, because I said it's going to directly or indirectly displace 1.008 parts of hydrogen, right? Next, oxide formation method. Okay, chloride formation method, I've taken this chloride displacing. I'll be comparing it in both. Next, metal displacement method. Next would be double decomposition method. I'll also be teaching you what is electrolytic method for calculating equivalent weight, neutralization method, silver salt method, as well as the last method is general method. Under this, as I said, you're going to study about calculating equivalent weight or equivalent weight of a metal. That is a general method which you have. Second, equivalent weight of an acid. Next, equivalent weight of a base. Next, equivalent weight of a salt. Right, all these you have for your syllabus. So the last one is compulsory, you should know about that. Apart from that, all these methods also come under equivalent weight. We'll be learning one after the other. Let's come back and learn the next type of mass, that is your molecular mass and formula mass. So when I have to speak about molecular mass, what is this? This is nothing, sum of atomic masses. So whatever atoms are present in that molecule, that particular atom's atomic mass we are going to take. right? Now the same thing, if I have to speak about formula mass, it is also sum of atomic masses, but here you're going to take in terms for the word formula unit, I use it for ionic substances, for ionic substances, right? Here when I have to take an example, simple HCl, the mass of hydrogen 1.01 U, the mass of chlorine, it is 35.5 U. When I add, I get 36.5 U. This is here, this. You can write it, also write it as AMU. So when you calculate masses, you get a gram per mole also we write. Right? Suppose if I take methane, carbon mass is 12 plus 4 into 1, which is equal to 16 U. That is how you're going to calculate. Now same thing when I have to take for ionic substances. If I take an example, sodium chloride, sodium mass is 23 U, unified mass, which is we are comparing with carbon 12, same as carbon 12 isotope, plus carbon chlorine is 35.5 U, which comes to 58.5 U. You can also write it as or AMU. Same thing with magnesium chloride. What do? You're going to write, you'll get almost 95.20 or something. Yeah. How do you do? Magnesium chloride, magnesium mass number, the atomic number 12, mass number 24, plus 2 into 35.5. This is U, this is also U. When I multiply, I get 95.2 U, or you can write it as AMU also. That's it. Right. So students, welcome back. Let us do the next important concept of your first chapter, that is empirical formula and molecular formula. So unless until you learn, see, you're learning a concept, right? You need to apply on the numericals, then only you'll get that perfection in the concept. So I'm trying to pick up, because it's the first chapter, I'm trying to pick up the questions from your comprehensive as well as NCERT. Your complete NCERT will be done. Every question of NCERT also will be solved by me. Fine. So when I have to speak, we have already learned what is meant by an empirical formula and molecular formula and how to frame it. So here gradually let us do certain numericals based on that. So what is the first question? Here they've given us, write the empirical formula of the compounds having the molecular formula. So molecular formula is given to us. We need to write the empirical formula. What actually is empirical formula? It is nothing but the whole number ratio, isn't it? That is what we have learned. Once again, empirical formula means it is a whole number ratio. I'm again specifying whole number ratio, right? And what is that? It is a whole number ratio of the atoms in a molecule. Obviously, isn't it? Molecule contains atoms. Don't write molecules in an atom. No, atoms in a molecule. So what am I trying to explain? Let me solve this numerical. Here they've asked me to write what? Empirical formula. So this is C6H6 benzene is given. This is a molecular formula, molecular formula, molecular formula. All these are molecular formula, right? So when you have to write empirical formula, simple whole number ratio. Copy the elements exactly like that. CH. Now, make it into a simpler whole number ratio now. 6 ones are 6 ones are 1 1 gets cancelled. 1:1 is a ratio. So if you have 1:1, simple, isn't it? If it is 1, nothing to mention. Leave it like that. So the empirical formula is CH. Next one, when I have to write C6H12. Now C6H12, 6 ones are and 6 twos are 12, isn't it? So copy the elements. So how much was 6 carbon? It was 1 times 6 table, 6 ones are 6 12 twos are. So nothing to write with 1. So 2, CH2 is a formula, which is the formula, empirical formula, because this is the simplest whole number ratio. If you wish to write like this also, not a problem, but it doesn't make any meaning, isn't it? That's why I'm not writing 1 anywhere, right? Let us come back to this. Again, I can, ones are. So write the elements HO. So 1 and 1, nothing to mention. You will not mention the number. When I have to come back to water, so they have asked me to write empirical formula. Again, I'm saying simplest whole number ratio. So here, can I take anything? No, isn't it? So you will directly write the formula. In this case, nothing can be done. It is the same again. N2CO3. Now, in this case, B2H6. Yes, I can write a simplest whole number formula. There is 2 1s are 2 3s are. So copy the BH B2H6, that is diborane. BH are the elements. So this was 1 time and this is 3 times. So H3 is a simple, isn't it? Now let us write this. I can still make this a simple whole number ratio. How? 2 1s are 2 2s are. So write the elements NO. So this went on 1 time and this is 2 times. So take out this 1. This is the empirical formula for this. When I have to write H3PO4, I can't write anything because it is the same. I said simple whole number ratio. When you take the ratio, you will not get it in whole number. So you will directly write that. When I have to write this is the same case. I can't write the simple whole number ratio. So the empirical formula is this. In this case, C2H2, yes, I can write a simple whole number. 1 and 1 goes. So C1H1. So I have nothing to write. So I'm writing this. CH. Here also CH, here also CH. This is how you're going to write the simplest empirical formula from the molecular formula given. Alright. So let us go into the concept now. Fine. Here in this particular question, early question, they've just asked us to find the empirical formula from the molecular formula. Now they're asking us to frame an empirical formula from this. Then gradually we'll go and again frame the molecular formula. Let's see. So when such question is given to you, what data should be important present in the question? First of all, the percentage composition of the elements should be present. It can be 2 elements, not a problem. There may be 3 elements also, not a problem. First important thing, percentage composition should be there. Along with that, you also need the atomic masses of those particular elements. If you know, not a problem, but you will be given the atomic masses. So with this 2 data, I can easily frame the empirical formula of the given thing. First of all, what should you do? First, try to make a tabular column. Fine? Right. Okay. I'll do the tabular column. Here, I've written the answers here for some things so that it is quick for me to explain. In the first column, always remember you are going to write the element given to you. First column, always element. How many elements are given? 1, 2, 3. What is the first element given to me? Sodium. Okay, let us write full form. SODIUM, sodium. So you can write the symbol also here, not a problem. Right, then take this column. Second element, carbon, CARBON, carbon element. In the third column, I am given oxygen. So I am going to write oxygen. Now, after writing this, what should you do? The second important step after element, the next one, which you need to follow is you're going to write immediately the percentage given, because adjacent to the element percentage is given to you. So write down that percentage composition immediately. So percentage composition, how much was sodium given to me? It is 43.4%. How much is carbon given to me? 11.3%. How much is oxygen given to me? 45.3%. Done. After this, immediately copy this data which is given, the atomic masses data. So write down here atomic mass. Fine. So when you write the atomic mass, how much is sodium? 23. How much is carbon? 12. How much is oxygen? 16. Done. 50% of the work is over. Now after this, you have 2 more columns which you should write. So in this, very important. Percentage composition, atomic mass. You have 1 more, that is your simplest ratio, and next is simplest whole number ratio. Simplest ratio is different. Simplest whole number ratio. I am not writing full form. Simplest whole number ratio. WNR, whole number ratio. Fine. So in the first case, take the simplest ratio. How will you get? Right. So before that, you have to do 1 more step. Let me write that. Simplest ratio we will not directly do. You need to, what should you do? You have to find the relative number of moles, then write simplest ratio. Okay. Let me write that. Okay. I have skipped out that step. Let me see. What should you write? You need to first calculate the relative number of moles. Then comes your simplest ratio. Then comes simplest whole number. That means 1, 2, 3 columns. 3 plus 3, 6 columns. So here you need to calculate the relative number of relative number or relative ratio. Then comes your simplest ratio. Then comes your simplest whole number ratio. Simplest whole number ratio. So, okay, relative number. What am I doing? Here, the relative ratio, the relative mass. What does it mean? It is a percentage composition divided by this. This by this. How much is this? 43.4 divided by 23. 11.3 divided by 12. 45.3 divided by 16. Okay, my first step is over. When I divide this, I get an answer of 1.88 here. Then I get an answer of 0.94 here. Here I am getting an answer of 2.83. That is a ratio of the percentage composition with the mass. That's over. Now what are you going to do? You're going to take the simplest ratio. That means among all these, which one is the, first of all, this is 1.88, okay, right? This is 2.83 maximum. So you have seen the 2.83 maximum. At the same time, you're going to see the minimum value also. So this is maximum, this is intermediate, this is minimum. Once again, maximum, minimum, intermediate. Then so go with the intermediate value, sorry, minimum value. The minimum value, whatever is there, that will be taken as a denominator. 0.94, here also 0.94, here also 0.94. Correct? Yes. So 1.88, here in this case 0.94, in this case 2.83. So remember, first you need to see the minimum relative ratio mass. That is what is important. So when you divide this, you get an answer of 2. Here I get an answer of 1. Here I get an answer of 3. Right? Have I got a whole number already? Already I have gotten a whole number. I have not got any other number which is not whole number. I have already got whole number. So I can directly copy the answer. If you don't get whole number, what will happen? What should you do also? I'll tell you. So I've got the same. I've copied here. Let me take this out. Now my whole work is over. Now let me write the final empirical formula. So I should write, therefore the given empirical empirical formula is, you need to write in full words. Start with sodium, Na, second is carbon, C, third is oxygen rate. Now for sodium, how much did I get? 2. For carbon, how much did I get? 1. So no need of writing 1. For oxygen, how much did I get? C. So the formula is Na2CO3. What is the name of this compound? This is called sodium carbonate. So this is how you are going to do. Right? So remember, first element, next comes percentage composition, next comes atomic mass. 3 are over. This is already given. You are left with only 3. Relative ratio, simplest whole number ratio. And finally, you are getting the empirical formula which they have asked you. Right, let us come back and solve a different types of question which is a bit different than NCERT question type of questioning. Here in this question, let's read. Certain non-metal X forms 2 types of oxides. One first oxide means type 1 oxide and type 2 oxide. So let us write what is given. So in the given data, they said there are 2 types of oxide. Okay, for this I am writing it as first oxide. Here I am going to write it as second oxide. Done. In this they said the mass percentage of oxygen is in the first one. The formula is X4O6. That means there are 2 elements given to us and the percentage is 43.7. So mass percentage of oxygen only is given in this. X is not given to us. So let us write. So here oxygen percentage, X percentage. How much is oxygen given? 43.7%. Right? What is the leftover? It is nothing but 56.3. Total comes to 100%. Then they said, which is the same as that of X in the second oxide. Same as X. That means same as X. This is 56.3% and the leftover is 43.7%. Done. Yes, now let's start solving numerically. Let's take both the conditions. What is the first condition? The first condition, 43.7% of oxygen contains how many oxygen atoms? 6 oxygen atoms. That means 56.63 contains how many oxygen atoms? First let us find. Once again, 43.7% of oxygen contains 6 oxygen atoms. The same thing, 56.3% contains how many oxygen atoms? I am cross multiplying this. 43.7, how much do I get? I am going to get 7.73 oxygen atoms. First is over. First part is over. Now I have to find out for X, isn't it? I did like this. Now let me start from here. 56.3 X contains how many X atoms? 4 atoms. Let us write that. 56.3 percentage contains percentage of X. Okay, let us write that. Okay, of X contains how much? How many X atoms? 4 X atoms. Now the same way, 43.7 percentage of this one contains how many X atoms? Now I am writing, for cross multiply this, 43.7 into 4 divided by 56.3. How much do I get? I get 3.1 X atoms. X atoms. Done. Yes. Now I have clarity. I've done everything. Now the last one. I'm going to take a ratio of this, isn't it? Yes. When I take this ratio, now this is 3.1. This is 7.73. I need to find only for the second one. So I'll start with this. So among these two, which is the minimum one? 3.31 is the minimum, isn't it? So I'm going to divide 3.1 divided by 3.1 is equal to 7.73 divided by 3.1. When I take this, 1 is to 2.5. Right. When I write, when I take the ratio again, make it into the simple ratio, I get the answer. Okay, simplest ratio. This can be written as, this is also equal to 2:5. Isn't it? Yes, this is not is equal to, isn't it? This is ratio. Yes. So I've got x2. Now write this formula. This formula, write it here. This is x2. The formula for the second oxide is x2O5. This is the formula. Here I've got x4O6. Here x2O5. These two are the oxides. So take it, compare, find the simplest ratio, take the ratio and then substitute in the formula. So this is how you're going to do your sum. Yes. So students, let's come back and do one more numerical which is based on the same concept, but maybe earlier they've given you 2 elements with the formula, like later you have studied with the 3 elements. Now let us see, they've given us 4 elements to find and frame a formula with that. So let's see. So here a compound, the same concept again. A compound has the following composition. So that there's a compound, it has magnesium in that, sulfur in that, oxygen in that, and water also in that. Okay, that means it will be a crystal which has water of crystallization. That is what is understood. Why? Because the composition of water is 51.22%. That is what in water of crystallization, just like your FeSO4, just like your copper sulfate 5H2O, like that, magnesium sulfate, maybe it will be magnesium sulfate. Let us see how to do. So when such, and what is given? The atomic mass is given. As I said, whenever you're given a question to solve, to find out empirical formula, 2 important data are very important, like important things. First, you should have the percentage of composition of each and every element. Point number 2, you should be given the atomic masses. If they're not giving the atomic masses, you will already know the atomic number. You can double it for few elements, except for few elements, remaining all of the double amount. So that one, and then write. Fine. Without that, we can't do the sum. Fine. So first of all, as I said, once this question is given, try to make a tabular column. So how many should be the tabular column? 6 should be the tabular column, right? I've written the answers for the ratios. So first of all, I calculated and I've written 1 is over. This is your second one. This is your third one. This is your fourth one. This is your fifth one, and this is the sixth one. Yes. So in the first one, always remember what should you have in this first one? You should have the elements. 1, 2, 3, 4 elements. So in the first column, it has element. So how many I have? I have 1, 2, 3 and 4 elements. Done. In this, let me make lines for this. Okay, this is the first one. This is the second one. This is the third one, and this is the fourth one. After elements, what should I write? I need to write immediately after element, you have percentage composition. So write down percentage composition. Now, let's come back to this. Here what is given to you? Atomic mass is given to you. So atomic mass, write down. After that, you're going to take the ratio of these. So relative number of moles. So write down relative number of moles. The relative number of moles. This is also over. After this, simplest ratio, simplest whole number ratio. So I'm going to write simplest ratio here. Then I'm going to write simplest whole number ratio. With this, all the columns, simplest whole number ratio. All the columns are done. Now start copying the data. So in the first case, element. What are the elements given? Copy in the sequence. Don't make it random, please. Your formula again, you will get confused. First one, magnesium is given to you, Mg-Neistion. So the element is magnesium. Next is sulfur given to me, Sulphur, and the element is sulfur. Next, oxygen is given to me, oxygen element, symbol is O. Next, water is given to me. Okay, let us write water, W-A-T, water, and H2O. Nothing, don't change anything, please. Now, write the percentage composition. First one, magnesium, how much is given? 9.76. Sulfur, how much is given? 13.01. Right. Next, how much is oxygen given? 26.01 percentage. How much is water given? 51.22 percentage. Now copy the atomic masses. Magnesium is 24, sulfur is 32, oxygen is 16, fourth one hydrogen is 1. Now you are going to write the relative ratio or relative number of moles. This divided by this. This divided by this, this divided by this, this divided by this, this divided by this. So 9.76 divided by 24 in this case, 13.01 divided with 32 in this case, 26.01 divided by 16 in this case, 51.22 divided by 1 in this case. In the first one, when I solve, I get an answer of 0.406. In the second one also, I get the same answer, 0.406. In the third one, when I do, I get an answer of 1.625. In the fourth one, 51.22. Fine. Okay. That is right. It is 2.846. Here, what is the mistake which we have done? How will I get 2.846 wrong, isn't it? Here, the mistake which I did is, here atomic mass of hydrogen only was given to us. But what is this? This is water molecule. This is where everybody does, as I did a mistake. So here, water molecule, if I have to say, 18 is atomic mass of water. So divide by 18. Now this is right. So please don't do that blunder. This is water molecule, a single entity. I have picked up, I've done a mistake by taking only hydrogen. No, hydrogen 2 and oxygen 1 completely makes up 18 grams or 18 AMU. Now when I divide, I get an answer of 2.846. Now over. Now see the minimum value. Among all these, 0.406 is the minimum value. So take the simplest ratio, 0.406 divided by 0.406. I'll get 1. In the second case also, I am making the simplest ratio, divide these two, again I'll get 1. In the third case, 1.625 divided by 0.406. Yes, because that's the simplest ratio, I get an answer of 4. Here when I divide 2.846 divided by the simplest value, that is divisible value 0.406, I get an answer of 7. Now observe, all are whole numbers. When all are whole numbers, nothing to do with them. Directly write simplest whole number 1147. Now my work is over. I don't need this. Now I need to write the empirical formula for this. So you're going to write the empirical formula, full form, write completely. Empirical formula of the given compound. Given compound is, I don't have space, so I'm not writing completely. What is that? Start from here. First is magnesium, Mg symbol. Next is sulfur and oxygen. Yes, sulfate, isn't it? Why did I write sulfate, ma'am? How did you know OC4? Because here 16, right? So MgSO4, magnesium sulfate. Fine. After that, dot, water molecule, H2O. Right, so fine, let me write sulfate 16. I need to first write the formula. How much is magnesium? 1. How much is sulfur? 1. How much is oxygen? 4. So 4. How much is water? 7H2. You need to place it here. So magnesium sulfate 7H2O. Magnesium sulfate heptahydrate. That is your water of crystallization of magnesium. So this is the procedure for doing. Point number 1. These two datas are important. So 1, 2, 3 columns are over in that. In the second thing, 3 more columns you need to make. What is that? Relative number of moles. I said this divided by this. After that, you're going to take the simplest ratio. See the value which is easily divisible, the minimum value which is divisible. Take that number, you get a ratio. After that, see whether it is whole number ratio or not. If you see the whole number ratio, continue, apply. For magnesium, it is 1. For sulfur, it is 1. For oxygen it is 4 and for water it is 7. This is how you are going to do the sum. Right. So students, let's come back and do one more numerical which is based on your empirical formula. So here till now what do we do? They've given us the data. I've written a tabular column. From that you've got your empirical formula. Now we'll be calculating molecular formula also from empirical formula. Right. Let's read. What did they give us? What is the simplest formula of the compound which has the following percentage composition? Okay. They've given us two elements. One element is carbon. The other element is hydrogen. Percentage composition is given to us. Fine. And if the molecular mass is 30, calculate its molecular formula. Okay, that is what I need to do. So first of all, your step 1 should be calculation of empirical formula. Step 2 should be calculation of molecular formula. Let's start. First of all, let us make a tabular column. As I said, always first important thing, find out empirical formula, then go to the molecular formula. Let us write that. First finding out empirical formula, then finding out molecular formula. Fine. So in the first thing, always this first column will have the name of the element or the symbol of the element. So what did they give us? So this will be element. What is the element? Carbon. Right? I've written the symbol here. Next element is hydrogen. Fine. So in the first column after this, of the element name, you will have percentage composition. As I've explained in the earlier numerical, how much is carbon? 80%. How much is hydrogen? 20%. Now after this, immediately you will be writing the atomic mass of both. Right. So for carbon, atomic number 6, mass number 12. For hydrogen, 1 is a mass number. This is over. After this, you are going to take relative ratio or relative, you are comparing both the things, relative ratio of number of moles. So relative ratio of the number of moles, how much do I get? I am going to divide 80 by 12 in this case. Here, I am going to divide 20 by there is no number, it's only 1. So here when I divide, I get an answer of 6.66. Here in this case, I get 20. Now I need to find the simplest ratio. Right? In the simplest ratio, as I have told, you are going to see which is the minimum value. Here in both the cases, this is the minimum value. So you are going to divide by 6.66 divided by 6.66 in this case. In this case again, 20 divided by 6.66. Fine. So I'm going to get, when I solve the 6.66, how much do you get? This is 1, isn't it? And when I divide this, you get 3. Now simplest whole number ratio. So if you're not getting whole number here, you need to further do the simplest whole number ratio. But here already I have got simplest whole number 1 and 3. Now what is the formula? For carbon, the formula is C1. Now this is empirical formula. What is? This is C1. How much is hydrogen? It is H3. Done. So no need of writing 1 here because it doesn't make any value. CH3 is the empirical formula. Underline this. Please write it in full form. I'm not written. Now I need to find the molecular formula. So molecular formula, what is the formula? Molecular formula is equal to empirical formula into N. This is the formula. Now what is N? N is nothing but, if I have to write, N is nothing but the molecular mass by empirical formula mass. Okay, right. This is your third one. Okay, right. Let us take this as 1. Let's take this as 2. Let us take this as 3. One after the other we'll do. So what is molecular mass given? How much is N given? Molecular mass is 30 given. What is empirical formula mass? What do? You're going to take this empirical formula, calculate its mass. How much? Carbon mass is 12 into 1. Plus, how much is hydrogen? It is 3, isn't it? 3 into 1. When I take this, how much do I get? I am going to get 15 as a weight. Done. So this is the empirical. Once again, carbon mass number is 12 into 1 plus hydrogen mass number is 3. Number of hydrogen atoms is 3 into 1. So total 15. So I've got this part, isn't it? Molecular mass 30. I'm calculating this one. After calculating this one, I'm going to substitute in this. So 30 divided by 15, I get an answer of 2. Now I've got N value. It varies with every numerical, isn't it? Now take that N, substitute in this. So this is your friend. Now I'm going to calculate molecular formula. That is, how much is empirical formula? I got CH3 into 2. This is 2. That means carbon will become, the molecular formula finally is, carbon is C2. Hydrogen is 3 2s are 6. That's it. This is how we are going to calculate. So finally, what did we got? We have got two things. First thing is empirical formula. I got it as CH3. Molecular formula, I have got it as C2H6. So you're going to write in this way, and just this is the maximum they will ask you. Let us see any other type of numerical which are related to this. Right, let us come back and do one more type of numerical in your empirical formula. So basically what is this? Let us read the question first. So hope till now you would have understood. I need to calculate first always empirical formula, then I need to go to the molecular formula, isn't it? Yes. So here they've given us butyric acid contains carbon, hydrogen and oxygen elements. That's understood, right? And they said they've given some data. What is this? A 4.24 milligram sample of butyric acid is completely burnt in oxygen. Okay, combustion reaction happened, it seems. Then what happen? It gives 8.45 milligrams of carbon dioxide, 3.46 milligrams of water, right? What is its mass percentage? Okay, they've given us about carbon dioxide, they've given us about regarding water, but here what is the problem? They've not given us oxygen separately, because here I need to find the formula for carbon, hydrogen and oxygen, but here oxygen is combined, here also oxygen is combined. I need to find that particular mass, right? Then what is the mass percentage of each of the element? Right, determine the empirical formula and molecular formula of butyric acid. Molecular mass of butyric acid is given to us. Fine. So when I have to do such numericals, first of all, find out or take the common thing, that is the basic thing, basic data of oxygen, or sorry, of carbon dioxide, of water. From that extract out oxygen and then start solving the numerical. So for the first thing, when I have to solve the numerical, yes, yeah. Let's see. First of all, I need to calculate from like for carbon dioxide. Let's see. So in carbon dioxide, if I have to speak, first of all, let us calculate the weight of carbon. Why am I taking that? Because I need individual carbon. Yes. So what is this? 44 grams of carbon dioxide or milligrams of carbon dioxide contains how much? Okay, let us write mg. Okay, milligrams of carbon dioxide contain 12 grams of carbon. 8.45 milligrams contains how much of carbon? Then I'm going to cross multiply with this. 8.45 into 12 by 44, which comes to 2.30 grams. This is over. Now I need to calculate the percentage. Why? Because this 8.45 gram, but the total is 4.25 grams. The sample is 4.25 grams, milligrams. In that 8.45 was so much. So I need to find the percentage, isn't it? So I'm going to find percentage of carbon, right? So how much is that? 2.30 by 4.24 into 100. Then I've got a percentage. How much did I get? 54.24. Okay, I've got 54.24 percentage of carbon. Now let us find the same for hydrogen. So in terms of water, when I have to take, yes, water, what is the molecular weight? 18 grams. Okay, 18 milligrams rather, contains how many hydrogen, how much weight of hydrogen? 2 grams, isn't it? Now 3.46 grams, 3.46 milligrams contains how much of hydrogen? You need to find that first. For that, you're going to cross multiply in this way. 3.46 into 2 by 18. Then how much do you get? You get an answer of 0.384. Now I need to find the same percentage of hydrogen. Same percentage of hydrogen, right? Now see, 0.384, total is 4.24. Find the percentage. 0.384 divided by 4.24 into 100. How much do I get? I get almost 9.05. Because why did I get less? Because there's still oxygen present. I need to find. Now this is your carbon percentage. This is your hydrogen percentage. Now I'll find for oxygen. So percentage of oxygen. Or how do I do? Take the total 100 minus 54.2 minus of 9.05. Then when I do this, I get 36.4 percentage of oxygen, right? So finally I've got three compositions. One is carbon is 54.24, hydrogen 9.05, then your oxygen 36.4%. Now with this data, I need to calculate the molecular formula. Finally, before that, I need to calculate the empirical formula. Let's come back and do that. Now let's come back and do next type of numerical. That is, here the concept of vapor density is given. The same concept. We need to find the empirical formula, molecular formula, but only thing is vapor density is given. So what is given? An organic compound on analysis gave the following data. In that organic compound itself, carbon percentage is 57.82%. Hydrogen is 3.6 and the rest is oxygen. Fine. So let us start. Let us write the given data. Let us write step 1. So in step 1, my aim is to first calculate empirical formula. From here, I'll go to molecular formula. So let us write the step 1. Let us make a tabular column, very vague line. I'm sorry for that. Yes. So in the first step, what will I write? I'll note the elements. First, carbon. What is the percentage of carbon? 57.82. Next, hydrogen, 3.6%. And oxygen is rest. That means 57.82 plus 3.6. That total minus 100. How much do I get? I get 35.8%. This is over. After this, I'm going to write the atomic masses of all. So atomic mass is equal to, for carbon it is 12. For hydrogen it is 1. For oxygen it is 16. Now I need to find the relative ratio for getting the number of moles. You're going to divide this by this, you're going to divide this by this, you're going to divide this by this. When you divide the first case, 57.82 by 12, how much do you get? You get 4.818. In the second case, 3.6 divided by 1, 3.6 only. In the third case, 35.8 divided by 16, you get answer of 2.40. Now I'm going to find what the simplest ratio. For the simplest ratio, I'm going to see which is the minimum value. This is 2.40 is the minimum value. Now divide 4. Okay, let us take out this line. I need some more place. 4.818 divided the minimum value 2.40. The second case, 3.6 by 2.40. In the third case, 2.40 by 2.40. I'm trying to get a simple whole number ratio. That's it. So when I divide this, what I'm going to get here in this case 2. In the second one, 5. 1.5. In the third case, 1. Okay. Still, I have not got the simplest whole number ratio because this is 1.5, isn't it? Fine. Now, simplest whole number ratio. So to make it simplest whole number ratio, just see with which number if I multiply, I get a simplest whole number ratio, isn't it? Suppose if I multiply everything with 2, let's see, this also 2, this also 2. Yes, let us start with 2. Suppose if I multiply with 2, this becomes 2 2s are 4, simplest whole number ratio. 1.5 into 2, 3. Simplest whole number ratio. 1.1 into 2, this is 2, simplest whole number ratio. So I've got 432. This is the simplest whole number ratio. Now I've come to a conclusion of empirical formula. So what is empirical formula? So carbon is equal to C4, hydrogen is equal to H3, oxygen is equal to 2. This is your empirical formula. Now I need to calculate what? Molecular formula. So molecular formula, what is this? Molecular formula is equal to empirical formula into N. What is N? I said N is nothing but molecular mass by empirical formula mass. Is any molecular mass given to us? No. Here they've given us vapor density. Fine. So once again, one more formula. Molecular mass is equal to 2 into vapor density. This is the formula. Fine. So now see. 2 into 83. How much do I get? I get 166. Isn't it? So this part is over. Molar mass, I got 166. Let us keep this aside. Later we will write. Let us find first. So molar mass I've got 166. Now let us find empirical formula mass from here because I want that data. So hope you would understood this. I have linked vapor density with the molar mass. I got this answer. So if I have to see 4 into 12 plus 3 into 1 plus 2 into 16. When I solve this, I get an answer of 83U. Now take this, divide, because empirical formula mass I got it here, molecular mass I got it here, so 83. So how much? It goes twice. Now I got almost done with the numerical. The final step is I need to find the molecular formula. This is N, no? Nothing but N. So what is molecular formula? Empirical formula into N. How much did I get? I got C4. C4H3O2 into 2. What do I get? I get 4 into 2, 8. 3 into 2, 6. 2 2s are 4. So this is your molecular formula. So now I've got two formulas. What is that? First one, empirical formula is equal to C4H3O2. Molecular formula is equal to C8H6O4. This is your answer. This is how you're going to find. Right. Let's come back and see the last type of method of calculating empirical formula. Fine. Let us read. So pure sample of a compound is found to contain 2.04 grams of sodium. Okay, a sample has contained 2.04 grams of sodium in that instance. Right. Next component is 2.65 into 10 raised to power 22 atoms of carbon. Very interesting. They have combined everything and given to us. And 0.132 mole of oxygen atoms. So mole is given. They've given us atoms, they've given us weight. Determine the empirical formula of the compound. Right. So first of all, when such compound, some question is given to you, to find empirical formula, you need to have the percentage. That is one thing. Okay, they've given it in a different way. Atomic masses, you know, fine. And you need to finally get the whole number ratio. Then only you can frame an empirical formula. So let's see how can we do this. First of all, in this particular numerical, the method for doing or calculating empirical formula is calculate the number of moles or the number of gram atoms for in each case. So first of all, for calculating number of moles, okay, for sodium, I'm getting first for sodium. What is sodium? That nothing but your weight by gram atomic weight, isn't it? How much is this weight? 2.04 divided by 23. Gram atomic weight of sodium is 23. The atomic mass rather. When I solve this, I get an answer of 0.0887. This is for sodium. Now I've got the number of moles because I need to find out the whole number ratio. Next comes your carbon. When I have to take carbon, what is given? They've given us 2.65 into 10 raised to 22 atoms. But we very well know 1 gram atom of carbon contains how much? It contains 6.022 into 10 raised to 23 atoms or particles, isn't it? Yes, so here atoms is given, this is also atoms. Both should be similar. When I cancel this, I get an answer of 0.044. This is for carbon. This is over. Yes. Now next is oxygen. Oxygen directly they've given us mole, not a problem. Here I've got moles of this, here I've got moles of this. Here oxygen directly they've given moles, that is 0.132 moles. This is done. Yes, now I'm coming almost closer to now I can easily find the ratio. So when I have to find the simplest ratio, see which is minimum. Which is a minimum value? 0.04 is a minimum value. Now divide. 0.0887 divided by, okay, you can also take the ratio first of all. Let us see. Is to 0.044 is to 113. Now for us, finding the simplest whole number ratio. Now this is simplest ratio. I need to find simplest whole number ratio. Then divide with the minimum value. In this case, this is the minimum value. So 0.0887 divided by 0.044 is to 0.044 divided by 0.044 because that's a minimum value is to this one 0.132 divided by 0.044. That's over. When I cancel this, I get 2. is 2. Here 1. Here when I cancel I get 3. Now over, isn't it? I have come to a formula. Now apply. What is the first element? Sodium. So sodium, what did I get? Na2. Second element is what? Carbon, C. Third element is what? Oxygen, CO3. So this is your formula. We have already got from that ratio, from that number of moles in atoms that I have calculated, I have got this. The final empirical formula is Na2CO3, that is sodium carbonate. Right. Now we've got the percentages. Let us start calculating the empirical formula and molecular formula. So let us write this as step 2. So in step 2, what should you do? First, let us try to make a tabular column. Fine. So in this tabular column, okay, I need a bigger column. Yeah. So in the first one, the first column is always what? Elements. What are the elements given? Carbon, hydrogen, oxygen. Carbon, hydrogen, oxygen. Now after this, the second step would be the percentages which you have got, which you have calculated already in step 1. First one, carbon is 54.24. Hydrogen is 9.05. Your oxygen is 36.4. Done. Immediately as soon as you write the mass percentages, you need to write the atomic masses of all. So in this case, carbon atomic mass is always 12 grams. Hydrogen 1, oxygen atomic mass 16. Yes, done. Now I need to find the relative ratio of number of moles. Okay, right? Why did I write this? Because weight by molecular weight, isn't it? That is nothing but number of moles. Fine. So when I divide this by this, how much do I get? I'm going to get an answer of, okay, let me write 54.24 divided by 12. I get an answer of 4.52. Done. Fine. In the second case, 9.05 divided by 1, it is only 9.05. In the third case, 36.4 divided by 16, I get an answer of 2.29. Right. Fine. Now I need to find what? Simplest ratio. For finding the simplest ratio, what is the rule? You need to see whichever is the minimum value, so which is divisible. So take this value, so 4.52. Here minimum value is 2.29, so you're going to write 2.29. Here 9.05, you 2.29. In this case, 2.29 by 2.1, just to get a simplest ratio. I'm trying to simplify the ratio. Simplify it so that I get a simplest whole number ratio finally. So when I divide this, I get an answer of 1.97. Here when I divide the second one, I'm going to get an answer of 3.95. In the third case, I'm going to, okay, nothing, 1. Now finally, I need to write simplest whole number ratio. Here all are in decimals. I need to make it in whole numbers. So 1.9 I can write it as 2. 3.9 I can write it as 4. 1 is like that. Now I can now make empirical formula. What is empirical formula? Carbon is 2, C2. Hydrogen is 4, H4. Oxygen is only 1, O. So nothing to write. This is over. Fine. So now immediately as soon as you get empirical formula, try to calculate the empirical formula mass and keep it ready. Fine. So immediately empirical formula mass. So how much is this? 12 into 2. Mass into this plus, you can write it like this also, 4 into 1. Oxygen is 16. Total how many? 44 atomic mass units, grams. Fine. Gram per mole rather, if I have to say. Done. I've got this answer. Now come back. I have to find out what they've asked me to find out empirical formula. I did that. Then they've asked me to calculate molecular formula. So molecular formula is equal to empirical formula into N. But what is N? N is nothing but molecular mass by empirical formula mass. What is molecular mass given? 88U. So 88 divided by your 44. So how much do I get? I get 2. Okay, let us erase this. Okay, I have not got my duster today. I just kept. Okay, 2 I have got. So how much is this? N. Now substitute this N in this. Why am I doing that? Because I need to find the molecular formula. Yes. So molecular formula, when I do What is here? Empirical formula is how much? C2H4O into 2. Now multiply, this becomes C4. Hydrogen becomes H8, oxygen becomes 2. So this is your molecular formula. So I have got both. Now empirical formula which I got is C2H4O, done. Second molecular formula which I got is C4H8O2. This is the thing. So this is your first answer, this is your second answer. This is how you're going to do. Right, after your laws of chemical combinations, let us come back to the next topic, that is different types of masses. So when I have to speak about different types of masses, this is an introduction chapter in chemistry, so you'll have the basic things like what types of masses we have. So when we have to speak about the different types of masses which you are going to use in chemistry, the first type of mass which we are going to learn is how to calculate atomic mass. After that, we will also be learning how to calculate molecular mass. Right, fine. Apart from that, in the atomic mass only, you're also going to learn about average atomic mass for isotopes. And let us write average atomic mass for isotopes. Fine, done. So after this molecular mass, we are going to learn about formula mass. Fine. Then next, we are going to learn about equivalent mass. Equivalent mass. After this, I'll also be teaching you how to calculate gram atomic mass, gram molar mass. So let us write GAM. What is this? This stands for gram atomic mass. The next one, GMM. This stands for gram molar mass. Fine. So 1, 2, 3, 4, 5, 6, 7. All the 7 types of 7 types of masses you need to know how to calculate. Right. So now let's come back and learn the first type of mass, that is atomic mass. So know what, basically you have a definition to remember. What is that? So atomic mass is when I have to measure, or when you write the units of atomic mass, it is either measured as AMU, that is atomic mass unit, or nowadays we are measuring it as U. U stands for unified mass. Once again, AMU is atomic mass unit, or U. Whenever you're writing like sodium atomic mass, 23 grams or 23 U, in that way. So when atomic mass concept has come into picture, they've picked up carbon 12 isotope as a standard thing. So the standard unit which they've picked up is carbon 12 isotope. Now what is this? This carbon 12 isotope they have given, or arbitrarily. What does it mean of arbitrarily? Arbitrarily means randomly they have decided what is it as a standard. How much is this given? This carbon 12 isotope, he is assigned with 12 AMU units. Okay, what am I trying to explain? I'll tell you. So basically, atomic mass unit, if I have to define, let us write the definition first. Yes, atomic mass is equal to 1/12 of the carbon 12 isotope, or 1/12 of the mass of carbon 12 isotope. What is that? We have taken carbon 12 isotope as a standard, and we are comparing the mass of one atom to 1/12 of the carbon isotope. Fine, let us write what we said. Atomic mass is equal to mass of one atom of an element. Okay, this is any element, anything. We are comparing with what? We are comparing with divided by 1/12 of which one? With the standard carbon, 1/12 of mass of one carbon atom. Which one is that? C12. Right? That means when you're calculating the mass of this, you're comparing the carbon 12 isotope. So now when I have to write in this, okay ma'am, I don't remember all this, what actually is atomic mass? Simple. 1U is equal to 1/12 of carbon 12, I said 1 by 12 into, right, to cancel this, okay, atomic mass of carbon is 12 grams divided by 6.022 10 to 23 atoms. Fine. So finally, when I have to calculate, when I calculate this, I get 1 divided by 6.022. I'm going to get an answer of 1.66 into 10 raised to the power of minus 24 atoms. Fine. So this particular thing, what should you remember? Atomic mass. Basically, if I have to speak in common terms, right? Lithium. What is atomic mass of that? Atomic number is 3, mass number is 6. Sodium, atomic number 11, mass number 23. Phosphorus 15, 31. Helium 2, 4. So nothing but you're just calculating and comparing with carbon 12 as a standard isotope. Right. So the next type of masses, that is average atomic mass. So now, how are we going to write this? What is it? Basically, this is, okay, average relative mass is equal to, or it is compared to which one? Carbon 12 isotope. How much did we take? We have taken this as 1 AMU, that is 12 AMU rather, right? So average relative mass is equal to the carbon 12 isotope, which we have taken as standard. Okay, how is this represented? We write it as average atomic mass is equal to, the formula is, right, so we're going to write m1 x plus m2 y plus m3 z divided by x plus y plus z. What are these? Let us take an example. So basically we are going to speak about this average atomic mass only with isotopes, right? So hydrogen has isotopes, protium, tritium, deuterium, chlorine has isotopes, both the isotopes. Let us take that. So basically when I have to speak about isotopes, I'm going to write about chlorine isotope, the basic example. So when I have to take chlorine exists as two types of isotopes. What is that? What isotopes? Isotopes are those elements which have the same atomic number but different mass numbers. So first chlorine isotope is 35, second chlorine isotope is 37. Fine. So now in nature, the existence or the abundance of this particular isotope is 3:1. This is 3 and this is 1. Now what are these? Let us write. So in the first one, average atomic mass, if I have to take, yes, fine, let's see. M1 is the mass of this particular chlorine atom, atomic mass, 35 into how much is its existence, right? So x1 is 3 plus m2 is 37. How much is this existence? Into 1 divided by x plus y plus z. This is nothing but x, the coefficients, this one, 3 plus 1. So finally, when I divide this, multiply and everything, I get an average atomic mass or isotopic mass. We also call it as average atomic mass or average isotopic mass. Isotopic mass. How much is this equal to? This is equal to 35.5. So what is this? U. You should write it as unified mass or AMU. Whenever you're measuring the mass, I said you're comparing with this, which is equal to 1 AMU or 12 AMU, as I said. So it is equal to 35.5. So this is your average isotopic mass. Right. So students, we've already seen the concept of molarity, isn't it? Yes, we've learned the formula and how to go about with that. We've already seen. So let us start solving important numericals of molarity. Basically, your molarity concept, finding a concentration, the n number of numericals which are related to this concept, and we'll be doing one after the other, both your NCERT questions as well as your comprehensive questions. Fine. So let us read the first question. So when I have to go with the first question, let us see what did they give us. Calculate the mass of sodium acetate, that is the formula given to us here, required to 500 ml, okay, required to like 500, like there's a small word missing, isn't it? So let us read again. Calculate the mass of sodium acetate required to make this. There should be a word here, make. Okay, make 500 ml of 0.375 molar aqueous solution. Molar mass of acetic acid, sodium acetate is 83.02 gram per mole. So basically, what did they ask me? They're asking me to calculate the mass. Fine. So for such things, first of all, when they have given you such data, try to first note what is given to you. So what should you find out? I need to find mass, right? So what else is given to you? They've given you the molar mass of solute, isn't it? See here, this one. They've given you molar mass of solute. Molar mass of solute. How much is given to you? Solute is nothing but sodium acetate. It is given 82.0245 gram per mole. Okay, right? Gram mole inverse or gram per mole. Then what else is given? Volume is given to you. Volume, how much is given? Volume of what? Volume of solution is given to you. Volume of solution is equal to 500 ml is given to you. Done. Fine. So I should find mass of solute, isn't it? This is nothing but mass of solute. So let us come back and write the formula. Fine. So anything else is given? They've also given molarity. See here, calculate the mass of this one. So of 0.375 molar aqueous solution. Molar aqueous solution is nothing but molarity. Molar aqueous solution means molarity, that is 0.375 molar, capital M. Right. So let us write the formula first. According to the formula, molarity is equal to W into mass of the solute, isn't it? That's mass of the solute by the volume of the solution in liters, isn't it? So what is that? Mass of the solute can be written as weight by molecular weight, right? Then small m. Let us write this into volume of the solution. So volume of solution. Fine. So this solution is in ml, and now weight by molecular weight into 1000. Right. So fine. So now substitute the values. Now what do we need? We require this mass, isn't it? So what do we require? We require the weight. This weight. Molar mass is already given. So I require this weight. W I require. So when I take this mass of the solute, fine. So when I take this W out, I'm getting this W out. I'm cross multiplying molarity with this. Okay. This W out and this molarity out. Fine. W is equal to molarity is how much? Molarity is nothing but 0.375. This is the mass which they have asked, and after that into how much is the molar mass given to us? It is nothing but 82.0245 into what is the volume of the solution given? 500 ml. 500 ml divided by 1000, isn't it? This goes down 1000. So how much do I get? I'm going to get an answer of 15.379 grams. That is nothing but, if I approximate this, because the significant number is more than 5, this becomes 15.38 grams. That's it. This is your first numerical. Hope this is clear to you all. Fine. So let us see the next question in molarity. So here in the next question, what do they give us? Right, let's read. Calculate the concentration of nitric acid in moles per liter. Okay, in moles per liter. Fine. This is the same sentence which is repeated, in moles per liter, in which one? In a sample which has density of 1.41 gram per milliliter, and the mass percentage of nitric acid in it being 69%. Fine. So let me first write what is given to us. So in the given data, yes, what's given? Density is given 1.41 gram per liter. Right, then what did they give us? What should I calculate? I need to calculate the concentration of nitric acid in moles per liter. So concentration of nitric acid in moles per liter means, what does that mean? Right, basically they are asking us they're asking us to find the concentration of nitric acid, like means they've given the units, right? They're asking us to find the molarity only, nothing else. Fine. Moles per liter unit is nothing but for molarity, isn't it? Fine. So that is what they're asking us. Fine. That's okay. Now I need to find capital M. Then after that, is there anything else given? They've given us mass percentage also. See here, mass percent of nitric acid is being given 69%. So mass percentage, what does it mean? That means 69% HNO3, right, means 100 grams of solution. What does this mean? 100 grams of this one contains what does it contain? It contains 69 grams of HNO3. This is what it means. Fine. So what is mass of HNO3 now? Yes. So mass is equal to 69 grams. Okay. Fine. So let us find the molar mass. I need to find molar mass because of molarity formula. I need molar mass also. So molar mass for HNO3. Molar mass of HNO3. How do I calculate this? I calculate molar mass. First mass of hydrogen is 1.0079 plus. What is the mass of nitrogen? 14 plus 3 into 16. How much do I get? I get come to 63.01 gram per mole. Okay, I got molar mass. So everything. Now let's come back. What is the formula for molarity? Molarity is equal to moles of the solute. That's the mass of the solute, isn't it? Right? That mass is equal to weight by molecular weight into 1000 by volume of the solution, right? Isn't it? Yes. So did they give us anything? They've given volume. They've not given us volume. They've given us density. So calculate density is equal to mass by volume. Let us write this as step 1. Let us write this as step 2. Density is equal to mass by volume. So cross multiply this volume. Volume is equal to mass by density. How much do we get? What is the mass given? 100 grams, isn't it? 100 grams divided by how much is the density given? 1.41. So how much will this come up to? Okay, we can directly leave that and calculate. Fine. So now substitute volume. Now substitute what is the weight of this one which they've given? Nitric acid, because this is for the solute, isn't it? This is for the solute. This is for the solution, isn't it? Fine. So weight of solute, how much did it? 69 into 1000 divided by what is the mass? This one. Okay, 63 grams, which we have got 63.01 into what is a volume? It is, volume is 100 grams. 100% means 100 grams, isn't it? 100. Okay, so here we have already got this volume 100 into, this is already there, into 1.41, because volume is 100 by 41. When it goes, it becomes the reverse. When I solve this, I get an answer of 15.43 molar. This is what is the answer, right? Hope this is clear to you all. This is how you're going to do. First, see what data is given to you all and see what to calculate, and after that write the formula and substitute in the formula. Right. Now let's come back and do the next sum, which is related to your molarity. So we have seen two combinations. Now let's see the next one. So in this question, what did they give us? Here again, they've asked us, this is, as I said, all these are molarity numericals. Let us read the question first. What is the concentration of sugar, that is your C12H22O11, in mole per liter? Fine. If it's 20 grams are dissolved in enough water to make a final volume of up to 2 liters. Right. So first of all, they are asking us to find concentration of sugar. So the concentration, what we are speaking concentration in terms of molarity here, isn't it? Yes. So I need to find the concentration, of this particular thing. Simple. It's a direct question rather, if I have to say. First of all, so when I have to find the molarity concept, first of all, let us write the formula. So molarity is equal to weight by your molecular weight into volume in liters. This is what is your formula, isn't it? Now let us write the data which is given. So let us write given data and substituting the formula. When I have to see, first of all, what do we require? Do we have weight here? Yes, W is given to us 20 grams. W is equal to 20 grams is given to her. Did they give us your mass or volume? Okay, volume, we'll see. Volume is given to us enough water to make up the final volume to 2 liters. Okay, they've given us volume as 2 liters. Already this is in liters, this is also in liters, not a problem. And after that, did they give us molecular mass? Okay, molecular mass. This mass is not given to us. That mass I'm going to calculate for C12H22O11. How much is this? C12H22, it's nothing but 12 into the mass of carbon, right? Fine, 12.01 rather, plus 22 into 1.007 of hydrogen, plus 11 into 16 of oxygen. Total this comes to 342 gram per mole. Okay, all are ready. I can directly substitute in this, isn't it? Yes, let's substitute. How much is the weight? 20. How much is the mass given to us? Your calculated mass. It is 342 into 2, because everything is in liter. So when I calculate this, when I solve this, I get an answer of 0.02092. Fine. So here, what are the units? The mass is in gram per mole, isn't it? Yes, weight and this and gram per mole and gram per mole. This is also in grams. This is gram per mole. Fine. So this grams and this grams gets cancelled. So what are we left with? Only mole. Mole per liter. So what are the units here? Mole per liter. This gram and this gram gets cancelled. This is already mole. This is already liter. When this goes above, this becomes mole per liter. Fine. So this is your answer. So finally, how can you write this? 0.0292 molar solution. This is what is. This is how you're going to explain. Hope this is clear to you all. Yes. Let us come back and see the next question. Fine. So here in the next question, this again, as I said, we'll be doing one more molarity numerical. All these are molarity numericals, different variations of molarity numericals. Right, now let's start solving this numerical. First of all, let's calculate the mass percentage. Fine. So percent by mass and mass percentage, both are the same. When I have to do the first part, let us just solve the first part and see. Explain this mass percentage. What actually is mass percentage or percent by mass? A mass of the solute by mass of the solution into 100. That is what is mass percent. But here, what did they give us? They've given us 15 ppm. They've given this. This is what is given. Contamination by 15 ppm by mass. That is why I'm picking up this concept. 15 ppm is nothing but 15 parts. 15 parts in 1 million. That is 10 raised to 6 parts. This is what is 15 ppm means. Right? So let us write. Now percent mass. Percent by mass. When I have to calculate. Yes. So mass of the solution they've given here in terms of 15 ppm means I have already written this, pick that thing here, 15 okay into 100 is already there because it is a percentage divided by 10 raised to 6. So how much do I get when I solve? I get here an answer of 1.5 into 10 raised to minus 3 percentage. This is your ppm. Fine. Let's come back and do the next one. Determine the molarity of chloroform in water sample. So when I have to determine the molarity, yes, so let us do the second part. So molarity, what is the formula? Weight by molecular weight into 1000 by your by volume into volume of sample. Okay, volume of sample. So what data is given to us here when I have to see? Fine. So let us see whether weight is given to us, right? So they've given here basically a sample of drinking water here in this particular equation. They have written like they've given sample of drinking water was found to be contaminated, carcinogenic. Only mass is given, nothing else is given to us. Fine. Okay. So now I can easily start with this numerical. Why? What am I trying to tell you? It's a contamination in water. That means, fine. So here your already mass we have got, isn't it? What is the mass? That is your mass percentage. This molarity, that mass I can directly substitute into 10 raised to minus 3. This 1000 is also there divided by, yes. This is what is the molar mass of this? Molar mass of which one? This is chloroform contamination. This set. Fine. So chloroform contamination means I can easily find, isn't it? So CHCl3. How much is this? Carbon comes to 12 plus hydrogen is 10079. How much is chlorine? 3 into 35.5. Okay. When I solve this chloroform, I get an answer of 119 gram per mole. Okay, this is what is your weight. So substitute that value 119 gram per mole, that is your 119 into volume of the sample is 100 ml, because they've given parts per million, that the thing they've given, isn't it? So into 100, done. Fine. So why did I take this? Because 1.5 into 10 raised to minus 3. 1.5 10 raised to minus 3 means 1.5 10 raised to minus 3 grams are present in 100 grams of sample. That is what is that? Parts per million is that only. Right. So that is why I've taken 100 here. Right. When I solve this molarity, I get an answer of 0.000 0.0126. Further, when if I have to write, molarity is equal to 1.26 into 10 raised power of minus 4. Hope this is clear to you all. They have given parts per million. First, you need to convert the parts per million. This is nothing but, as I said, it is 1.5 into 10 raised power of minus 3 percentage. It's nothing but, when you write in grams, 1.5 into 10 raised power of minus 3 grams present in 100 grams. This is present in 100 grams. That the same concept I have applied there also. Fine. So let us do the next numerical, which is based on molarity. Fine. So here there's one reaction given to you all. Basically, these are all comprehensive numericals. Let's do reaction 2Br minus aqueous plus Cl2. Aqueous gives 2Cl minus plus Br2. Okay, is used for commercial preparation of bromine from its salts. Okay, if we have 50 ml of 0.060 molar solution of NaBr, what volume of 0.050 molar solution of chlorine is needed to react completely with Br minus ions? Okay, fine. So basically, they've given us a lot of information here. They've given us your M1, they've given us like your V1, they've given us M2. I need to find V2. Okay, let us write what actually are this. Fine. So first of all, when such question is given to you, write the formula which you're going to use. How did I know that it is M1, V1? Basically, they've given different molarities, isn't it? Here molarities are given, volume is given. They're asking us to find the other volume. So that is the reason I could predict that formula. Fine. So first of all, let us take the formula M1 V1 is equal to M2 V2. Right, but here they've given one question here, reaction here, isn't it? Suppose if I assume, let us take this M1 V1 in terms of your Br, because it is the stoichiometric equation is 2, isn't it? So I'm taking this as 2. Let us take your M2 V2 in terms of chlorine. Okay, right. So here chlorine, how much is chlorine? It is only 1, isn't it? So 1. So take this relation in this way and see. Fine. Now let us write what information is given. Here they've given us M1 is equal to 0.060. This one, this M1. Fine. How much? What is V1? V1, I need, okay, for V1 how much did they give you? 50 ml of 0.060. So V1 is 50 ml. How much is M2 given? M2 given is 0.050 mole liter inverse. Okay, so M1 also mole, the same thing, 0.06 mole. Molarity is nothing but mole per liter inverse only, you know. Yes. So V2 is how much? I need to find. So let us come back and substitute in this formula. So take these values. V2 is equal to, now cross multiply this. What do you get when you cross multiply this whole thing? It becomes a reverse order, isn't it? So V2 becomes M1 V1 by 2 into 1 by M2. Correct? Yes. So substitute the values now. V2 is equal to M1 is how much? 0.060 into how much is V1? 50 divided by 2 into how much is M2 here is 0.050. So finally V2, how much do I get? When I solve, I get volume of 30 ml. This is your answer. This is how you're going to do the sum. So hope this concept is clear to you all. I'm gradually doing all the varieties of numericals which you should be practicing for molarity. More than this you will not be questioned. So try to practice all the types of molarity numericals at one stretch. Yes? Yeah. So let's come back and see the next variety question. Here they've given us molarity and normality. Both the concepts are linked here in this case. So let's read the question. How much volume of decamolar solution of sulfuric acid is required to prepare 500 ml of solution with density 1.03 gram per liter and having mass percentage equal to 40%? Fine. Also calculate the molarity and normality of the resultant solution. Fine. So here I need to find both molarity and normality. So first of all, you should know the formulas of these two. Then only you will be able to do the sum. Fine. So first of all, molarity. Fine. Normality, molarity, both the formulas will write. But here you should one thing remember. They've given a density. I've taken one class where I said relation between molarity and density. There's one formula also directly given. I'll write that formula first so that I can easily apply. So for molarity, there's one formula as I said just now. Molarity in relation with density. What is that? Molarity is equal to percentage into 10 into d by molarity of the given sulfuric acid. Fine. So the second one, when I have to speak about normality formula is molarity into molecular mass divided by equivalent mass. This is one more formula. Now let's substitute here. In this case, what do they give me? What is the percentage of this one given mass equal to 40%? They're given 40 into 10. How much is the density given? Direct substitution. 1.03, right? How much is the molar mass of sulfuric acid? This is for sulfuric acid, isn't it? We're speaking in terms of sulfuric acid. Sulfuric acid molar mass is 98, isn't it? So how did I calculate sulfuric acid? Like that. So 2 into 1 plus 32 is the molar mass of sulfur plus 4 into 16. I got 98 gram per mole. This is okay. Yes. Now substitute the value here. You get 98 gram per mole. When you divide this whole thing, you get an answer of 4.20 mole per liter. Okay. This is over. The molarity value you've got. Fine. So now one more thing. What did they say? Okay, volume of decamolar. They said how much volume of decamolar solution they said. Fine. So volume of decamolar. So decamolar is nothing but 10 moles, isn't it? 10 molar sulfuric acid B. Right. So then what can I write? So that decamolar, if I take volume into 10. So how much is the volume given to us? They've given 4.2. Isn't it? Yes. So I've got means the volume which I've got that particular thing volume into 10. That means what am I trying to explain? I'll show it in a subject. What am I trying to explain is let the volume of decamolar is nothing but 10 molar. Okay, deca means 10, isn't it? Decamolar sulfuric acid solution, okay, required B, that will be VML. Fine. That means V into 10 is equal to 4.2 into 500, isn't it? Okay. So why am I finding? I need to substitute this value in my normality also, isn't it? Right. So V is equal to 4.2 into 500 divided by 10. How much do I get? I get an answer of 210 ml. Okay. Now, second, because I need to find for this one, isn't it? Equivalent mass, nothing but your basicity by your this one, the base divided by the mass divided by the molar mass divided by the basicity, isn't it? Yes. So that's why I'm trying to find this value. So 210 ml I've got. Now, what is basicity? Basicity of sulfuric acid, H2SO4 is 2, isn't it? Yes, 2 ionizable ions. Fine. So now equivalent mass you calculate. Equivalent mass sulfuric acid is equal to molar mass divided by basicity. It comes to 49. Now it's easy for me to substitute. Normality is equal to molarity into molar mass divided by equivalent mass. Now what is molarity? I got 4.2. What is the molar mass of sulfuric acid? 98. What is the equivalent weight? Which I got 49. So when I calculate, I get an answer of 8.4 normality. This is how you are going to do the sum. This is directly molarity in relation with density is one numerical. Next one is a normality. Fine. Hope this is clear. Let us come back and do one more sum. Keep noting it and you keep solving numericals. When you start solving more number of numericals, your concepts will be clear. Yes. So let's do this. Next question. Commercially available concentrated HCl contains 38% of HCl by mass. Okay. What is the molarity of this solution? Density again is given, same variety of question. What volume of concentrated HCl is required to make 1 liter of 0.1 molar HCl? Okay, fine. So in this question, what should you do? You need to find the molarity, and you should also need to find the volume, isn't it? Yes. So let us do step by step. So first of all, molarity, as I said, when density is given, what formula can you apply for molarity? Molarity is equal to percentage into density into 10 divided by molar mass. This is one formula which you can apply. Fine. So let us see. Now in this case, percentage, how much they give me? They've given 38%. So right now 38. How much is the density given to us? It is 1.10 into 10 divided by what is the molar mass? Molar mass of what? Of HCl, isn't it? HCl is nothing but 36.5. How did I get this? Hydrogen is 1 plus chlorine is 35.5. So this comes to 36.5. I have got this. So how much is the answer? When you divide this, you get molarity is equal to 11.45 mole per liter. This is over, isn't it? Okay, now done. Now I need to find the volume. First part is over, second part I'll do it. What volume of HCl, concentrated HCl is required? So when I'm asked us to find the volume, right? So in the second concept, we have molarity equation, isn't it? So let us write according to molarity equation. What is molarity equation? Molarity equation is M1V1 is equal to M2V2. Now M1V1 will take it for concentrated HCl, M2V2 will take it for dilute HCl. Okay, yes. So what do we require? They've asked us to find what? They've asked us to find what volume of concentrated HCl I require. So they're asking us to find out what volume I need to find. So okay, sorry, I need to find this volume. So when I take out this and substitute the leftover values, I get an answer, this one as 0.1 into 1.0 by 11.45. So this comes back to 8.73 into 10 raised to minus 3 liter. If I have to convert in milliliter, 8.73 milliliter. That's it. This is your volume of concentrated HCl V1. This is how you're going to do this. Yes. Hope this is clear. Concept is clear. I'm trying to do all types of numericals. Please try to practice it. Fine. Let's come back to one more question. So in the next question, yes, a sample of sodium hydroxide weighing 38 grams is dissolved in water and the solution is made to 50 ml in a volumetric flask. Okay, what is the molarity of the resulting solution? Fine. How many moles of sodium hydroxide are contained in 27 ml? Okay, so in this particular question, fine. What did they give me? What should I find out? I need to find out first of all molarity also. Then I need to find out how many moles also. So both the concepts are given to you. Right? We'll do step by step. First of all, moles of sodium hydroxide. Let us do that and then come back. Moles of sodium hydroxide in 50 ml. Okay. Because I'm from the known, we are going to the unknown. In that way, we'll go. So let's see. I have to solve this. Moles of sodium hydroxide in 50 ml. What is this? What is mole? Mole is nothing but weight by molecular weight. Weight of sodium hydroxide by molecular weight of sodium hydroxide in grams. So weight of sodium hydroxide is how much? 38 grams. That given, isn't it? See here. A sample of sodium hydroxide weighing 38 grams. So 38 grams divided by molecular weight of sodium hydroxide is 40 gram per mole. This is also over. These two are over. So this is your number of moles. So when I what did they ask us? Now moles of 1 liter of solution. Because how many moles are contained in this, isn't it? Okay. Now when I have to take now moles of sodium hydroxide in 1 liter solution. The same thing. Let us find moles of, therefore moles of NaOH in 1 liter solution, right? Fine. So 27, there's some information also missing, isn't it? 27 ml of 0.15 molar solution. Okay, this is important. Okay, I've left this data. Okay, So now substitute. This is there in 50 ml. So the 1 liter, if I find 38 by 40 into 1000 by 50. This is for 1 liter, isn't it now? Yes. So how much does come to? 19 mole per liter. Done. So now this is over. Fine. So now I need to find for this, the second, this one, they have given 0.5 molar. So we have got one answer for 1 liter. Okay. 1 liter, we have found this coefficient. Now we'll see for 27 ml. Right. Let's see what am I trying to tell you. 1 liter of solution. Now they said, now I standardize this to 1 liter. The second concept is, they said, according to the second one, 1 liter of solution, which one of sodium hydroxide NaOH contains 0.15 moles. Okay, so 27 ml rather. 27 ml of solution contains how much? Isn't it? How much? So cross multiply 0.15 into 27 by 1 liter means 1000 ml. This is equal to 4.05 into 10 raised to minus 3 moles. Okay, this is how you're going to do. So start from your known factor, and then come back to the thing which you need to find out. Yes, so this is over. So let's come back and see the next question. Right, let's come back and do the next variety of numerical that's based on your molarity. Fine, let's read the question. Fine, so what did they give us? If the density of methanol is 0.793 kilogram per liter, what is its volume needed for making 2.5 liters of its 0.25 molar solution? Okay, so basically when such numerical is given to you, right, you should have a clarity of what data is given to you, where to substitute, what to calculate. So first of all, in this particular thing, let us write the given data. So in the first thing, given data is, when you write what is given to you, you will have a clarity. So they've given us density of methanol. So density is equal to 0.793 kilogram per liter. That's over. So how can I convert this into gram per liter? So 0.793 into 10 raised to 3 gram per liter. This is over. Fine. So next one, we have two things, isn't it? If the here, what is the volume to be needed? One volume is needed. They're asking for the different volume, right? So there are two things. First, we have one formula, isn't it? M1 V1 is equal to M2 V2. We're going to apply this whole information in that formula, right? So first of all, what are there when I have to write M1? Let us divide this into M1. This is V1 here. Let us write here M2 and V2. Fine. So what is M1 here given to us? Fine. So do we have M1? We need to find M1 because what is the volume needed to find for 0.25 molar solution? There are two things given here. Fine. So M1 and M2. Fine. So here M1 I need to find out. How much is M2? 0.25, fine, 25 molar. Here in this case, volume also I need to find. Volume also not there. What is the volume here given? V2, they've given us 2.5 liters. So 2.5 liters, isn't it? Fine, this is over. Because we are going to divide it into solute and solvent, isn't it? Fine, this is how we are going to do. Now, for calculating the molarity, first molarity is equal to, you're going to write weight by, okay, this one directly also you can write, isn't it? Yes, okay, let's see how can I write this. So your density is given, weight by molecular weight, but density is given. So how can I write this? I can write density is equal to density divided by mass. I can write this, isn't it? Yes, density is equal to mass by volume. But here, this is molarity, this is mass. Fine. How much is this coming up to? This is coming density 0.793 into 10 raised to 3 gram per liter. Right, how much is the mass given, right? So how much is this weight? I need to calculate the molar mass. What is that molar mass of methanol? Methanol is CH3OH. Now calculate for carbon. How much is that? For carbon, okay, 1, there's only 1 into 12 plus 3 into, okay, 1 into 12, methanol this is, okay, yes, 3 into 1.00, your 7 plus 16. When I do this, I get methanol weight is 32 grams. 32 gram per mole I've got. Okay, now substitute 32 gram per mole. Fine. So when you divide, you get molarity equal to 24.781 mole per liter. Okay, this is over. Now what did I get in this? Here I have got M1. I've got. Now substitute this M1 here in this case. Yes. So how much is M1? M1 is equal to 24.781. Okay, now you can do, isn't it? Yes, let us turn the page and do the sum. So what is M1 now? We have got two things, but let us write this formula 2. M1 V1 is equal to M2 V2. Now how much is M1? 24.781. V1 I need to find. M2 is 0.25. How much is V2? So take this V1 out. This goes the other way. 0.25 into 2.5 divided by 24.781. So V1 finally I've got an answer of 0.025 liters, because volume is in liters. So this comes to 25.22 milliliters if I have to convert. Fine, this is how you are going to do the sum. See what data is given to you, see how to find out from the given mass or given information, and then finally take the final answer. This is how you're going to finally calculate, because they've asked us to calculate V1. Fine, let us come back and do the next sum in this. So in the next sum, they've given us a sample of drinking water was found to be severely contaminated. Okay, right, with what? It was contaminated with chloroform essence. Fine. So and it's supposed to be carcinogenic in nature. The level of contamination was 15 ppm by mass. Express this in percent by mass, as well as determine the molarity of chloroform in water sample. Both the things they've asked me to do. Fine. So when such numerical is given to you, as I said, every time when such numerical is given to you, try to write the given data. When you write the given data, you'll have an idea, okay, what is given, what should I calculate. This is how you're going to do the sum, isn't it? Fine. So here express it in mass percentage, as well as determine the molarity also. Both the things they've asked me. Fine. Let's start doing the numerical. First of all, what is given to us in a sample of drinking water, they said. Fine. So let's start noting the data. Right. So let us see the next question. Hope concepts are getting cleared gradually. See, you will not get the concept immediately. You need to keep practicing, then only you will understand. Fine. So next question. How many volumes of 10 molar HCl should be diluted with water to prepare 2 liters of 5 molar HCl? Fine. So here, in this question, what did they give us? Like how much volume? I need to find the volume, isn't it? Is how much volume they said. So simple. They've given two things. Let us note the data first. So according to this, the given data, the simplest numerical this is. Yes. So in dilution, like molarity, the dilution law. When what happens? What is the formula? M1 V1 is equal to M2 V2. So here, this is. Let us take this as 10 molar HCl. Right, and the next one, okay, this is equal to this quantity. I'm going to take it as 5 molar HCl. Right, so 10 molar, 10 into, I need to find V1 because how much volume they said, and this 5 into, what is the volume? 2 liters they've given. 2 liters. Fine. So V1 is equal to 5 into 2 divided by 10. Okay, this is liters. So how much do I get? I get 1.00 liters. This is how we would do. This is the simplest numerical. Rather, there's nothing much. Given data, substitute in the dilution law or the molarity dilution law, and finally get the answer. Fine. So let's see one more numerical based on molarity. Here, this particular question, molarity, number of moles, both the mole concept as well as molarity are related. Let's see this question. So here, calculate the number of moles and the amount in grams of sodium hydroxide in 250 centimeter cube of 0.100 molar sodium hydroxide solution. Okay, fine. So here, what should I do when I need to solve this numerical? How can I do this numerical? Let's see. So first of all, number of moles, both the things, calculate the number of moles I said. Fine. So let us start from here. This is your main thing. 0.100 molar solution sodium hydroxide. How much is contained? 0.100 molar sodium hydroxide solution contains solution contains, what does it contain? It contains 0.1 moles of NaOH in how much? In 1 liter. In 1 liter, 1 liter. Okay, or I can write this as 1000 centimeter cube of a solution. Yes, I can write in this way. Okay, fine. So number of moles, if I have to find number of moles of sodium hydroxide, fine, in 250 centimeter cube of solution. 250 centimeter cube of solution. How can I do write this? I write this as molarity into volume of the solution. This is in liters. So how much is molarity given? It is 0.1. How much is the volume? 250. You're standardizing it to 1 liter, right? So molarity is equal to 0.1 into 250 divided by 1000. This comes to 0.025 moles of sodium hydroxide. Okay, this is over. Right. What should I find? I need to find the this one also, isn't it? The total. Asked me to calculate the amount in grams also. There's also one more thing which I need to find. So when I have to calculate the amount in grams, so let's write first of all molar mass of sodium hydroxide. Molar mass of sodium hydroxide is equal to 40 gram per mole. Right. Fine. So now mass of NaOH in 250 centimeter cube, because that is what I need to find, is equal to N of KOH into M of KOH. This is formula. So N of KOH is how much? 0.025 into M of KOH is what? 40. When I multiply, I get 1 gram. That's it. So both the questions, hope these are clear, both the concepts. Let's come back and do the last variety of molarity numerical, which is there. Fine. So here, let us see the question. 2.8 grams of KOH is dissolved in water to give 200 centimeter cube of the solution. Calculate the molarity of KOH in the solution. Okay, yes. So here, what should I find? I need to calculate my molarity. Direct formula this is. Basically, how let us write? Molarity is equal to moles of solute. Moles of solute by volume of solution in liters. Volume of solution in liters. Isn't it? Yes. Done. So here, what data is given? Moles of solute means nothing but weight by molecular weight, isn't it? But here they've given 2.8 grams of KOH is dissolved in water to give 200 centimeter cube of solution, they said. Right. So first of all, let us calculate the molar mass and then come back. Molar mass of KOH. Molar mass of KOH is equal to how much? 56. Gram per mole. Hope this is clear. 1939, 60 plus 16 plus 1. So this comes to 56. So let us 56 gram per mole. So here 2.8 grams, they said 2.8 grams of water. Okay. 2.8 grams of KOH. 2.8 grams of KOH is equal to, now like how much weight, isn't it? This should be the other way. Molar mass of this contains 2.8 grams contains how much? Okay, so what do I get? 2.8 divided by 56 moles of KOH. Okay, how much do I get? I get 0.05 moles of KOH. Okay, now I've come almost closer to the sum. Now let's come back and write. So molarity is equal to, now molarity is equal to, again I'm writing the formula, moles of solute divided by your volume of solution. Volume of solution in liters. Yes. So how much is the moles of moles we got? 0.05. Volume of the solution 200 by 1000, which comes to 0.25 moles per liter. This is your sum. So this is how you're going to calculate the molarity of the gas. So I've done the various combinations, almost 12 numericals regarding molarity. Let's come back with the next set, that is calculating your or doing the numericals based on limiting reagent. Right, so let's come back and start solving numericals which are based on limiting reagent. Fine. So we've already seen what actually is a limiting reagent. The reactant which is consumed the most is a limiting reagent, isn't it? Right. So let's read this question and see how to do the numerical. Dinitrogen and dihydrogen react. It means nitrogen and hydrogen react with each other to produce ammonia according to the following chemical reaction. Fine. Calculate the mass of ammonia produced if 2 into 10 raised to 3 dinitrogen reacts with 1 into 10 raised to 3 grams of dihydrogen. Okay, they have asked us to find the mass of ammonia when so much of nitrogen, so much of hydrogen reacts. Done. Second question, will any of these reactants remain unreacted? I need to find that also. Next is said, if yes, which one and what would be its mass? Fine. So they've given us the concept, they've given us the balanced stoichiometric or the balanced reaction in the equation. Let's start. Suppose when I have to solve this question, first of all try to write the equation which is given. N2 gaseous state plus 3H2 which is in the gaseous state gives 2 ammonia gaseous state. Right. So nitrogen 1 mole, isn't it? This is 1 mole. Hydrogen how many? Here according to the equation 3 moles, balanced reaction. Then here this is 2 moles. Fine. So 1 mole of nitrogen is how much? 28 grams. This means normally nitrogen mass is 14, for 2 nitrogens 28 grams. Hydrogen when I have to take isn't 3 2s are 6, isn't it? Right. So 1 is 1.008, so 6 grams. This is 6 grams. Then after that ammonia when I have to calculate, it comes to 2 moles means 34 grams. This is over, isn't it? Yes. So now what is the concept? 28 grams react with 6 grams of hydrogen. So 1 gram reacts with how much? Yes, that is what you should always start with the basic thing. So let us do what I'm trying to explain. So just write 28 grams of nitrogen reacts with 6 grams of hydrogen. Okay, yes. So now 1 gram of nitrogen reacts with 1 gram of nitrogen reacts with how much? Means cross multiply 1 into 6 divided by 28 grams. Okay, this is over. Yes. So now what did they ask? They've asked us 2000 grams of nitrogen. That is what they've given, isn't it? Look here. So they've given calculate the mass of ammonia produced if 2 into 10 raised to 3. 2 into 10 raised to 3 is nothing but 2000 grams of nitrogen, isn't it? So here I've got this for 1 gram. Now see, 2000 grams of nitrogen will react with, so cross multiply this, 2000 into 6 by 28, which comes to 428.57 grams of hydrogen. Done? Yes. Now just see here when I have to see the weight. Now nitrogen is limiting reagent, isn't it? While hydrogen is an excess, isn't it? So nitrogen limits the amount of ammonia produced. So that is what is the limiting reagent. Let us see. Let us come back and finish up and then come back to the equation. Now 28 grams of nitrogen produces how much? 34 grams of ammonia. Yes, so 1 gram of nitrogen produces how much? 34 by 28 grams of ammonia. Correct. Yes. So 2000 grams, because they've asked us to find for 2000 grams of nitrogen will produce how much? 34 by 28 into 2000, which comes to 2428.57 grams. Okay, this is of ammonia. I found for ammonia, right? So next, this is the first one. What did they ask in the next one? Will any of these two reactants remain unaffected? So hydrogen is an excess, isn't it? When I have calculated, right? Hydrogen here is an excess. I've got 428.57 grams of hydrogen. So hydrogen is excess, so it will remain unreacted. This part remains unreacted. So the second answer would be, yes, when you write hydrogen is in excess. Hydrogen is in excess. and excess, and it will remain unaffected. Remain unaffected because it is an excess. Whichever is consumed more is the limiting reagent, that is nitrogen, remains unaffected. Fine. Now after that, amount of hydrogen remained. How much is the amount of nitrogen? I got 428, isn't it? So that how much hydrogen number I can here only I write the third question. I'm solving it here. Amount remained unaffected. It is nothing but 1000 minus 428.57, which comes to 571.43 grams. That's it. Fine. So simple question. Basically, we are trying to write the stoichiometric equation. Then you are showing one after other, which is related to what? 28 grams. Normally 28 grams. That is 1 mole contains 6 grams of hydrogen. Then you started relating to 1 gram. Then you got finally weight of hydrogen. Then out of weight of hydrogen, I can easily say whichever is maximum consumed is limiting reagent, whichever is left out it remains unaffected. So next 28 grams are calculated, I got this answer, right? So let's come back and see the next question on limiting reagent, which is your NCERT question. Fine. Yes. So now calculate the amount of carbon dioxide that could be produced when 1 mole of carbon is burnt in air. 1 mole of carbon is burnt in 16 grams of oxygen. 2 moles of carbon are burnt in 16 grams of dioxygen. Okay, right. So they've given this question. Let's start how to do this. So basically, when such questions are given to you, so what should you remember? 1 mole. So first of all, your mole concept should be clear regarding this. 1 mole of carbon is burnt in air, correct? Yes. So first of all, let us write the reaction for this. Now I have to write the reaction. Carbon solid combines with oxygen gas to form carbon dioxide, isn't it? Yes. So here 1 mole of carbon, this is 1 mole, oxygen 1 mole, here carbon dioxide 1 mole. So 1 mole of oxygen is now, what is this? 32 grams. Right, 1 mole of carbon dioxide means 44 grams, isn't it? Now equation, first let us go with first one. 1 mole of carbon is burnt means 1 mole of carbon will burn, how much will it give? 44 grams, isn't it? So simple, the first answer is 44 grams. 1 mole gives us 44 grams. So let us write 1 mole gives 44 grams. That's all. Second, this is your part 1. So the second question, 1 mole of carbon is burnt in 16 grams of dioxygen, right? That means normally 1 mole requires how much? 32 grams for a reaction to occur. But now what do we have? We have 16 grams, right? So what will happen? So the amount of carbon dioxide produced by 16 grams. When 32 grams, when 1 mole, that is your rather if I have to say, when 1 mole you require 32 grams. For 16 grams, how much do you require carbon, or how much 1 mole of carbon? That means yes, the amount of carbon dioxide, rather if I have to see, the amount of carbon dioxide produced by 16 grams, and this has become half the amount of carbon dioxide produced. How much will this become? This also will become 22 grams. So here they've given 1 mole. This is what. Now tell me which is the limiting reagent. Now oxygen is the limiting reagent because it is consumed most. Yes. So oxygen is the limiting reagent. That is the thing. Next one. 2 moles of carbon are burnt in 16 grams of dioxygen. So 2 moles are burned. Again, what is happening here? 2 moles are burned. So basically, when I have to see this thing, right? So let us come back. 1 mole of carbon, if I have to say 32 grams of oxygen reacted to give 44 grams of carbon dioxide. Now in the second step, what did they say? This has become 16 grams. Then how much will this become? This will become 22 grams. Right? Now, the third case, what did they say? They said in this case, oxygen, they said 16 grams will react with only how much? Like 2 moles of, they said 2 moles of carbon are burnt in 16 grams. Again, they said 2 moles of carbon. Now here it is 1 mole. Now they said 2 moles of carbon will burn with 16 grams, they said. Fine. So in this case again, what will happen, which is the limiting reagent? Fine. So here oxygen is a limiting reagent. Why? It is consumed the most, isn't it? So 16 grams can react with how much? 0.5 mole of the carbon only, but how much? This is 22 grams, right? So in the last case, remember again, in this case again, oxygen is a limiting reagent, right? So 16 grams of oxygen can react with 0.5 mole of carbon only to produce, because this is also become half, isn't it? Yes. So 0.5 mole of carbon to produce 22 grams. So this is how you're going to do. So careful, such things you should just analyze. If this becomes half, this also becomes half, and the one which is consumed is the most or it is a limiting reagent. Okay, let us see the next question. When I have to see the next question, right, in a reaction A plus B2 gives AB2. Identify the limiting reagent if any of the in any of the following reactions. 300 atoms of A plus 200 molecules of B. Okay, 2 moles of A plus 3 moles of B. Next, 100 atoms of A and 100 molecules of B. Next, 5 moles of A and 2.5 moles of B. Next, 2.5 moles of A plus 5 moles of B. Okay, when such question is given to you, right, so first of all you need to just see, okay, like as I said, you should have the concept of your number of moles, number of molecules. Yes. So if your concept is clear regarding that, then you can easily solve such questions. Let's see the first question. What did they say? 300 atoms of A plus 200 molecules of B. Fine. So what is the reaction? A plus B2 gives AB2. Fine. Now let us first start solving. In this case, A plus B2 gives me AB2. Now according to the first reaction, what do they say about reaction? One atom of A reacts with one molecule. This is molecule, isn't it? One molecule of B, right? So 200 atoms of A will react with 200 molecules of B. Yes or no? Right? So in this case, B is the limiting reagent. Why? As this is in excess. Identify the limiting reagent. Once again, let us come back. This, according to this, one atom reacts with one molecule of B. Fine. So if they say 300 atoms, rather let us take 300 atoms of A and 200 molecules of B. Fine. So 300 atoms of A, right, will react with 200 molecules of B. So in this case, which is consumed more, or which is more, or which is maximum? 300 A is more, and 200 B is less, isn't it? So in case 1, this is your first case. Case 1, B is the limiting reagent. That is case 1. Fine. Let us go to the next part. Fine. 2 moles of A and 3 moles of B. Now let's again come back. 1 mole of A reacts with 1 mole of B. 2 moles of A will react with 2 moles of B, according to this, isn't it? Yes. So now in both the cases, which is this one, 2 moles of A will react with 3 moles of B, they said. So which is consumed more? A. So in this case too, A is a limiting reagent, according to this. Now in the third case, when I have to see 100 atoms of A, 100 molecules of B, both are same, isn't it? There is no limiting reagent in the third case. Nothing, no change at all. Yes. Let us write the fourth one. 5 moles of A and 2.5 moles of B, right? So 2.5 moles of B requires only how much? Basically 2.5 moles of A to react. Fine. So now as I see directly, I can see, isn't it, which is consumed more in both of these? B is consumed more. So B is a limiting reagent in this case. Whichever is consumed more is limiting reagent. Simple. Fifth one, 2.5 moles of A and 5 moles of B, they said. Fine. So here again, just see which is consumed more in both the cases. 2.5 is consumed more, right? So here in the last case, A is a limiting reagent. That's it. This is how we are going to do the limiting reagent questions. Fine. So let's come back and see one more question, limiting reagent. So here, what did they give us? 500 centimeter cube of 0.200 molar NaCl is added to 100 centimeter cube of 0.500 molar AgNO3 solution, resulting in the formation of white PPT. white PPT which is insoluble AgCl. Okay. How many moles and how many grams of AgCl are formed? Which is the limiting reagent? How many moles and how many this one are formed, and which is the limiting reagent, they said. Okay, fine. So basically when such question is given to you, try to write the formula first. What is that? What did they say? AgNO3 reacts with NaCl. Silver nitrate reacts with NaCl. It gives AgCl and NaNO3. What do you get? Silver chloride plus NaNO3. Number of number of NaCl, number of moles of NaCl in 500 centimeter cube. They're given here. See, number 500 centimeter. Number of moles of NaCl in 500 centimeter cube. What is 500 centimeter cube? Nothing but 0.5 liter, isn't it? Yes, of 0.200 molar of NaCl. Fine. Once again, let us write what I'm trying to explain. Number. Right. So let's come back and do the numerical. As I said, numerical. Let us read it once again. Fine. I've done a part of in the earlier video. Maybe I'll just redo it again for you all. Right. So what did they give us? Basically, they've given us 500 centimeter cube of. Let us type this off and start with the numerical. Before going into that, what should we remember? What is limiting reagent? Limiting reagent is something or the reactant which is mostly consumed. Means the quantity of the reactant whichever is less, that means it is consumed more, and that will be the limiting reagent. Once again, if one of the reactant is A and one of the reactant is B, right? Suppose after the reaction is complete, if the reactant A is 5 grams and if the reactant B is 3 grams, that means out of A and B, which is more consumed? B is more consumed. That means B will be the limiting reagent. So the reagent or the reactant which is consumed the most is a limiting reagent. Done. Let us read the question now. 500 centimeter cube of 0.200 molar NaCl solution is added to 100 centimeter cube of 0.500 molar AgNO3 solution, resulting in the formation of a white PPT of insoluble AgCl. Okay, how many moles and how many grams of AgCl are formed? What is the limiting reagent? So basically, what they give us? They've given us silver nitrate. Okay, it reacts with NaCl. Done, and it forms a white PPT of AgCl. Yes, this is your white PPT, and in this white PPT along with that NaNO3 is formed according to this reaction. Now what should I find out? I need to find out for AgCl, I need to find the number of moles. Along with that, I need to find the mass also in grams. This is my task now. So first of all, when such question is given you, try it given. First of all, they've given us 0.200 molar. Okay, molar means nothing but molarity, isn't it? Yes. First, try to find out among these two which is the limiting reagent, because they have two things given. See here, how many moles and how many grams of AgCl. This is what is there. What is the limiting reagent? I need to find one limiting reagent. I need to find the moles. I need to find the grams. So let us start with finding out the moles. So first of all, divide the page into 2 equal halves. Now let us divide this page. The first one, we'll calculate moles of NaCl first. Then in the second case, we'll calculate moles of AgNO3. Moles of AgNO3. Done. Now how much did they give me? They've given 500 centimeter cube of 0.2 molar NaCl. So here they've given 500 centimeter cube. What is 500 centimeter cube? It is nothing but 0.5 liters, isn't it? Of how much? Of 0.200 molar. Now let us write for AgCl. They added to 100 centimeter cube of 0.5 molar AgCl. So let us write here 100 centimeter cube. That means what is 100 centimeter cube? It is nothing but 0.1 liter, isn't it? Of how much? 0.500 molar. This is over. Now what should I calculate? I need to calculate the moles of both. Once I calculate the moles of both, I can tell whichever is mostly consumed, that will be the limiting reagent. Now come back. Here, according to molarity, it is molar, isn't it? Molar is nothing but molarity. Molarity is equal to number of moles by volume of the solution in liters, isn't it? Here also same, molarity is equal to number of moles by volume of the solution in liters. Let us turn the page and do the sum. Fine, this is what you have written. Now here in this case, number of moles. What is this? Now I need to find N. N is equal to molarity into volume of the solution in liters. Both the case is the same. N is equal to molarity molarity into volume of the solution in liters. Hope this is clear. Now, how much is the molarity which they've given us? They've given us 0.200, isn't it? That is the molarity which they've given. Just turn back and see. They said 0.2 molar solution. That thing with molarity, isn't it? Substitute that here. N is equal to 0.200. What was the volume? It is 0.5 liters. In this case, we have got 0.500 into 0.1 molar. Now, in value, here when I multiply, I get 0.1 mole. Okay, this is for what? This is for NaCl, and when I multiply here I get 0.05 mole. This is for what? This is for nothing but your AgNO3. Okay, now compare. I need to find the limiting reagent. Now directly see here, 0.1 mole is NaCl, 0.0. Okay, well, let us write that reaction once again. NaCl plus AgNO3 gives me AgCl plus NaNO3. Okay, now how much was this one? NaCl is how much? 0.1 mole. How much is AgNO3? 0.05 moles. Now compare. This is 0.1, this is 0.05. Which is more consumed among these two? This is more consumed. AgNO3 is more consumed. So here the limiting reagent here is AgNO3. Why? Because it is more, or it is consumed more or more consumed? More consumed. It is more used up. It consumed means it is used up. Yes, fine. So this is over. The first part is over. I need to do the second one. What should I do in the second question? They've asked me to find out the moles in grams of AgCl. So when I have to do that, moles in grams, I'm solving the second part of it. Let us make it line now. Yes. So when I have to solve the second one, they've asked me moles in this. So we have again the same formula. What is that? Molarity is equal to N by V. Okay, N is equal to molarity into liters. Easily you can do this, isn't it? Yes, fine. So here a number of moles also I can find from here, N into M. Yes, done. How much is the number of moles of, okay, molarity of this, right? How much did I get? I've got like 0.05 AgCl, isn't it? Yes, so 0.05. 0.05. How much is this one of that? The thing, what do you say, mass of this? It is 143.5 grams. So when I multiply, okay, what is this one here? I need to find mass, isn't it? Okay, mass is equal to N by V. Okay, this is done correctly. It is for 7.2 grams of AgCl. This is how you find. Now next one, when I have to see the mass, molar mass of AgCl. Okay, molar 143.5 is molar mass of AgCl, isn't it? Yes, fine. How did I come, ma'am? How did you get this? Let me see. See, 1 mole of NaCl combines with 1 mole of AgNO3, isn't it? The same thing to form 1 mole of AgCl. Come back again. 0.05 moles of NaCl combines with 0.05 moles of AgCl to form 0.05 moles of this one. What do you say? AgCl. That's why I've taken 0.05 here in this case. Molarity I've taken as 0.05. That is the reason I've added. Multiply this. So final answer is 7.2 grams. Fine. Hope this is clear. I've clearly explained step by step reaction. Let us come back and do the next question. Limiting how many moles. Fine. So here we have magnesium sulfide question. So this is also an interesting question, but the only thing is you need to remember how to do this concept. Let us read. How much magnesium sulfide can be obtained from 2 grams magnesium and 2 grams sulfur by the reaction magnesium sulfide MgS. There is one reaction given here. Okay, which is the limiting reagent? Calculate the amount of one of the reactants which remains unaffected. So once I calculate limiting reagent, the leftover is unreacted, isn't it? Let's see. First of all, let us write the reaction. What is this? Magnesium. I'm copying the same reaction here. Magnesium plus sulfur gives me magnesium sulfide. Right. So what did they say? 2 grams of magnesium and 2 grams of sulfur, they said. So let us find the number of moles first of all. So here number of moles for both we'll calculate. Number of moles in terms of magnesium and number of moles in terms of sulfur. So N is equal to, okay, 2 grams means what? So 2 grams of magnesium means how much? Yes, according to this, 2 grams of magnesium is nothing but 200 divided by molecular weight 24.3. It comes to 0.0824 moles. Okay, now for sulfur, how much is this? Again 2 grams. 200 by how much is the sulfur weight? 32. It is equal to 0.064, 0.0624 moles. Now see, in this case it's 0.0624 moles. In this case 0.0824 moles. Both are there. Now in both the cases, which is less or which is more consumed, which is more consumed here? This is 0.08 of magnesium and this is 0.06 of magnesium. So sulfur is more consumed, isn't it, in this case, right? So what is the limiting reagent? Whichever is consumed more, that will be the limiting reagent. Once again, the one which is consumed more is the limiting reagent. So here sulfur is consumed more compared to this with a given weight 2 grams converted and according to sulfur. So sulfur is a limiting reagent. Sulfur is a limiting reagent. This is over. First thing. Now what should I find? I need to calculate the amount. This part is over. We'll come here. Calculate the amount of one of the reactants which remains unreacted. So which is remaining unreacted? That means whichever is excess, that is magnesium. Now we'll see. Sulfur is so much, magnesium is so much. So we'll calculate both. Let us turn the page. We'll calculate both the cases. What should I calculate now? I need to calculate moles of magnesium and I'll also calculate mass of magnesium. Mass of magnesium left unreacted. Both we will calculate. So moles of magnesium, mass of magnesium. So moles of magnesium is another 0.084. What that was the leftover this one, sulfur I'll take out 0.0624. I'll take out. What do you get? 0.0200 moles of magnesium is left. Okay, and this is what is left. Now mass of magnesium, how do I do? Normally N is equal to W by M, isn't it? So or if I have to do the other way, this is equal to N by volume. Okay, let us come from here. N, what is N? N is nothing but weight by molecular weight. This is what I have written here, right? Okay, N by fine into 1 by V. Okay. Now what do I require? I require the mass. Take out W. W is equal to cross multiply N into M because I need mass. How much is number of moles of magnesium? I have got here W is equal to 0.0200 into how much is the molar mass of magnesium? This is nothing but 24 grams. Yes. So when I multiply, I get an answer of 0.486 grams of magnesium. Okay, this is what your answer is. Fine. So I have got moles, I have got mass, right? Then I have got even the limiting reagent, right? This is how you're going to do. Hope this is clear with the sum. Let us go back to the next sum of limiting reagent. Fine. So here they've given us, let's read the question. 50 kg of nitrogen atoms, or 50 kg of nitrogen and 10 kg of hydrogen are mixed to produce ammonia. Okay, as soon as such question is given, just try to write the reaction in keep. Stoichiometric reaction. What is stoichiometric? Balanced reaction in keep. What is this? Nitrogen gaseous state, it combines with hydrogen gaseous state to form ammonia NH3 gaseous state. Now here hydrogen is 3. So here hydrogen is 2. Here nitrogen is 2. So I'll put 2. Now 3 to the 6 hydrogens. Now balance here. 3 to the 6. Now balanced. Now let's read. Now this reaction mixed to produce ammonia itself. Calculate the ammonia formed. I need to calculate the ammonia form. That is first. I need to identify the limiting reagent in the production of ammonia in this situation. Fine. So let us calculate separately. Let us start solving. Let us take this part for nitrogen. Let us take this part for hydrogen. Fine. I need to calculate what? Limiting reagent in terms of moles. Fine. So what is number of moles equal to? Like basically if I have to write this one, number of moles is equal to weight by molecular weight, isn't it? Now see, what am I going to do? Now I need to, both the cases I'll calculate moles, and whichever is consumed more, that will be the limiting reagent. Now see, how much did they give us? They've given us 50 kg and 10 kg of hydrogen. I need to convert it into moles. Now I'll be using dimension analysis. How is this done? First of all, 50 kg right? Weight by molecular weight, isn't it? Number of moles. So 50 kg. What is the mass of nitrogen? It is nothing. This for nitrogen, it is nothing but grams. Now to cancel this kg, I am going to divide by 1 kg. So this kg and this kg gets cancelled. Now 1 kg is how many grams? It is nothing but 1000 grams. So cancel this grams and this grams into, now here you multiply with 1 mole. Now see here, this and this gets cancelled, this and this get cancelled. The final answer which I get, I'll get in 1 mole, isn't it? So when I solve this, I get an answer of 17.86 into 10 raised to 2 moles. The same case applies here. 10 kg hydrogen. So 10 kg hydrogen into, to cancel this out, I am going to multiply with 1 kg. Gone, cancelled. Number of moles is weight by molecular weight. What is the weight of hydrogen? Just 2 grams. Okay. Yes. So now this is grams. Now 1 kg is equal to how much? 1000 grams. This gram gets cancelled and multiply with 1 mole. Now kg got cancelled, gram got cancelled. What am I left with? Moles. Now multiply, n is equal to 4.96 into 10 raised to 3 moles. This is what is the answer. Now when I compare both the answers, now see which is more consumed here. 4.96 is more consumed, right? Hydrogen is more consumed. This is 17.86 of nitrogen is left out, but here hydrogen is consumed more, 4.96. So what will be the limiting reagent here? So hydrogen is a limiting reagent. Let us write that question. Hydrogen is a limiting reagent. Why? It is consumed more. Limiting reagent as it is consumed more. It is consumed more. This is what is consumed more. Fine. Now next one. What should I find out? I need to find out the amount of this one also, isn't it? The amount of ammonia also. Let's see. Now accordingly, I'm doing the second one. According to the equation, yes, nitrogen, how much nitrogen, nitrogen, how much it react? It will react with N2 plus 3 H2, isn't it? It will react with 3 hydrogens to form 2 NH3, isn't it? Yes. So how much normal nitrogen, how much did I get? I got nitrogen mass is 17.86. 17.86 into 10 to the power of 2 moles of nitrogen. The will react with 3 into 17.86 into 10 to the power of 2 of hydrogen. This is what is the concept, because it is 3, isn't it? How much do I get? I get an answer of 5.36 into 10 to the power of 3 moles. Fine, this is how I got. Fine. So I got so much of nitrogen unreacted. I also calculated the limiting reagent. So this is the procedure to do the limiting reagent numericals. Simple, nothing much complicated in this. See, the reactant which is consumed more is the limiting reagent. Yes. This is the thing. Now they asked us to find out every element of sodium sulfate. So let's start. First of all, individually we'll start. For that mass of solution, I need to find the molecular weight of sodium sulfate. So molar mass or molecular weight of Na2SO4. How much is this? 2 into mass of sodium is 23 plus sulfur is 32 grams plus 4 into 16. This comes to 142.04 grams. Now, I need to start with sodium. So, mass percent of sodium, second, mass percent of sulfur, third, mass percent of oxygen. So mass percent of sodium, right? So how much is this? Mass percent is nothing but weight by molecular weight. Okay, so mass of solute, that is weight of sodium by the total mass of solution. So this becomes how much? How much was this mass of this one? So the weight of that thing, it is nothing but 23 grams. One sodium is 23 grams, but 2 sodiums are there, so 46 grams. Rather, it is 45.98 grams divided by total 142.04 into 100. This comes to 32.37. Next, mass of sulfur. Mass percent of sulfur, that is weight of sulfur divided by mass of the solution. Sulfur weight is 32 grams divided by 142.04 into 100. How much do I get? I get 22.57. Now when it comes to oxygen mass is how much? Weight is 64 grams. The total mass of the solution is 142.04 into 100. This comes to 45.06. So this is how we are going to do. Right, hope this is clear. Yes. Carefully try to do the numericals one after the only thing is you need to remember the formula. When you remember the formula, it's easy for you to apply the concept. Yes. So let's come back and start with the next concept, that is your mole concept. Very interesting numericals you have in this. Let's see. So in your mole concept, first of all, let us see one question after the other, which are, it will be taking us into the depth of the topic. So 1 mole atom, 1 gram atom, 1 this one GMM, GAM, gram atom also, molecular mass also, gram molar mass also. Let's see how to do. Fine. So Avogadro number, everything, all the concepts will be there in this. So in the mole concept, first of all, what did they ask? 3 moles of ethane, calculate the following: number of moles of carbon atom, number of moles of hydrogen atom, number of molecules of ethane. Fine. First of all, let us start with the solution. What is this? Number of moles of carbon atom. Whatever you do, try to relate with 1 mole. Start with 1 mole. So in the first case, let us see, take this first case, 1 mole of ethane, that is C2H6. How much does it contain? It contains 2 moles of 1 mole of ethane. This is 1 mole. It contains how many moles of carbon? 2 moles of carbon atom. Isn't it? Yes. Now what did they say? Number of moles of carbon atom, isn't it? Right. So in 3 moles they said. So what we'll write? 3 moles of ethane. 3 moles of ethane contains how many? That means it is nothing but 2 into 3, 6 moles of carbon. Simple, isn't it? Always start with 1 mole. That's easy. Now let us come back to the next. Number of moles of hydrogen atom. So next, 1 mole of ethane. How much it contains? How much it contains? How many hydrogen atoms? It contains 6 moles of hydrogen. 6 moles of hydrogen atom. Now what did they say? 3 moles. 3 moles of ethane contains how much? Means 3 into 6. This gives to 18 moles of hydrogen. Simple, isn't it? Now third case, they've asked us number of molecules. Fine. So 1 mole of ethane, how much does it contain? It contains 6.022 into 10 raised to 23 molecules, isn't it? Molecules, that is what. Now they said in 3 moles. So in 3 moles of ethane contains how much? Means 3 into 6.022 into 10 raised to 23. How much this comes to? This comes to 18.066 into 10 raised to 23 molecules. That is what is the concept. Try to relate the mole, always 1 mole to that particular thing. Start with 1 mole, see you'll be getting the answer. Yes. Fine. So next question, let us see in the mole concept. Fine. How are 0.5 moles of sodium carbonate and 0.5 molar sodium carbonate different? How is the mole as well as molar different, they're asking us. So basically, first of all, you should have an idea what actually is mole and what actually is molar. So most of the students, they get confused. So let's see. First of all, to solve this question, always remember, try to keep the molecular mass of the given thing, and then it's easy for us to relate. So first of all, try to find molar mass, because 1 mole we are going to relate it with its mass, isn't it? Molar mass of Na2CO3. So how much is this? Sodium carbonate is 2 into 23 plus carbon is 12 plus 3 into 16. This comes to 106 gram per mole. This is over. Yes. Now this is the molar mass. Now see, I'm comparing both. What does it mean? 0.50 moles, and I have to know what is 0.50 molar. Just see. Yes, 0.50 moles of sodium carbonate. That means how much it, I'll be writing both in terms of grams, and you'll understand. What is 0.50 mole? See, 1 mole contains when I have to see the 106 grams of this one, isn't it? So basically it is 1 mole contains, this is for sodium carbonate, both I'm asking. This is also sodium carbonate, this is also sodium carbonate. Yes. And here 1 mole contains how much? Molecular weight 106 grams of sodium carbonate. So 0.5 moles contains how many grams? Means how much? 0.50 into 106 grams, that is equal to 53 grams of sodium carbonate. That is that is nothing but your 0.5 mole. Now when I have to say 0.50 molar sodium carbonate, this means it is, just see this, 53 grams sodium carbonate is present in, it is present in 1 liter of solution. Means you are dissolving that. Molar means nothing but number of moles of solute in volume of the solution in liters, isn't it? That means 53 grams weight of sodium carbonate you have dissolved in 1 liter of solution. So this is 1 mole, this is 0.5 mole, half of that. This is total 0.5 molar, means this I've already got the weight. 53 grams is taken and dissolved in 1 liter of the solution. That is your concept. Right. Now let us see the next question. Which one of the following will have the largest number of atoms? 1 gram gold, or 1 gram sodium, or 1 gram lithium, or 1 gram chlorine? Right. So which one will have the maximum? They asked us. Let's start solving this question. So here 1 gram gold. So 1 gram gold means what? What actually is 1 gram gold? So let's start solving instead of discussing. So 1 gram gold means, it means gold atomic molecular mass 1 by 197 means the molecular mass of this molecular atom moles, or 1 by 197 moles of mole atoms of gold. What does it mean? That means this is equal to how much? 1 by 197 into 6.022 into 10 raised to 23 atoms of gold. This is what is the concept. The same thing. Let us start. In the second case, 1 gram sodium is nothing but 1 by 23 mole atoms of sodium. That is nothing but 1 by 23 into 6.022 into 10 raised to 23 atoms of Na. The same case if I have to start with lithium. 1 gram lithium is equal to 1 by 7. You can also take as like one mole is equal to so much. That 1 mole is how much? Basically 1 mole is 6.022 into 23 atoms, isn't it? But here they've given, we are comparing the molar masses. So 1 gram of lithium, yes, contains 1 by 7 into 6.022 into 10 raised to 23 is an of lithium. That's okay. Now let's start chlorine, fourth one. 1 gram Cl2 means 1 by 71 of mole atoms of this, which is equal to 1 by 71 into 6.022 into 10 raised to 23 or atoms of chlorine. Right? So this is the thing. So basically when I have to see among all these, so among all these, what are you observing? 1 gram of lithium has the largest number of atoms, isn't it? So this is 1 by 197 into 6.022. This is 1 by 23 into 6.022. This is 1 by 7 into 6.022. This is 1 by 100. Among this, which will have the maximum largest number of atoms? Lithium. Lithium will have the maximum or the largest number of atoms when I see this fraction. So lithium is the answer. Yes, so this is how we are going to do the numerical. Right, so let's come back into one more question. Calculate the number of atoms in each of the following: 52 moles of argon, 52 U of helium, 52 grams of helium again. Okay, so I need to calculate the number of atoms. Again, I'm telling you, basically all these questions are, they will try to clear your concept. When you keep solving, isn't it? When you keep solving, they keep they'll be clearing your concept which you have studied in terms of your mole concept. You would have done this mole concept, isn't it? This mole concept one in your schools also. So when you start solving, then only you'll have a clarity. Okay, my teacher has taught this, how should I apply this in the concept? Let's start. Calculate the number of atoms in each of the following. First of all, 52 moles of argon. Start with 1 mole always. What did I say? 1 mole of argon contains how much? It contains 6.022 into 10 raised to 23 atoms. Okay, yes, now they said 52 moles of argon contains 52 into 6.022 into 10 raised to 23 atoms. So this is how much? This comes to 313.144 into 10 raised to 23 atoms. Further, if you write 3.13131 into 10 raised to 25 atoms. This is over for RV. They've asked how many atoms, isn't it? So calculate the number of atoms. I've got it in atoms. Now let us start calculating for the second one. 52 U of helium. Now basically when I have to see 1 mole of helium is nothing but 4 U, isn't it? 4 U of helium means that is equal to 1 helium atom, isn't it? The mass of helium. Now what do they give? 52 U of helium contains how many atoms? Because everything I need to calculate in atoms. So this comes to 52 into 1 by 4, which is equal to 13 helium atoms. Now again I've got it in atoms. Now let us do for next one. That is 52 U is over. Now 52 grams of helium I need to calculate. The third one, the third case. Now gram relation. Start. 1 mole atom of helium contains how much? 4 grams. What is 4 grams? That 4 grams contains 6.022 into 10 raised to 23 atoms, isn't it? Yes. Now 52 grams of helium, 1 mole atoms, okay. 52 grams of helium contains how much? Means 52 into 6.022 into 10 raised to 23 atoms divided by 4. Why did I do this? Because I have to convert it into the mole atoms, because this is equal to mole atoms, isn't it? So when I solve, I get 78.286 into 10 raised to 23 atoms, which is further equal to 7.8286 into 10 raised to 24 atoms. Finally, I have got to an answer which is equal to atoms. I need to calculate everything in atoms instead. That's also over. Yes. So let us come back and do one more question in your mole concept. So assuming complete dissociation, how many chloride ions are present per mole, per ml in a solution obtained by mixing 100 ml of 0.5 molar barium chloride, 100 ml of 0.2 molar KCl and 100 ml of water. Fine. This is the question given to us. I have to assuming the complete dissociation result. Fine. So complete dissociation, when they speak, you need to be careful in seeing like how much, step by step we'll go. First of all, they've given us barium chloride, then we have KCl, we have water. We'll calculate for everything. First of all, number of moles of barium chloride in 100 ml. Let us see, because it is per ml in the solution. So what did we say? Number of moles of barium chloride in 100 ml. 100 ml of solution. So how much is this? This comes to 100 into how much is the molarity given? 0.5. 0.5 into 10 raised to minus 3. Yes. So how much do I get? I get equal to, that is nothing but 1, you're converting it into 1 liter, that is your 1000 ml, isn't it? So you've got it to the numerator, nothing but 0.05. Now, let us calculate for chlorine. Number of moles of Cl minus ion in barium chloride. How many are there? See, for barium you've got this. Number of moles are how many? BaCl2, isn't it? So 2 into 0.05. That is equal to 0.1 mole. This is also done. Now, number of moles of KCl. Number of moles, because second thing I've come back now. This is your first one. I'm doing the second one. Number of moles of KCl in 100 ml solution. 100 ml solution, right? It is equal to 100 into 0.2, the same thing, because they've given 0.2 into, again as I said, 1000, 10 minus this comes to 0.02. Right. Now let's come back. Number of moles of Cl minus also I need to do. Yes, let us do that. Number of moles of Cl minus in KCl solution. How much is this? It's coming to 0.02. Now I've calculated everything, isn't it? Barium chloride I've calculated. I've calculated the amount of chlorine. Here also KCl also I calculated. Then I calculated now moles of chlorine also I did. Now let us calculate the total volume. Total volume after mixing. total volume after mixing, it is equal to 100 plus 100 plus 100. For all the three, it is 300 ml, all the three units, right? Fine. Now, total moles of chlorine, both the cases, total moles of Cl minus, right? How much is this? 0.1 I got in one case, 0.02 I got in one more case. How much this is coming to? It's coming to 0.12 mole, right? So now I need to calculate moles of chlorine per ml, isn't it? Then I'll calculate it to 1 mole. Like basically they're asking us to calculate number of this in assuming complete dissociation, isn't it? How many, they've asked me how many chloride ions are present per ml in the solution. That is what I'm calculating, right? So moles of Cl minus ions per mole, sorry, per ml. How much is that? 0.12 by 300, because per ml I'll calculate 300 ml, right? So number of moles now, number of Cl minus ions is equal to mole of Cl minus into 6.022 into 10 raised to 23. This comes to cross multiply, you're going to get 0.12 into 300. This is the same thing. Basically this is calculated for one mole, so that particular ml total volume, and this is per mole. This comes to 0.12 by 300 into 6.02 into 10 raised to 23. It comes to 2.408 into 10 raised to 20. Okay. So many steps. Yes. So what did I do? I did initially one step, then I did one more step. I calculated individually for barium chloride, then I calculated for potassium chloride, then I added the complete chloride concentration or chloride this one, and the moles of chlorine and chloride ion, and then finally I found for per ml, because they asked me to find per ml. Then I've gone to your comparing with 1 mole of that. So I've got this answer. Right, now let's come back and do one more numerical, which is based on molality. So what do we learn in molality? When we have seen molality, let us write the formula first. So if we write the formula, it's easy for me. Basically molality is equal to, or it is denoted by small m, which is equal to moles of solute divided by mass of solvent in kg, isn't it? This is what is your molality. Fine. So further, how can I write this? If I have moles of solute is nothing but n, how can I write n? I can write it as mass of solute in grams into 1000 divided by mass of solute into mass of solvent in grams. Okay, now let's start with the numerical. What do they give us? This is basically an NCERT question. They've given us the density of 3 molar solution of NaCl is 1.25 gram per liter. Calculate the molarity of the solution. Directly they've given us, nothing is there. Let's start. First of all, always try to calculate first molar mass and keep it ready. So mass of NaCl, right, in 1 liter solution, 1 liter. Find mass of NaCl. So what do they give us? 1 liter is 58.5. So if I have to take this 3 molar solution of NaCl, that means it is nothing but 3 into 58.5. How much this comes to? 175.5 grams. Okay, this is done. So next important, till now it's not done, the numerical is not done. Now I need to find the molality, isn't it? So when I have to go back to this, first of all I need to calculate what is given. Density is also given, isn't it? So mass of 1 liter solution, okay, mass of 1 liter solution is equal to 1000 into your density. Yes, fine. So how much is the density given? 1000 into 1.25, it's coming to 1250 grams. Okay, now I need to calculate mass of the solvent also. So let us take that mass of, because I need to apply everything in the molarity formula. Mass of water in solution. Mass of water in solution. So this mass of water in solution is how much? Total is 1250 grams. 1250 grams minus how much was water which I got? It is nothing but 175.5. Subtract that. When you subtract 175.5, you get grams. You get how much? 1.745 grams. This is what is this. Now molarity directly. Now I have all the data I can calculate. Hence, how much is the molarity equal to? Now what is this? Mass of solute divided by mass of solvent in kg. Mass of solute divided by mass of solvent in kg. This is your molarity. So how much is the mass of solute which they gave us? They've given us how much? 3 grams. Isn't it? 3 molar. That is nothing but 3 moles of solute. 3 divided by mass of solvent. How much did I get? I got 107.5 grams. This comes equal to 2.79 mole per kg. That's it. This is how we are going to do. So hope these numericals are clear to you all. I've covered all the numericals like significant figures, empirical formula, scientific notation, molarity, normality numericals, equivalent mass, mole concepts, and every numerical I have covered. Yes, any doubts, please let me know in the comment section. So after empirical formula numericals, we have done limiting reagent numericals. Now let's start with the basic numericals. Those are your molecular masses. Fine. So this topic is a basic concept which I would have done first, but I felt any time is the same. Fine. So what is this question? Calculate the molecular masses of the following. So simple, isn't it? How to calculate? I've already taught you. So first of all, always whenever you're calculating a molecular mass of a particular compound, try to start with this. Yes, so 2 into atomic mass, that is important, plus 1 into atomic mass of oxygen. Okay, what does it mean? 2 into, what is the mass of hydrogen? 1.0079 U plus 1 into 16 U. How much is this? This is coming to 18.0158. So normally this significant figure, it is less than 5. So we tend to neglect this and we write 18 U. This is U, unified mass. That is how you calculate. Let us come back and do this. Carbon dioxide. Now 1 into, just multiply, 1 into 12.01 U plus oxygen is 2 into 16 U. How much does this come to? This come to 44.01 U. Okay, this is also done. When it comes to methane, again the same concept. Carbon is how much? 1 into, how much is carbon? It is nothing but 12.01 U plus 4 into 1.0079 U. How much this comes to? This comes to 16.04 U. Okay, this is how you're going to calculate. Simple, isn't it? Just see the coefficient, see then the multiply with the molecular mass, then add 2 and do it. Let's come back and do the next question in molecular mass. Here, what do they give us? How much copper can be separated or can be obtained from 100 grams of copper sulfate? Okay, how much mass? Again, your molecular mass concept. And how much mass of copper they said? Can be obtained from 100 grams of copper sulfate. First of all, when such question is asked to you, try to, first important thing which you should do is calculate the molar mass of copper. I'll tell you why. Molar mass of copper sulfate, when you calculate, it comes to, copper is how much? 63.5 plus how much is sulfur? 32 grams plus 4 into 16. It comes to 159. Okay, if you take the decimals also, 6 gram per mole. This is your molecular mass. Now what is it say? What is said? 159.6 grams of copper sulfate. Now we are relating with this because this is for 1 mole. So 1 mole and mole we are relating, then come back to 100 grams. Now what is this? 159.6 gram per mole of copper sulfate. Yes, how much does this contain? It contains 63.54 grams of copper. This is the first thing. Now 1 gram copper sulfate contains how much? It contains how much? Now cross multiply, 1 into 63.54 grams divided by 159.6 grams. I'll get this particular thing, isn't it? Now here I'm not solving it directly. Now what did they ask? They've asked for 100 grams copper sulfate. This is for 1 gram. Now calculate for 100 grams. The same thing, 100 grams of copper sulfate contains how much? Means this 1 into 63.54 okay, into 100 divided by 159.6 grams. You get an answer of 39.81 grams of copper. That's it. So what do? First you calculate for molecular mass, then compare between the masses of both, calculate 1 gram, and then come back to the given mass, 100 grams or how many ever grams they give. Fine, hope this is clear to you. So now let's come back and do the next question here. Right. So here, what will be the mass of 112th carbon isotope, like carbon 12 isotope? Yes, in grams they've asked you to calculate. So simplest question, isn't it? Already we have studied in the masses. What actually is that? We have studied how much why are we taking 1 gram or why are we comparing it with carbon 12 isotope? That's taken as a standard. I already told you 1 AMU, 1/12 of the mass of carbon atom. So right, so that concept they're using it here. So what will be the mass of 112? Okay, mass of the same concept which I've taught, mass of 1 atom of carbon 12. We have taken this as a standard, 1 atom of carbon 12. What is this equal to? This is equal to atomic mass of carbon divided by Avogadro's number, isn't it? Yes, so this comes to 12 grams by 6.022 into 10 raised to 23. This comes to 1.9927 into 10 raised to minus 23 grams. This is what is the answer. So mass of 1 atom of carbon. This is mass of 1 atom of carbon. This is the thing. Yes, so this is how we are going to do it. Right. So let's come back and see one more question based on mass. Right. So here, next question, what did they give us? Calcium carbonate reacts with aqueous HCl to give calcium chloride and carbon dioxide. Calcium carbonate reacts with HCl to give calcium chloride plus carbon dioxide plus water. What mass of calcium carbonate is required to react completely with 25 ml of 0.75 molar HCl? Okay, this is a question which is given to you. Fine. So let's do this question carefully. So first of all, what should I do? I need to calculate what? I need to calculate mass of calcium carbonate. That is what is the question, isn't it? Yes. So mass, when such question is given to you, first of all, I try to analyze the whole question so that it's easy. Fine. So here in this thing, there are 2 steps basically. First step is I need to calculate the molarity. In the second step, I need to calculate the mass. Okay. Now, first of all, to calculate the mass of calcium carbonate, what should you require? Like I need to calculate for the complete this one. So let's start solving numerical. First of all, what mass of calcium carbonate reacts completely with 25 ml of 0.75 HCl they've given. So first of all, let us calculate the mass of HCl, then compare with the calcium carbonate. Yes, let us do the step 1. In step 1, first of all, we'll calculate calculation for mass of HCl. And how much mass of HCl in 25 ml of 0.75 molar HCl, right? Fine. So molarity is equal to W into 1000 divided by M into volume in ml. Okay. Yes. So molarity is how much? 0.75. What is this one? Weight. I need to find that W into 1000. Molecular weight of HCl is 6.5. What is the volume here? The volume here is how much did they say? They said 25 ml. They said 25 ml. So 36.5, that is 25 ml. So when this comes back, cross multiply, get this weight out. Weight is equal to, cross multiply this, 0.75 into 36.5 into 25 divided by 1000. Then W we get weight of 0.6844 grams. This is what is your answer. So first of all, now I've got the weight of HCl. That's done. In the second step, I need to calculate the mass of calcium carbonate. Now my second step. Okay, there's no page here. Let me take a fresh page. Yes. Now Okay, I am not left with any pages. Now let me take one more page. Sorry for the inconvenience. Yes, so now I have to do the second part. Okay, I have to do the second part of that. Let me, I said okay, this way it is going. Now let me calculate the mass of calcium carbonate. So here in this particular case, when I have to calculate, what is this calculation of mass, or the calculation of required mass of calcium carbonate. Calculation of required mass of calcium carbonate. I'm going to calculate the required mass here. Let me write the reaction. Calcium carbonate, it reacts with HCl to give me calcium chloride plus carbon dioxide plus water, isn't it? Now calcium carbonate, how much was that? Basically 100 grams. This is 100 grams. Now let us do the stoichiometric reaction. H2 and this is 2HCl. Right. So how much is HCl? Now let us calculate for 100 grams. So basically we've written calcium carbonate plus 2HCl. This is what is a stoichiometric equation. Now we need to calculate for 100 grams for this particular reaction. Why are we taking this? So basically they've given like two quantities, isn't it? 100 grams or like according to the equation. First of all, we relate the 100 grams to this molecular mass. 100 grams of this is how much? 2 into 36.5 grams. That is coming to 73.5 grams. 73 grams. Okay, 73 grams rather. Yes. So now, according to balanced reaction, now let's see. What are we getting? 73 grams of HCl. How much it reacts with 100 grams of, because gram I'm relating. Reacts with 100 grams of calcium carbonate. Okay, now relate 1 gram of HCl. Okay, this is what HCl, this is also HCl, right? 1 gram of HCl, it reacts with how much? Reacts with how much, like how much of carbon, this one, so multiply 1 into 100 divided by 73. 1 into 100 divided by 73 grams, it comes to some certain value. But now this is for 1 gram. Now what did they say in the question? They said we have got 0.6844. like why did I get this? Because so much of HCl weight will complete. This is 1 gram of HCl. What did I get in the earlier question? I've got 0.6844 grams of HCl. Will completely react with how much? Means 100 into 0.6844 divided by 73. This comes to 0.9375 grams. That's it. So simple, isn't it? Both the steps I've explained in this step also here like this. First of all, I've calculated for HCl, then I calculated for, I've taken the stoichiometric reaction, then I compared 100 grams. Basically I compared 73 grams, the original mass of this, right? So 1 mole, that is 36.5. Now 2 moles, isn't it? So 73 grams. So 73 grams reacts with 100 grams, means 1 gram reacts with how much? Now again, according to this stoichiometric equation, we have got 0.6849. So no, the thing. So I went back and said 0.6844 grams of HCl reacts with how much? Finally I got the 0.9375 grams. This is how we are going to do the question. So let's come back and do one more question on masses. Yes, let's come back and do the next question. Here what do they give us? Chlorine is prepared in the lab by treating MnO2 with aqueous HCl according to the reaction. This is again your NCERT question. Fine. So they've given us a stoichiometric reaction, and there's a balanced reaction is given to you. So first of all, what should I calculate? How many grams of HCl? How many grams of HCl reacts with 5 grams of MnO2? That is what is the concept. So how many grams of HCl when they give like that? Start first, write to the basic thing. What do? You need to copy the stoichiometric reaction. HCl aqueous plus MnO2 solid gives me 2H2O liquid plus MnCl2 aqueous. Okay, now start. Here, if it is 4 HCl, that means what? 4 into 36.5 grams of HCl. MnO2, what is the molecular weight? It is 87 grams. Correct? Now, according to the balanced equation, what is this? I need to find how many grams of HCl reacts with 5 grams. But basic thing is this. So, let's start. 87 grams of MnO2. It reacts with how much? It reacts with 4 into 36.5 grams of HCl. This is the basic thing. Now what do they give me? They've given me 5 grams, isn't it? 5. So put gram and gram below. 5 grams of MnO2 will react with how much? So 5 into 4 into 36.5 divided by 87 grams. So how much this comes to? This comes to 8.39 grams of HCl. 8.39 grams of HCl. That's it. What did I do? First I've written the basic thing. Then I've compared with the given information there, and then I calculate the amount of HCl. So 5 grams of MnO2. How many grams of HCl they say? So 8.39 grams. So 87 grams reacts with so much. 5 grams reacts with so much of HCl. 8.39 grams of HCl. That's it. So let's come back and do the next question, which is there in molecular mass. Yes, let's read. Here, what do they give us? A mixture of aluminium and zinc weighing 1.67 grams was completely dissolved in acid and evolved 1.69 liters of hydrogen at STP conditions. Okay, standard conditions of temperature and pressure. What is the mass of aluminium in the original mixture? Okay, what is the mass of aluminium in the original mixture, they've asked. So here, first of all, when such question is given to you, again I said try to write the stoichiometric reaction first. That will give you the whole concept. Fine. So what did they say? Aluminium is completely dissolved in acid. So aluminium reacts with HCl to form aluminium chloride plus hydrogen. Now let us see. Here chlorine is 3. So this is 3. Here hydrogen is 3. So to cancel that, we multiply with 3 by 2 fractional weight. So 2 and 2 gets cancelled and we are left with 3 hydrogens. Now aluminium is balanced 1 and 1. Right. So here, let us start solving numerical now. Aluminium, what is the weight of aluminium? It is 27 grams. Fine. So here, how much is that? Because I need to find what is the mass of aluminium in the original mixture, isn't it? That's why I'm considering aluminium here. So here, what is this? This is 3 by 2 into 22.4 liters STP at STP conditions. So let us write the reaction with zinc now. So when you write the reaction with zinc plus HCl, so what does it give you? It gives you zinc chloride in the reaction, ZnCl2. Along with that, hydrogen gas is again evolved in this. Now balance the reaction. Here zinc is 1, zinc here also is 1. Hydrogen is 2, so hydrogen here will be 2. So this is stoichiometric equation. Now what is the mass of zinc? Zinc is nothing but 65 grams of zinc. Fine. So what is the mass? Now what is this? The volume of this? This is nothing. It's balanced already. So this is 22.4 liters at STP conditions. So both the things are there, isn't it? Now both the cases we have found. Now let us assume the mass of aluminium as X. So now I'm assuming, because I need to find for aluminium, let us assume mass of aluminium as X grams. Fine. So now how much is this? Now we have got the basic thing. What did we say? We have so let us go back and say we have said 27 grams for 1 mole. This is again 65 grams, 1 mole. So much was hydrogen. I'm comparing between grams and grams. Means this grams in volume. So mass and volume. Here also this. Now what happened? They've given me what is the mass of aluminium in the original mixture. So now I've assumed aluminium mass as X grams. Right? So let us solve. X grams of aluminium produce how much of hydrogen? Already we have got, that is equal to 3 into 22.4x divided by 2 into 27. Right. So if I take this out like and solve, this becomes 1.67x grams of zinc. I'm going with the zinc now. So zinc produces hydrogen how much? The same thing. This is for aluminium, this is for zinc. Right? Of zinc produces hydrogen how much? This is equal to 22.4 into 1.67 minus x divided by 65. Right? Fine. So now let's add everything. So now 3 into these two together makes the stoichiometric original reaction, isn't it? You need to add both. So 3 into 22.4 x by 2 into 27 plus 22.4 into 1.67 minus 6. I need to find that x value, isn't it? 65. So when I solve that x value, I get equal to 1.2385 grams. That's it. This is how I've got. Fine. So hope this is clear. What did I do? Let us go back and again revise once again. First of all, I've written the stoichiometric equation, right? So this side aluminium is reacting, aluminium and zinc are weighing. So the aluminium and zinc with HCl, I've written the stoichiometric equation. They've given volume, so here also I've compared 3 by 2 because according to the fractional balancing, 2 and 2 gets cancelled, I get the volume. Here also in this case 65 grams and I get. Now after this, what am I trying to do? I have assumed aluminium weight is X. Then I started comparing X grams of aluminium produces how much hydrogen, like that, because I need to find X. Both the cases, in case of aluminium also have taken, and in case of zinc also have taken. Now I've added both and I started solving X value. When I started solving X value, I got 1.2385 grams. So this is how we are going to do. Now let's come back and do the mass percentage numericals. Hope the limiting reagent numericals are clear. Hope the molecular mass numericals are clear. Now last but not least, after mass percentage, we'll be doing your mole concept numericals. Yes.